Hi dear students, here we have a session for the most important 100 MCQ discussion for the chapter Haloarene. You know, this is the first organic chapter from your grade 12, one of the easiest chapter. For your board examination, 6 marks we get easily score from this all concept. So we can discuss through all concepts and 100 MCQs we are going to discuss here. So stay tuned and we are going for the first question. That's from 2024 board question. Question: which alkyl halide from the given option will undergo SN1 reaction faster? You may have studied about SN1 and SN2 reaction thoroughly. It's one of the most sure question for your examination. So SN1 reactivity order, you may already studied that is tertiary greater than, secondary greater than, primary. Yes or no? Correct. So SN1 reactivity order for haloalkane we studied as tertiary greater than, secondary greater than, primary, because SN1 mechanism, the main factor is which one? Stability of carbocation is the factor. This is the stability of carbocation. And if they're asking you the SN2 mechanism, what is the answer? Were primary greater than, secondary greater than, tertiary? Because in SN2 mechanism, steric hindrance is the factor, bulkiness is the factor, crowdiness is the factor. You know, in primary haloalkane, steric hindrance is very less, therefore more reaction. But in SN1 mechanism, be careful, stability of carbocation is the factor. Therefore, the order is tertiary greater than, secondary greater than, primary. Don't forget. Which alkyl halide from the given option will undergo SN1 reaction faster? So, you can able to see that option A is given as CH3 thrice C. What is that? CH3 thrice. CH3 thrice CBr. See all of you, is it a tertiary or not? Yes, the halogen connected carbon connected to 3 carbon. So this is a tertiary carbocation. Yes, it can undergo the reaction faster. But tertiary is not enough. Okay. So we studied that tertiary, secondary, primary is the order of their SN1 mechanism. But that's not enough for answering some other question. Here it's okay because all are given as primary, secondary type, no problem. But all question SN1 mechanism, this order is not applicable. Means this order is not enough. More than primary, secondary, tertiary, some other groups also present. We can discuss in other question. Don't worry. So here, this is a tertiary one. And what about B? CH3 twice, CH3 twice, CH3. This is the one, right? You know, this is called isopropyl bromide. You know that this is a secondary carbocation because the carbocation connected to 2 carbon. This is secondary. And what about this? This is very clear primary, right? Halogen connected carbon connected to only 1 carbon. This is primary. Here halogen connected carbon connected to 1 carbon, primary. So no problem. Yes, option A is the correct answer because that is the one tertiary. So basically, when you get a question from SN1 mechanism, first you classify them as which one? Primary, secondary, tertiary, correct? So if it is tertiary, that will be the one undergo SN1 reaction faster. This is the 2024 board question. So very carefully watch it and whether they are asking increasing order, decreasing order, which one undergo faster, which one undergo very least, those questions be careful. Let's go for question number 2. What is the correct order of reactivity of haloalkane toward beta elimination? You know what is beta elimination? Dehydrohalogenation. Yes or no? Beta elimination is also called what? Dehydrohalogenation. You know that if you consider they are asking about tertiary, secondary, right? Let me take a tertiary haloalkane. Okay, let me take a tertiary haloalkane for example, this one. And let me take a primary haloalkane about this one. Okay. See, in this tertiary haloalkane, what is the first step in beta elimination, dear all? You know, the halogen that will leave, it will form a carbocation. Halogen leave, form a carbocation. You know what type carbocation is this? This carbocation connected to 3 carbon, therefore it is tertiary. This carbocation connected to only 1 carbon, therefore it is primary. So basically, beta elimination or dehydrohalogenation follows what? SN1 type mechanism. That means where stability of carbocation is the factor. So if they're asking you the beta elimination, you go with the SN1 mechanism type. There is tertiary greater than, secondary greater than, primary. Yes, tertiary greater than, secondary greater than primary, because there is a formation of carbocation. So beta elimination or dehydration, if these kind of elimination reactions, if they mention, basically it follows the stability of carbocation, that is tertiary, secondary, primary. Okay, don't forget option B is the answer. Okay, I think the second question is clear, my dear student. Yes or no? Yes. Next question. Monohalo. What do you mean by monohalo? The compound contain only one halogen. Dihalo, they contain two halogen. Trihalo, three halogen. Tetrahalo, four halogen. Are types of haloalkane? Yes, haloarenes based on the. According to what they classified, we studied many type of classifications of haloalkane. What are they? Based on the number of haloalkane, based on the number of halogen atom, we can classify them as monohalo, dihalo, trihalo, tetrahalo. Based on the hybridization, we studied vinyl, allyl, benzyl, different kind of groups, right? And based on the carbon connection, we studied that what are primary, secondary and tertiary, correct? So this is monohalo, dihalo, trihalo. That is based on what? The number of halogen atom present. Clear all of you? Option B is the correct answer here. Let's go for question number 4. Which of the following compound contain? Which of the following compound contain an allylic carbon? First of all, what is meant by allylic? What is meant by allylic? You know, this is halo. This is halogen is present. So what is meant by allylic group? Mean halogen connected carbon is sp3, then it's connected to sp2, again it's connected to sp2. That is called allylic group. You studied, right? Halogen connected carbon sp3, that is connected to sp2, again it's connected to sp2, then it is a allylic group. And what is meant by vinylic also you studied, my dear. What is vinylic mean? Halogen connected carbon is sp2, again it's connected to sp2, then it is called a vinylic. And what about benzylic? What about benzylic? You know, benzylic mean this one. Benzylic mean this one. Means halogen connected carbon is sp3, then it is connected to a benzene ring. Halogen connected to sp3, then it is connected to a benzene ring. That you call it as what? Benzylic. Yes. So this is allylic, vinylic and benzylic. Those three components, that three special compound, please focus it. That definitely you can expect a question based on this one. So here they are asking which is allylic. Okay, let us check it, my dear. Allylic carbon. See the halogen, this connected carbon. What is this carbon? You know, single bonded carbons are sp3, right? And what about this carbon? This is sp2 because double bond is also sp2. Check it. Yes, you can able to see the track. It's a halogen connected carbon is sp3, then it is connected to sp2, again it's connected to sp2. You can able to see that path here. Yes, this is the allylic one. So A is the correct answer. What about B? B, that halogen connected carbon is sp3. Nothing else. This is just a purely haloalkane. Halogen connected carbon is sp3 only, then it is called what? That is a haloalkane. And what about this? Here halogen connected carbon is sp2, again it's connected to sp2. See, halogen with sp2. This is what? This C is vinylic. This is vinylic. What about this? Halogen connected carbon is sp2 and it's a benzene ring. Halogen with sp3, then a benzene ring, that is called benzylic. If halogen directly present on benzene, what? If halogen directly present on benzene ring, then what we call it as aryl, right? Then what we call aryl halide or aromatic halide. Okay. So halogen if directly on benzene ring, what we call aryl. Okay. So this is allyl, this is haloalkane, this is vinylic, this is what? Aryl or aromatic. So what is our answer? Option A. Next question. Which of the following categories does the compound shown belong? Can you say, my dear? Just to be discussed now. Here you can able to see this is the halogen. The halogen connected carbon is sp3 carbon. It's not a benzene ring. It's purely alkane. So it is normally a haloalkane. It is purely a haloalkane. Halogen with a sp3 carbon, what we call? Haloalkane. There is no benzene ring, right? Okay. And they're asking you whether it is primary, secondary or tertiary. Can you say what is that? Here the halogen connected carbon. How to identify primary, secondary, tertiary? Halogen connected carbon, if it connected to only one carbon, primary. If it connected to 2 carbon, secondary. If it connected to 3 carbon, tertiary. See here, halogen connected carbon is this one. It is directly connected to 2 carbon, therefore it is secondary. My dear, is it clear or not? Okay, here the halogen connected carbon is this one. It is directly connected to 2 carbon, therefore it is secondary. That's it. So classification of haloalkane, please study carefully. Next one. Which of the following is a vinylic halide? Again, previous year question. Which of the following is a vinylic halide? Let us check it all. First question. See the, where is the halogen present here? See the halogen connected carbon is a single bonded carbon. So this is sp3. And nearby carbon is what? sp2. Not enough. What is vinylic mean? Halogen connected to sp2. Again it's connected to sp2. So 2 sp2 carbon is required. Here sp3 is there. Leave it. Not our answer. And here you can able to see there is no double bond, my dear. There is no double bond. There is no sp2 carbon. All are single bond. All are sp3. Yes, you know, if a carbon is single bonded, it is sp3. If a carbon having a double bond, sp2. If a carbon having triple bond, sp. Yes or no? So here you see, oh, no double bonded carbon. Leave it. What about this case? Halogen connected. This is CH2. That is what? sp3. Okay, leave it. Halogen should connected to sp2. Again, it should connected to sp2. Check the last one. Let me write the last one. CH3CH, double bond C. On one Cl is there. One CH2, one CH3 is there. Check it all. Halogen connected carbon, sp2. Because it's double bonded carbon. Nearby carbon also. sp2. Yes, here the halogen connected to sp2. This is what we call vinyl. Okay, so answer is which one? Option D. Hope you all clear about it. Okay, next. Again, the SN1 reaction in alkyl halide results in. We studied in SN1 mechanism. SN1 mechanism carried in 2 steps. Yes or no? What is happening in first step? First step, the halogen remove will form a carbocation. What is second step? Nucleophile is attacking. Nucleophile can attack through 2 sides, in front or back side to the carbocation. Yes or no? And we studied that in SN1 mechanism, there is a retention of configuration. Yes, correct. In SN1 mechanism, there is a retention of configuration. But here, in second step, we studied that. This is our carbocation, and where the nucleophile can attack? Nucleophile can attack through in front side or back side. Yes, nucleophile can attack through in front or back side. So basically the point is this one. In SN1 mechanism, nucleophile can attack through 2 sides. Therefore, there is a chance to form what? Racemization or racemic mixture. You know what is meant by racemic mixture? Racemic mixture is the mixture which contain 50% dextro and 50% levo. Yes or no? 50% dextro, 50% levo. So how this SN1 mechanism giving a racemic mixture? That is a question for your exam. So in SN1 mechanism, the nucleophile can attack through 2 sides, in front or back side to the carbocation. So one side attack give dextro, mean other side attack can give levo. So there is a commonly 50-50 chance to get dextro and levo in SN1 mechanism. So it will give what? Racemization. So if there is an answer retention and racemization, the most correct answer is which one? Racemization. Because SN1 mechanism racemization can form, SN2 mechanism racemic mixture can't form. Why? Because in SN2 mechanism we studied nucleophile can attack through only one side. The back side, the opposites of halogens, only the nucleophile attack. It won't give 50-50 chance. Okay. So SN1 mechanism can give racemization or racemic mixture. Please note it all. Option 2 is the correct answer. Now, among the following, which alkyl halide have the strongest carbon halogen bond? You can able to see that CH3Br. Okay, it's already given here. Let me take from this one. You know, CH3Br, CH3Cl, CH3I, CH3F. Where you can able to see the strongest carbon halogen bond? Of course, option 4. Because you know, carbon, fluorine, you know, the halogen family, chlorine, bromine, iodine, right? This is the one. You know that fluorine is the smallest element and highly electronegative element, then chlorine, then bromine, then iodine. You know, down the group, the size of the halogen increases. So what happened? The bond is weaker. And this one is what? Stronger. Okay. You know that top to bottom, the reactivity of the halogen increases because fluorine is most electronegative element. It holds the carbon very tightly. The bond is very strong. Down the group, the size of the halogen increases. Size of the halogen increases mean the bond get weaker. If the bond is weaker, easy to break, easy to undergo reaction. So which is the one more reactive mean? We can say the iodine because the bond is weak. And why CF is least reactive mean? Because the bond is strong due to the high electronegativity of fluorine. So answer is which one? Fourth one. Now, phosgene, you may hear this name very well. Phosgene is a common name for a gaseous chemical called. What is phosgene you studied, my dear? You know chloroform, CHCl3. Chloroform, when it is exposed to oxygen, it reacts with light and oxygen form a poisonous gas called what? COCl2 along with HCl. What is COCl2 is called? Phosgene, the poisonous gas. COCl2 we can write like this one. COCl2, this is called carbonyl group. Carbonyl chloride. That is another name of which one? Phosgene. Phosgene, what is that? Phosgene is a poisonous gas which is formed by when chloroform. You may study chloroform, why it is kept in a dark and wax lined bottle. Because chloroform is highly reactive towards heat and light, and it form, especially oxygen and light, and it form a poisonous gas called which one? Phosgene. What is the another formula or another name of phosgene? That is a question. Carbonyl chloride is the correct answer. Yes, carbonyl chloride. This is what we call carbonyl group. Okay, next. Dash possess the highest melting point among the given set of common. And we studied the melting point order. Melting point order like this one. POM. Melting point order is what? POM. P-O-M. Para, ortho, meta. Why para having highest melting point? We studied in classes that para having high symmetry. You know this ortho dichlorobenzene, para dichloro, meta dichloro. You know that, my dear. This is para dichlorobenzene. Yes or no? See, para dichlorobenzene having a proper symmetry, perfect symmetry. See, the elements all are located in the perfect symmetric axis. So because of the para dichlorobenzene high symmetry, they can fix in the crystal lattice tightly. They can fix, there are some spaces in the crystal where the species can occupy. Because of the proper symmetry of the para dichlorobenzene, they can fit in the crystal lattice tightly. They have high melting point. So among ortho, meta, para dichlorobenzene, the order of their melting point is what? POM. POM, para having highest melting point because of one reason, because of high symmetry, they can fit in the crystal lattice tightly. So answer is which one? Option 2, para dichlorobenzene, which possesses the highest. Yes, para. Now, which among the given substances possess the maximum dipole moment? Yes, dipole moment questions we discussed in class. They given these three species. Let me discuss the complete idea. Let me take the species CH3F, CH3Cl, CH3Br, CH3I. Let me take this species. These all are tetrahedral geometry. We will draw like this one, CH3F. Then this is what? CH3Cl. Then we have CH3Br. Then we have CH3I. These are the species we have. When we drawing the dipole moment arrow, dipole moment diagram, we know how to draw that one. Towards the most electronegative element, electron shift. You know, carbon and fluorine, when you consider fluorine is the most electronegative element. So towards fluorine, the electron shift. Carbon and hydrogen, when you consider carbon is more electronegative. So this is the dipole moment diagram. All the dipole moments are adding up. Thus having high dipole moment. Even in the same case, chlorine is more electronegative and here carbon is more electronegative. Bromine is more electronegative and here carbon is more electronegative. Here also iodine like this. So here, basically most of them dipole moment are in upward direction. Or no, there is not much cancellation, right? So all of them having highest dipole moment. Among these four, which one having highest? That I can say this one. Because fluorine is most electronegative element. It pull the electron more. Yes or no? Fluorine is most electronegative element. So it make the dipole moment more. Okay. Dipole moment more. So here we are going to discuss the point is, among this one, we are expecting, dear all, please mark it, this is an exceptional case, okay? This is an exceptional case. We are expecting fluorine is the one having most dipole moment, but no. Dear all, if this compound, if they given for dipole moment question, please exchange chlorine and fluorine. This is the one most. So the answer is CH3Cl and CH3F. Then we have CH3Br. Then we have CH3I. This is the order of the dipole moment. CH3Cl having highest maximum dipole moment. And what is the reason? You know that dipole moment is equal to Q into R. What is dipole moment? Dipole moment is equal to charge into distance of separation. We said that fluorine having greater dipole moment. We expected fluorine having greater dipole moment. Why? Because fluorine having greater charge, because high electronegative element. But this R value is greater for CCl. Because chlorine is little bigger in size, and all electron when come closer, there will be high electron-electron repulsion. In order to minimize the repulsion, CCl bond get elongate. So this here the distance R value is bigger. Where R value is bigger, where the dipole moment. So overall the product and charge into the distance of separation when calculating, CCl having greatest dipole moment. What is the reason we said? CCl having greater electron-electron repulsion, so bond get elongate. The R value increases, so therefore dipole moment increases. So these three compound, when they asking you please exchange chlorine and fluorine. Chlorine come first. Clear all? Next one. A chemical substance called ethylene dichloride. Ethylene dichloride. That term or the compound, please mark it all. Ethylene dichloride is prepared by the addition of hydrochloric acid 2. What is ethylene dichloride? Let me tell you, the compound is this one. This is what ethylene dichloride. Ethylene. This is called ethylene dichloride, or you can say 1,2-dichloroethane. Dear all, it is a vicinal dihalide. It is a vicinal dihalide. Vicinal dihalide. Okay. Because the halogens are present on the adjacent carbon. Vicinal. So vicinal dihalide, ethylene dichloride is nothing but this is the compound. From where you can prepare, from these four compound, how you can prepare when we treated with hydrochloric acid? Methane, ethylene, propane, when you choose, dear all, you won't get it. You can just check with the ethylene glycol. What is glycol? You know what is ethylene glycol, my dear? This is what we call ethylene glycol. Glycol mean if two OH group are present on adjacent carbon, they are called a glycol. Okay. If two OH group are present on adjacent carbon, they are called a glycol. This ethylene glycol, when we treated with what? Hydrochloric acid. You know what happened? This OH goes, Cl comes. You can add to HCl, so you can remove both of the OH. You can get CH2Cl, CH2Cl. So mark it all. Ethylene dichloride mean it's a vicinal dihalide. It can prepare from ethylene glycol. What is meant by glycol? If two OH group are present on adjacent carbon, they are called what? Ethylene glycol. So answer 4 is the correct answer. Now, dash is a secondary halide. Which of the following is it? Which is a secondary halide? What do you mean by secondary halide? Halogen connected carbon. If it connected to 2 carbon, it's called secondary. That's it. You can identify first of all. Isobutyl chloride. But as a student, you should know what is its common names. What is isobutyl? Isobutyl is this one. You know, this is isopropyl, and with one more carbon is called isobutyl chloride. This is called isobutyl. Check it, is it primary or secondary? Here the halogen connected carbon connected to only one carbon. This is primary. So not our answer. Second one, isopropyl. What is isopropyl? CH3. Dear all, this is isopropyl chloride. Here the halogen connected carbon is this one. It is connected to 2 carbon. Yes, this is our answer, secondary. Okay, and what about N-propyl? N-propyl, you know, CH3, CH2, CH2, Cl, right? Normal propyl, this is what? Halogen connected carbon connected to one carbon. That's primary. Option 2 is the correct answer. So please study all. This is called isobutyl. This is called isopropyl. Okay, fine. Next one. Select the primary halide among the following compounds. Select the primary halide. What do you mean by primary? Halogen connected carbon, if it connected to one carbon, it's called primary. Let me draw the first one. Neohexyl. What is neohexyl? You studied this compound. These names you studied in 11th grade, right? What is this group, my dear? What is this branch we call? Tert-butyl, tertiary butyl. On which one carbon comes extra, that's called neopentyl. Neo, total 5 carbon, right? Neopentyl. With one more carbon is called neohexyl. So this is neohexyl chloride. Check it, is it primary or not? Yes. The halogen connected carbon, it's connected to only one carbon. This is our primary. Answer is first one. What is tert-butyl? Tert-butyl, you know, one carbon connected to 3-methyl. One carbon connected to 3-methyl, then with a bromide, tert-butyl bromide. This is tert-butyl bromide. What about this? Here the halogen connected carbon connected to 3 carbon. This is tertiary. And secondary butyl. What is secondary butyl group? Note it all. This is what secondary butyl. Please note it all. This is we call secondary butyl with what? Iodide. Secondary butyl iodide. This is secondary butyl. See here the halogen connected carbon connected to 2 carbon. It is secondary. So which is primary among these 4? Neohexyl chloride is the primary. Clear all? Next one. A chemical compound carrying a molecular formula of C3H7Cl can have dash possibility of structural isomer. How many structural isomers are possible with this formula? C3H7Cl. What do you mean by structural isomer? Compounds having same molecular formula, different structure. Let's see C3, total 3 carbon, right? Let me place it CH2, CH2, Cl. This is one structure possible with this formula. This is 1-chloropropane. Let me place this chlorine in the center. You will get another compound. What we call it as this compound, my dear? This is called 2-chloropropane. So this is 1-chloropropane, okay? This is 1-chloropropane. This is 2-chloropropane. Any other structure is possible with this formula? No, you can check it. There is only 2 isomers are possible with this formula. So answer is 2. Select the correct arrangement of alkyl halide in their decreasing order of their boiling point. Dear all, boiling point, the main factor is molecular mass. Main factor is what? Molecular mass. Greater the molecular mass, greater the boiling point. Please note it all. Molecular mass is directly proportional to boiling point. You check it. You have the compounds alkyl fluoride, alkyl chloride, alkyl bromide, alkyl iodide. Which one having greatest mass? You know, fluorine, chlorine, bromine, iodine. Down the group, atomic size increases, atomic mass increases. So iodine is the one having greatest boiling point. So down the group, in haloalkane, boiling point increases. So where is the answer? Ri, Rbr, Rcl, Rf. What is the main factor about boiling point? The main factor is which one? Molecular mass. Now, you can able to see one species here. What is the IUPAC name of this compound? What is the compound? Let me just expand. CH3, tri-C. That means on one carbon there are 3 CH3, right? This is the compound with 1 Cl. CH3 thrice CCl is the compound. What is its IUPAC name? Dear all, select the longest chain first of all. You know, you can able to select 1, 2, 3 or you can select 1, 2, 3, both are fine. Here you can able to see second position chlorine is there, second position methyl is there. So what is the name? 2-chloro, alphabet okay, 2-chloro, 2-methyl, total 3 carbon is there, what we call propane. 2-chloro, 2-methyl propane. Yes, option 3, 2-chloro, 2-methyl propane. Someone you may think that, sir, why it is not tert-butyl? Yes, my dear, this is tert-butyl. This is tert-butyl chloride, then why it is not option A? That is common name. That is common name. The isopropyl, sec-butyl, tert-butyl, neopentyl, these names normally we are using in that which one? Common name. Don't use it in IUPAC name. IUPAC name with the numbers 2-chloro, 2-methyl propane. Clear? Next one. Which of the following statements about SN2 mechanism is incorrect? SN2 mechanism is incorrect. Okay, let's see. First one. The transition state is stable. That is the incorrect statement, and that's our answer. Why? You know what is the first step in our, let me take a haloalkane here. This is a haloalkane. You know what is happening in first step of SN2 mechanism? Nucleophile attack through the opposite of this. If it is all bulky group, you know, reaction will be very lesser. So let me take one hydrogen cell, small groups. Then only, you know, main factor in SN2 is what? Steric hindrance. Yes or no? So here, this is a haloalkane. And the nucleophile, you know, it is attacked always through the opposite of halogen. Opposite of halogen. And after that, you will get a transition state. What is a transition state? In which you will write this RHH is there, this one. And nucleophile is making a bond with this carbon. I can write like this one. What is this? Nucleophile is going to form a bond with the carbon. If nucleophile form a bond, the halogen try to leave. So this bond is going to break. So here nucleophile is going to form a bond. At the same time, carbon halogen bond is going to break. This highly unstable state. This is the highly unstable state because the bonds are not completely formed, completely broken. Such a state what we call transition state. Transition state are generally highly unstable. It immediately become the product. Okay, so that is the incorrect statement. What about B? Complete mechanism takes place in a single step. Yes, you know, SN1 mechanism carry 2 steps, SN2 mechanism only 1 step. Rate of the reaction depend on both reactant. Yes, here you have 2 reactant. One is your haloalkane, one is the nucleophile. So rate depends on 2 species. Therefore, it is called SN2 mechanism. And there is an inversion of configuration. Yes, you know, SN1 mechanism retention, SN2 mechanism inversion. Correct. Next question. A monohaloarene is an example of monohaloarene. Can you give one species for that one? Monohalo mean 1 halogen. And it should be a haloarene. That means halogen should be on benzene ring. For example, chlorobenzene. Chlorobenzene is a monohaloarene. If you take it 1 chlorine here, this is a dihaloarene. Correct. So here, only 1 halogen and it should be on benzene ring. Correct. This is an example of what? Which one? Is it an aliphatic halogen? No, it's an aromatic. Side chain substituted, not side chain. The halogen is directly on the benzene. It is not alkyl halide because halogen is connected to sp2 carbon, not sp3. It is an aromatic halogen compound. Yes, D, right? So, halogen when it is present on benzene ring, what we call it as haloarene. It's a aromatic halogen compound. Simple question. What is 3-bromopropene's common name? Some simple question, but what is very expected, okay? 3-bromopropene. Careful, dear all. What is propene? What is propene? There is a double bond. 3-bromo. You know, this is 1, 2, 3. Third position bromine. So, this is the compound we have actually. Dear, this is the compound 2-bromopropene. Whether it belongs to allylic, vinylic or tertibutyl. You can't able to see any tertibutyl group and all, leave it. And what about this? Here the halogen connected carbon is sp3. Then it's connected to sp2. Again it's connected to sp2. Do you remember this pattern anywhere? Halogen connected to sp3, then sp2, again sp2. Where we study this point, all of you? That is the allylic group. So this is a allyl bromide. This what? Allyl group. Okay, allyl group. What about vinyl? sp2, sp2. Okay, don't forget. Now, which of the following is the right name of the compound? This one. What is the compound given? CH3, CHCl2. You can able to see that this is not vicinal dihalide, right? Here the halogens are on same carbon. So what it is? It is a geminal dihalide. It is a geminal dihalide, my dear. It is a geminal dihalide. Okay. Now, what is the name of this compound? Is it 1,2-dichloro? No. This is 1,1-dichloro. Both of the halogens are on the same carbon. And ethylene dichloride or ethylidene chloride. Ethylene dichloride we discussed in a previous question. This is what ethylene. This is what ethylene dichloride. This is vicinal, right? And what is ethylidene? Dear all, that is the compound if the two carbon in which halogens are on same carbon is called what? Ethylidene. If halogens are on present on adjacent carbon, it's called ethylene. Okay, so this is the one correct answer, option C. So please note it carefully, dear all. What is ethylene dichloride and ethylidene dichloride? Okay, ethylene dichloride means the halogens are on two carbon which is adjacent. Ethylidene means two halogens are on same carbon, it is geminal. Option C is the correct answer. What is the catalyst in the chloroalkane react of a primary alcohol with a HCl? You studied a primary alcohol, for example, ROH. A alcohol when react with HCl, you will get RCl along with the H2O. Yes or no? RCl along with the H2O. This is happen in which catalyst? That is Lucas reagent. What is the catalyst, my dear? Anhydrous zinc chloride. HCl and concentrated HCl and anhydrous zinc chloride, what we call Lucas reagent. Lucas reagent. What is the function of Lucas reagent? To convert alcohol to haloalkane. So, in order to convert alcohol to haloalkane, the catalyst which is used along with the HCl, that is anhydrous zinc chloride. Option C is the correct answer. Clear all? When ethanol combined with the PCl5, what is ethanol? CH3, CH2, OH. Ethanol when combined with the PCl5, let's see. We studied the reaction. When alcohol react with the PCl5, we get the haloalkane first, that is CH3, CH2, Cl. Yes, we'll get CH3, CH2, Cl along with the two byproduct. Do you remember the byproduct? We will get POCl3 along with HCl. What is POCl3 is called? POCl3 is called phosphoryl chloride. Phosphoryl chloride, or you can say phosphorus oxychloride. Okay, so what is the answer? When ethanol react with the PCl5, it produces three products. Yes, one haloalkane, one POCl3, one HCl. They already said chloroethane. This is our chloroethane. Hydrochloric acid. Yes, hydrochloric acid. And what is the remaining? What is that? POCl3, that is phosphoryl chloride is the compound POCl3. So don't forget about to study the byproducts also. Now, which of the following substances has the highest melting point? Highest melting point. Basically, melting point and boiling point related to their mass. See, chloromethane. What is chloromethane? CH3Cl. What is tetrachloromethane? CCl4. What is trichloromethane? CHCl3. See, trichloromethane. And dichloromethane is which one? CH2Cl2. Which one having greatest melting point? Can you say where is the greatest the mass you have? Greatest mass, I think you can able to see CCl4, right? CCl4. And CCl4 is having a zero dipole moment also. It's tetrahedral geometry, all dipole moment cancel each other. So CCl4 having the greatest mass. When you check it, other species, it's having 2, 3 chlorine, 1 chlorine, 2 chlorine, it's having 4 chlorine. So greater the mass, basically having greater the boiling point and melting point. So tetrachloromethane. An order of isomeric dichlorobenzene as per dipole moment is. See, dipole moment cases, they said dichlorobenzene, right? Okay, let me take the compound. This is ortho, this is ortho dichlorobenzene. What about meta? Meta means you have to place one chlorine here, right? This is meta dichlorobenzene. And if you place one up and one down, this is what? Para dichlorobenzene. You know how to write the dipole moment. See, chlorine is more electronegative here. So chlorine is more electronegative. So they are pulling in this way. So resultant is this one. Yes, it's having high dipole moment. Whereas this chlorine up, this chlorine slightly down, there is some cancellation. Here one chlorine up, one chlorine down. Here dipole moment is exactly 0. So which one having greatest dipole moment? Ortho, meta and para. Dipole moment we can able to understand by drawing there the dipole moment arrow. So we can able to say which one? Ortho, meta, para. The order of the isomeric dichlorobenzene as per the dipole moment is ortho, meta, para, OMP is the correct answer. Hope it's clear. 26th question. In Friedel-Crafts synthesis, you studied what is Friedel-Crafts alkylation and acylation. In Friedel-Crafts synthesis of toluene, reactants in addition to anhydrous AlCl3 are. What is Friedel-Crafts reaction you studied? We know benzene, right? Benzene when treated with CH3Cl in presence of anhydrous AlCl3. We get this CH3 on benzene ring, we get what? Toluene. So they are asking, in order to get toluene, other than anhydrous AlCl3, what all reagents we are using? What is that? Benzene and chloromethane. What is that? Option B, benzene and chloromethane. Okay, one simple question. Now, which of the following are arranged in the decreasing order of their dipole moment? Decreasing order of their dipole moment. This question already we discussed in part 1 lecture. If they ask you CH3F, CH3Cl, CH3Br, CH3I, if they ask you, I told you that what is the exception in this question? Chlorine and fluorine, please switch it. We'll come CH3Cl come first, then CH3F, then only CH3Br, then we will get CH3I. Clear? So dear all, which one having? CH3Cl having greatest, then CH3F, then CH3Br. What is the reason we studied? In CH3Cl, the carbon-chlorine bond, because of high electron repulsion, that bond get elongate. So overall dipole moment nu is equal to Q into R, where R is greater, therefore dipole moment is greater. So keep in mind about this dipole moment. Question, which of the following is a free radical substitution reaction? What do you mean by free radical substitution? You know, for an alkane, to an alkane, if you add halogen in presence of light or heat is compulsory for a substitution reaction, free radical substitution. You know what is happening in this reaction? One H remove, one Cl get added. You will get CH3Cl. Remember, substitution reactions are happening only in alkane. See the first reaction. Here, this is toluene. When react with the chlorine with the boiling, where this chlorine get added? Yes, to the alkane chain. To the alkane, one hydrogen remove, one chlorine added. Yes, this is the free radical mechanism. Why not this case? You can able to see here, this CH3Cl is the one adding. You know, this CH3 plus come to this. This is our Friedel-Crafts reaction. Friedel-Crafts reactions and all we studied under electrophilic substitution reaction, not our answer. This is silver nitrate, something is treated, leave it HCN, no. So, what do you mean by free radical substitution? There should be an alkane. There should be an alkane to which when you add halogen in presence of heat or light, from the alkane, one hydrogen leave, the halogen substituted. This is it. Okay. And what is the reactivity order of the halohalide toward dehydrogenation? Whatever the reaction, the reactivity order, we already studied that. If you consider RF, RCl, RBr and Ri, you know that which bond is weaker and stronger. Yes, my dear, this is the bond stronger and this bond is the weaker. Weaker the bond, easy to break, easy to undergo the reaction. So down the group of haloalkane, their reactivity increases. So what is the order? Ri, RBr, RCl, RF, we can say. So reactivity order of alkyl halide, if they asking majority cases, iodide is the one more reactive because it is the best leaving group because the bond is weak. Clear? Okay, 30th question. Among the following compound, the decreasing order of their reactivity toward electrophilic substitution. Very good question. See all of you, what is the basic idea? You know, let me consider a compound with the electron donating group. Okay, if there is an electron donating group on benzene ring, they will donate to the donate electron to the benzene ring and make the ortho and para position what? Electron rich, general. When an electron donating group present on benzene ring, it make the ortho and para position electron rich. And what is an electrophile? You know, electrophiles are with a positive charge. They are electron deficient. So where they attack, of course, they go to ortho and para position because their side are electron rich. So if there is electron donating group, more donating group present, more strength electron donating group when present on benzene ring, where more electrophilic substitution can happen. Similarly, electron withdrawing group, if there, this reactivity will be lesser. You see, this is methyl group. You know that methyl group, alkyl groups are electron donating group. So that make the electrophilic substitution faster. This is normal benzene ring. And what is this? Methoxy. You know, methoxy, oxygen contain more lone pair. It's more donating group. It is more electron donating group than methyl. So methyl or methoxy, more donating mean methoxy. Okay. And what about here? You can see fluorine is there. You know, fluorine is an electron withdrawing group. That will decrease the reactivity. So which one increase the reactivity toward electrophilic substitution faster? This is the most donating group. So third one greater, then first one, then second one, least the one with electron withdrawing group. So 3, 1, 2, 4. Yes, option A. Okay, 3, 1, 2, 4 is the, what is the overall factor? If there is an electron donating group present, it will make the electrophilic substitution faster. Why it is so? If there is an electron with donating group present, it will make the ortho and para position more electron rich. Electrophile can easily attack them. Now, which among MEX? What is Me? Methyl group. Okay, Me stands for CH3. CH3 halogen and RCH2. This is, you know, this is methyl halide. This is a primary haloalkane. This is a secondary haloalkane. This is a tertiary haloalkane. Which is more reactive toward SN2? SN2 reactivity order, you know, primary greater than secondary greater than tertiary. Where is less bulky group? Where is less steric hindrance, where more reaction can happen in SN2. So which is that? MEX. This is the most simplest haloalkane among all others. Alkyl group numbers are higher, so that is weaker. So SN2 reactivity, you don't need to bother about any other factor. Where is less bulky group, where more reaction can happen. Then in chlorination of benzene, what is chlorination of benzene? You know, benzene, to which when you add chlorine in presence of anhydrous AlCl3, what we get? We get chlorobenzene. We studied under electrophilic substitution. During this reaction, what is the reactive species? Most of you write Cl minus. No, it is Cl plus. Okay, answer Cl plus is the correct answer. Why so? You know what is this happen? Cl2. Let me write Cl2 like this. And what is anhydrous AlCl3? AlCl3, let me write like this one. See the central aluminium. This aluminium carry 3 bond. You know, 3 bond is equal to 6 electron. Right? This 3 bond equal to 6 electron. 6 electron mean they are electron deficient. So they need one more chlorine or one more bond. So one of the chlorine go to this AlCl3 as Cl minus. So this Cl when get into this one, it become AlCl4 minus. Because this one Cl go as what? Cl minus. So other Cl exists as what? Cl plus. This Cl plus is the electrophile. It is going to the benzene ring. So what is the reactive species here? Cl plus. Now, anti-Markovnikov addition of HBr is not observed in. You know, Markovnikov's rule and anti-Markovnikov's rule, in order to obey or in order to happen, what is the main thing? What is the main thing? You know, the main thing is that alkene should be unsymmetrical. See propene, what is propene? CH3, CH double bond, CH2. It is a unsymmetrical alkene because you see these two carbon having, the double bonded carbon having different number of hydrogen, unsymmetrical. So there is a carbon with a less hydrogen and more hydrogen. Markovnikov, anti-Markovnikov can be applied. And what is 1-butene? 1-butene means CH2 double bond, CH, CH2, CH3. Yes, 1-butene is also unsymmetrical because the double bonded carbon carry different hydrogen. What is butadiene? Yes, dear, this is our answer. This is our butadiene. Do you have any carbon with a less hydrogen and more hydrogen? You know what is anti-Markovnikov's and Markovnikov's rule? Anti-Markovnikov rule, the negative part goes to carbon with less hydrogen. That is Markovnikov's, right? Anti-Markovnikov's is what? Negative part goes to the carbon with more hydrogen and positive part goes to carbon with less hydrogen, and opposite in Markovnikov's rule. So in order to happen that alkene should be, or alkene or alkane should be unsymmetrical. This is what? Symmetrical. So option C, here the anti-Markovnikov's rule is not observed. Clear? Now, among the following, the molecule with the highest dipole moment. highest dipole moment. Let me take the species here. This is different, okay. One dipole moment question exception we studied. This is something normal. CH3Cl. You consider this is CH3Cl and this is what? CHCl2, CHCl2 and another is CHCl3. That is our chloroform and this is our carbon tetrachloride. Okay. Let me draw the dipole moment very faster. Carbon and chlorine, when you consider, chlorine is more electronegative. Carbon and hydrogen, carbon is more electronegative. Here all dipole moments are adding up. It's having very high dipole moment among this one. And what about this one? This chlorine almost cancel. Only these two hydrogen will contribute. And here this chlorine cancel. Only one hydrogen contribute. And here, see all the surrounded atoms are similar. So what happened? You know, the dipole moment is what? Cancel each other. That is equal to 0. So what is the overall dipole moment of these 4 species? You can say this is the correct order. The order is CH3 Cl greater than, CH2Cl2 greater than, CHCl3 greater than, CCl4. This is the correct order. So among the following, which molecule having highest dipole moment? No doubt option A, because all dipole moments are adding up. Okay. Now, CH3 thrice CMGBr. Let me draw the structure. CH3 thrice CMGBr on reaction with the D2O. On reaction with the D2O, what is the product going to form? What is meant by D2O? D2O, you know, it's called as heavy water. Heavy water. You know, deuterium. You know, H2O mean where hydrogen is protium. You know, the isotope of hydrogen. D2O where D represent what? Deuterium. Okay. So in D2O, what is the ions in H2O? Ions in H2O are H plus and OH minus. Yes. Similarly, what are the ions in D2O? D plus and OD minus. That's it. So D2O contain D plus and OD minus. Okay. What are the ions in Grignard reagent? You know, Grignard reagent, magnesium is plus char. The alkyl group is always minus R. What is Grignard reagent? RMgX, where magnesium plus R minus. Okay. So here, what are the product? Very simple. Positive, just a double displacement you can do it here. To the minus 1, the plus will attack. So to the minus part, the D plus will attack. You will get CH3C, CH3, CH3, to which D will attack. Plus, what is here? MGBr is there. MGBr, to the MGBr, MG, who will attack? OD will attack. So where is the product? Can you able to see this product anywhere? CH3 thrice CD. That is option A. CH3 thrice CD. So what is the point overall? Grignard reagent, when it is react with the water, D2O, H2O, whatever, they make this displacement reaction, it form the corresponding alkane. So Grignard reagent, this is the way to make ion. Be careful. Okay, so Mg or charge is always positive, the alkyl group charge is negative, and water or heavy water they given make into their ions and just a double displacement. Now, a solution plus. What is meant by plus, dear? Dextro. You know what is dextro? Plus 2 chloro 2 phenyl ethane in toluene racemizes slowly in the presence of. Racemizes. Okay, you know how this racemic mixture we discussed. In the presence of small amount of SbCl5 due to the formation of, we can say, carbocation. Why? They already said racemizes. Racemization is followed by, or racemization is happen in which mechanism? SN1 mechanism. In SN1 mechanism, what is the main factor? Formation of carbocation. Yes. What is the first step in SN1 mechanism? Halogen leave, formation of carbocation. Second step, nucleophile attack through the carbocation through 2 sides. So SN1 mechanism, that racemizes mean SN1 mechanism, the formed intermediate is which one? Carbocation. That's it. Para-dichlorobenzene has high melting point. Yes, we discussed para-dichlorobenzene having highest melting point due to high symmetry. What is the reason? Here already we discussed this question, but in another way they are asking. What is the answer? B, right? Para-isomer has a symmetrical crystalline structure. Because of the symmetrical arrangement, they can fit in the crystal lattice tightly. Therefore, they have high melting point we discussed before. Fittig reaction can be used to prepare. What is Fittig reaction? You know, my dear, diphenyl is the product. What is Fittig reaction? Let me take chlorobenzene. How many? Actually, we need 2 chlorobenzene. Yes, actually we need 2 chlorobenzene. So chlorobenzene and another chlorobenzene. Let me take 2 chlorobenzene and let me add 2 sodium here. What happened? This sodium take this chlorine away. You know, this is actually happening in presence of what? Dry ether. This phenyl get joined. 2 phenyl ring group get joined. You will get the compound called diphenyl or biphenyl. Option C is the correct answer. So my dear student, be careful. What is the difference between? This is actually sodium and dry ether we are using in our the haloalkane topic, that's called Wood's reaction. So what is basically the difference between Wood's reaction and Fittig reaction? Wood's reaction is used to combine to haloalkane, whereas Fittig reaction is to combine to haloarene. Fittig reaction, the product will be what? Biphenyl or diphenyl. Now, identify the end product in the following sequence. We want to know the final product C. Carefully listen on. C2H5OH. What is C2H5OH? C2H5OH is nothing but ethanol. Ethanol, when treated with SOCl2, what is SOCl2? Thionyl chloride. We get, you know, OH remove, chlorine attack. You will get chloroethane. Yes or no? You know the purpose of SOCl2 very well. And if you treat it with a KCN, you know, KCN will give you cyanide, AgCN give you isocyanide. So we will get CH3, CH2, CN, right? Cyanide. What is last? H2O and H plus, acid hydrolysis. What is this called? Acid hydrolysis. This reaction you may not study in haloalkane chapter, but it is there in our another organic chapter. Now you study like this all. Cyanide on acid hydrolysis. You know, acid is the catalyst, hydrolysis is there, water is there. Cyanide on acid hydrolysis become carboxylic acid. Complete hydrolysis, it become carboxylic acid, COOH. So this is the answer. Where you can able to see that? Option C. So what's the first reaction? OH becomes Cl because SOCl2 function is there. Cl becomes Cn because Cn is there. And Cn becomes COOH on acid hydrolysis. Okay, so answer is option C. Now, here another reaction is given. In the above reaction, what is the end product D? See, first reaction is given CH3, CH2, CH2, Cl. This is treating with the what? Alcoholic KOH. Tell me, dear all, what is the purpose of alcoholic KOH? Beta elimination. What is beta elimination? Halogen removed from alpha carbon, hydrogen removed from beta carbon, make a double bond between alpha beta carbon. This is the product first, right? This on beta elimination, you will get propene. Propene when treated with HBr, you know, H plus Br minus. There is no peroxide, so Markovnikov's rule. Negative part goes to carbon with less hydrogen, positive part to carbon with more hydrogen. You will get 2-bromopropane. Yes, 2-bromopropane. This undergo Wood's reaction. 2-chloropropane when undergo Wood's reaction. What we get? Dear, this is the one. Let me write 2-chloropropane like this, okay? Is it 2-chloropropane? Check it. 2-chloropropane. Sorry, not 2-chloro, right? Bromine is needed, right? Yes, bromine. Okay. 2-bromopropane. You know, Wood's reaction is the combination of two same haloalkane. Let me take one same haloalkane. CH3, CH, Br, CH3. So, two same haloalkane is ready. Let me place 2 sodium. You know, in presence of dry ether, what happened? This Br go with the sodium. This alkyl group join with this alkyl group. And finally, we get CH3, 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 CH3. What is the name? 2,3-dimethyl butane. 2,3-dimethyl butane. Option B is the correct answer. Okay. So Wood's reaction is used to combine to haloalkane. These two haloalkane when joined, this is the alkane going to form. Option B is the correct answer. Next. Identify. So I think it's clear, right? Okay. 2,3-dimethyl butane. Next. Identify the compound Y in the following reaction. This is Y, right? So very simple reaction, you know. What is this, my dear? This is our aniline. Aniline on, what is this? diazotization, yes or no? Diazotization. Aniline on diazotization, we get benzene diazonium chloride. Benzene diazonium chloride, when you treat it with a Cu2Cl2, we get chlorobenzene and nitrogen gas. This is our reaction, Sandmeyer reaction. Cu2Cl2, if you are using, you get chlorobenzene. Cu2Br2, if you are using, you will get bromobenzene. So where is chlorobenzene as an answer? Option A is the correct answer. Okay, direct question. Toluene react with a halogen in the presence of iron 3 chloride. What is toluene? Yes, let me take toluene, benzene with the CH3. Toluene react with a halogen. For example, let me take chlorine. In presence of iron 3 chloride. What is iron 3 chloride? FeCl3, like AlCl3. Giving ortho and para halo compound. Yes, you know, toluene is a ortho para directing group. So we will get two compound, orthochlorotoluene and parachlorotoluene. We'll get orthochlorotoluene and parachlorotoluene. Right. This reaction belongs to, dear all, you know, addition of chlorine in presence of anhydrous AlCl3 or FeCl3. What is this reaction? The electrophilic substitution reaction. Electrophilic substitution reaction. You know, chlorination, nitration, sulfonation, Friedel-Crafts alkylation, Friedel-Crafts acylation. These all are coming under which area? Electrophilic substitution, because among Cl2, Cl plus electrophile is going to ortho and para position. Yes. Which of the following is halogen exchanging reaction? We studied two halogen exchanging reaction in this chapter, Finkelstein reaction and Schwarz reaction. Iodine exchange is Finkelstein, fluorine exchange is Schwarz reaction. Which is a halogen exchanging reaction? Option A, sodium iodide is where we studied Finkelstein reaction. See all of you, the existing halogen is X and here the iodine halogen exchange, we are getting Ri. This is our Finkelstein reaction. Yes or no? Yes or no? Right. This is our halogen exchanging reaction. Which reagent will you use for the following reaction? What is the reaction given here? What is the reaction given here? Butane, right? They given a alkane. They given a pure alkane. And what happened to the product? One chlorine added to the first and second position. Which means here one chlorine added, one more product, here another chlorine added. That means chlorination. To an alkane, if you want to add chlorine, that is only possible with a light or heat. That is our free radical substitution reaction. That for that, what is required? Chlorine in presence of light. So if you want to add a halogen to an alkane, we need halogen in presence of light or heat. That is our Friedel-Crafts substitution reaction, my dear. And arrange the following compound in the increasing order of their density. You know, density is equal to mass by volume. So density related to mass. Which one having greatest mass? That having greatest density. So this is benzene, here one chlorine, here two chlorine, here bromine and chlorine. Which one having greatest density? Option D, right? Because bromine and chlorine means what? They're having highest masses. And with this two chlorine, then this, then without this. So we can say arrange the following, right? We can say arrange the following compound in the increasing order. So D is the highest because bromine and chlorine. Then we have C because two chlorine. Then we have B and least to one A. Correct? So density related to what? Mass. Which of the following belongs to the? Belongs to the class of vinylic halide. What is vinylic, my dear? Halogen connected carbon is sp2. Again, it's connected to sp2. See the first compound. Here the halogen connected carbon is what? sp3 carbon. Okay, leave it. sp2 should come. And what about this case? Here the halogen connected carbon. Yes, it's having a double bond connection sp2. Yes, here also sp2. Yes, option B. Let me take option B once again. CH2 double bond. CBr, CH3. Check it all. Halogen connected carbon, sp2. Again, it's connected to sp2. This is our vinylic group. Check it other cases. It's not there. This is sp. Leave it. Now, in which of the following molecule carbon atom marked with the asterisk is asymmetric? What is meant by asymmetric? Chiral carbon. Where is a chiral carbon? You know very well, my dear student, you know very well what is chiral carbon. If the carbon, all four surrounded groups, if the carbon, all four surrounded groups are different, then what we call a chiral carbon. See this first carbon. This carbon connected to hydrogen, iodide, chlorine, bromine. See, all are different. Yes, this carbon is chiral. Here is connected deuterium, chlorine, bromine, iodine. See, all are different. This is chiral. What about this case? Hydrogen, OH, CH3, methyl and ethyl. See, all are different, chiral. What about here? These, here repetition is there. No, all should be different. All the four bonds should connected to four different atoms or different group. Then only it will be chiral. So, A, B, C, all are what? Chiral. Question which is asymmetric. Asymmetric mean which is chiral. Okay. A, B, C are chiral. Which of the following is an example of, again, vicinal dihalide? Vicinal. Dichloromethane. What is dichloromethane? CH2Cl2. See here. Here both of the halogens are on same carbon. It is geminal. Not answer. 1,2-dichloroethane. Yes. 1,2-dichloroethane. Yes. Here the halogens are on adjacent carbon. This is our vicinal. What is ethylidene? Remember what is ethylidene? What is ethylidene dichloride? Here, this is the ethylidene dichloride. Okay. This is also geminal. So 1,2-dichloroethane is the vicinal dihalide. The position of bromine in the compound is, check it out. Let me write the compound. CH3, CH double bond, CHC. On this C1 Br is there. And in which one? 2 CH3 are there. This is the compound given. And what is the position of this bromine? Oh, where is the position? See, the halogen connected carbon is sp3, then it's connected to sp2, then again it's connected to sp2. Halogen with sp3, sp2, sp2, what is that? Allyl group. Yes, this is what? Allylic position. So, these position based questions are more repeated in the previous year. Okay. Halogen connected carbon sp3, again connected to sp2, again connected to sp2, that is allyl group. Now, what is A in the following reaction? Okay, let's see. Simple reaction. See, this is an alkene. They are adding HCl. You know very well, this is our Markovnikov's rule. According to Markovnikov's rule, negative part goes to carbon with less hydrogen, positive part goes to carbon with more hydrogen. What we get? Benzene, then we have CH2, then CH, to which Cl will attack, then you will get CH3. Where is that? Where is that, my dear? That is option third one. So that means just we are following what? The Markovnikov's rule. You know, negative part goes to carbon with less hydrogen, positive part goes to carbon with more hydrogen. This is the 51. A primary alkyl halide would prefer to undergo SN2 reaction. You know what is the order of the SN2 reaction? Primary greater than, secondary greater than, tertiary. Yes or no? Because primary less steric hindrance were more reactions. So primary greater than, secondary greater than, tertiary is the order of which one? SN2. So primary haloalkane prefer to undergo which mechanism? SN2 mechanism. Which of the following alkyl halide will undergo SN1 reaction most readily? You can able to see all are tertiary here. See, CH3, tri-CF, chlorine, bromine, iodine. Here only the difference is fluorine, chlorine, bromine, iodine. All are tertiary, and you check the, if it is so, check the halogen present. You know, I told you which is the halogen more reactive? Iodine. Because iodine is bigger in size, weaker the bond, easy to break, easy to undergo reaction. So the last one is the one. So fluorine, chlorine, bromine, iodine, if they mention, and all are tertiary or all are secondary or all are primary, in such cases, which is the best leaving group, that you want to check it. Iodine is the best leaving group. Now, IUPAC name of, let me just mark this compound once again, okay, for making it more clear. CH3, CH, what is C2H5? CH2CH3, okay, CH2CH3, then CH2Br. Most of the students, what the mistake they are doing is, they are taking this as a branch. No, dear all, if they given any short form, please try to expand it. Maybe your parent chain is going through that way. Okay, so where is the parent chain? Can you select a longest chain here? Are you selecting 1, 2, 3? Then it is wrong. You have another chain 1, 2, 3, 4. So let me take it. this is the parent chain. And you know, parent chain, while numbering, the branches should get least number. So let me start 1, 2, 3, 4. 1 bromo, 2 methyl butane. 1 bromo, 2 methyl butane. 1 bromo, 2 methyl butane. Option 3 is the correct answer. Please don't take C2H5 as ethyl, my dear. It is not a branch here. It is come as a parent chain, part of the parent chain. So when they give you any short form, ethyl, methyl, any short form if they given, please expand it. Maybe your parent chain is going through that way. Okay. Next one. What should be the correct IUPAC name of diethyl bromomethane? What do you mean by diethyl? 2 ethyl group. This is one CH3, CH2. This is one ethyl group. This is another ethyl group. All right. This is 2 ethyl group, in which we have bromomethane. Methane means how many carbon? Only 1 carbon with a bromine. Diethyl bromomethane. This is the compound. What is its IUPAC name? 1, 2, 3, 4, 5. 3-bromopentane. 3-bromopentane. See the way of question. See the way of question, my dear. So, okay. So, this is diethyl bromomethane. Its IUPAC name is what? 3-bromopentane. Clear? The reaction of toluene with the chlorine in presence of iron and in the absence of light yield. Already we discussed this reaction before. The reaction of toluene with what? Chlorine in presence of what? Presence of iron and in the absence. Iron in the sense Fe or FeCl3. In the absence of light. So, absence of light means we can say it is not a substitution reaction, because substitution happen in presence of what? Light. So, this is our electrophilic substitution reaction. So, Cl go to ortho and para, because toluene is a ortho para directing group. So, we will get CH3, 1 Cl here, ortho chloro toluene, and we will get para chloro toluene, because it is our electrophilic substitution. So, we won't get this one. 2 and 3 are possible. So, mixture 2 and 3. This is the correct answer. Mixture of 2 and 3 can form. And here, which of the following molecule is chiral in nature? Chiral in nature question already we discussed. Okay, once again. 2-bromobutane. What is 2-bromobutane? This is the compound 2-bromobutane. Check it. Is there any chiral carbon or not? Yes. This carbon is chiral. Why this carbon is chiral? Because it connected to methyl group, bromine, hydrogen and 1 ethyl. See, all are different. Therefore, this carbon is what? Chiral. Option A is the answer. Let me check it. Why it's not? Let me check one compound random. Okay. Why it is not option 4? 2-bromo-propan-2-ol. 2-bromo-propan-2-ol. This compound. Tell me, dear all, why there is no chiral carbon? If you check this carbon, it's connected to 2 same group. All groups should be different. All bonds should connected to different. Then only it will be chiral. So option A is chiral. Reaction of C6H5CH2Cl. What is C6H5CH2Cl? C6H5CH2Cl. You know, I told you this group is called benzyl. This is called what? Benzyl chloride. Benzyl chloride. With aqueous sodium hydroxide follow. Dear all, aqueous. What do you mean by aqueous H2O? We studied in classes SN1 mechanism follow polar protic solvent. Right? SN1 mechanism follow polar protic solvent. That means water, alcohol. So aqueous alcohol medium SN1 mechanism is favored. You know why the SN1 mechanism? What is the first step in SN1 mechanism? Halogen goes, will get carbocation. What is this carbocation called? Benzyl carbocation. It is highly stable because this carbocation it can involved in resonance stabilization. Dear all, benzyl carbocation is something more stable, okay, because it getting more resonance stabilization. So even it's aqueous. Aqueous means what? That's basically follow SN1 mechanism, because aqueous medium is a polar protic solvent. That polar protic solvent SN1 mechanism is favored. One more reason, the carbocation is more stable. So they prefer to undergo SN1. So question reaction of this one will follow, yes, SN1 mechanism. Because of 2 reasons. One is medium is aqueous. Second one, stability of the carbocation. Which of the carbon atom present in the molecule given is asymmetric? My dear, what is asymmetric? Asymmetric means which is chiral. Which is chiral in nature. Check this carbon. This carbon, one bond with OH, but two bond with oxygen. Two bonds connected to same element. So it is not chiral. You can able to see this carbon also same situation. Two bond is connected to same element. All four bonds should connected to different. So this is not chiral. What about C? This C connected to OH, H and COOH and then one another group. Yes, all are different. Even this carbon also same, connected to one chain here, one hydrogen, one OH, one CHO. All are different. B and C are chiral. B and C are chiral. Okay, yes, B and C are chiral here. And which is the correct increasing order of the boiling point of the following compound? 1-iodobutane. Let me draw the structure here fast. All of you carefully listen. 1-iodobutane. So 1, 2, 3, 4. 1-iodobutane. 1-bromobutane. Okay, 1-bromobutane. Fine. Then 1-chlorobutane. Okay, 1-chlorobutane. Chlorine. And you have butane. Okay. What is the main factor affecting the, what is the question? What is the correct increasing order of their boiling point? Increasing order. Boiling point mainly depends on molecular mass. Which one having highest mass? Of course, iodine. See, all of them contain same carbon number. So check the halogen. Iodine is the one biggest mass. So this one having greatest, then bromine, then chlorine, then this normal. So where is that? 1-iodobutane, 1-bromobutane, 1-chlorobutane, butane. Yes, first one. So factor is which one? Boiling point mainly depends on the molecular mass. Greater the molecular mass, greater the boiling point. Which is the correct increasing order of the boiling point of the following compound? First one, 1-bromoethane. What is 1-bromoethane? This is 1-bromoethane. 1-bromopropane. 1-bromopropane. One carbon increased. 1-bromobutane. Yes, one more carbon increased. And bromobenzene. Yes, bromobenzene. Check it all where you can able to see the highest mass. Highest mass is in this one, right? Because it contains 6 carbon and bromine. Then here 4 carbon bromine, 3 carbon bromine, then 2 carbon bromine. So where is the answer? Question is increasing order. So where is the answer? Check it all. Bromoethane, bromoethane, bromobenzene. Yeah, bromobenzene, bromoethane, no, bromobenzene, bromobenzene, bromobutane, bromopropane, bromoethane. Yes, fourth one is the correct answer. So greater the molecular mass, greater the boiling point is the factor. Okay, correct. Next. Which of the following is not an allylic halide? Not an allylic. What is allylic? Halogen connected carbon, sp3, then connected to sp2, again it's connected to sp2. Let us check it all. Option A, 4-bromo-pent-2-ene. Let me draw pent-2-ene first. Which is not an allylic is the question, okay. This is pent-2-ene, 4th position bromine, 4th position bromine. Is it allylic or not? Check it all. Here the halogen connected carbon, sp3, this is what? sp2, this is again sp2. Yes, this is allylic. So that's not our answer. 3-bromo-2-methyl-but-1-ene. What is but? 4 carbon, 1-ene. 3-bromo, 3rd position bromine. 3-bromo, 2-methyl-but-2-ene. Check it. Here halogen connected carbon, sp3. This is sp2. This is sp2. Yes, it's already allylic. So not our answer. 1-bromo-but-2-ene. 1-bromo-but-2-ene. Right, 1-bromo-but-2-ene. Here you see halogen connected carbon sp3. This is sp2, again sp2. This is also allylic. So what is the only chance? I think option D is the answer. Let us check it. Okay, let us check it. 4-bromo-but-1-ene. You know, this is but-1-ene, 4th position bromine. Check it. This is sp3. Again, it's connected to sp3. No, sp3, sp2, sp2 should come. Here sp3, sp3. So this is the one. Answer option D, which is not containing any allylic group. Clear? Now, alkyl halides are immiscible. What is immiscible? Not soluble. Alkyl halides are immiscible in water though they are polar, because we studied haloalkanes are polar even though they are not soluble in water, because haloalkanes cannot form hydrogen bond with the water. So they cannot form hydrogen bond with the water, therefore they are insoluble in water. Okay. Now, which of the following alkyl halide undergo hydrolysis with the aqueous KOH at the fastest rate? I told you again, aqueous. hydrolysis. What is that medium? H2O. If water is the medium, they're indirectly asking you SN1 mechanism. Please note all of you. They ask you SN1 mechanism in different way. Which will undergo SN1 faster, which will undergo hydrolysis faster, which will undergo solvolysis faster, which will give racemization faster. All indicating SN1 mechanism. Okay, SN1, hydrolysis, solvolysis, racemization, all indicating SN1 mechanism. So indirectly they are asking you which will undergo SN1 faster. What is the first step in SN1 mechanism? Remove the halogen, make the carbocation. Remove the halogen, make the carbocation. Check it all. What type carbocation is this? This carbocation connected to only one carbon, it's primary. This carbocation connected to one carbon, primary. This carbocation connected to one carbon, primary. But this carbocation connected to two carbon, it is secondary. So you know that what is the reactivity order of our SN1 mechanism? Tertiary greater than, secondary greater than primary. So secondary is the one undergo reaction faster. And in the reaction given below, which of the following statement is correct? They're all whether they are asking you whether it is SN1 or SN2 mechanism. Can you say? See, this is our haloalkane, right? This is our haloalkane and this OH minus is the nucleophile. So this is the way they are initially existing. When the nucleophile attack, they get like this. Means there is a inversion happen. Where we studied inversion of configuration, SN2. SN1 mechanism retention, SN2 mechanism inversion. So the reaction proceed via SN2 mechanism, hence inversion of configuration takes place. Let's go with option A. This is see the arrangement configuration. It is like this. After the attack of nucleophile, like this. There is a inversion of configuration happen. Now, tertiary alkyl halide are practically inert. Inert means not reactive. With the SN2 mechanism. We know SN2 mechanism, what is the reactivity order? What is that? Primary greater than, secondary greater than tertiary. You know why tertiary undergo SN2 mechanism lesser? Because there is more steric hindrance, more bulky groups, right? So what is the answer? Option B, there is steric hindrance. So tertiary haloalkane are practically inert to undergo SN2 mechanism because of high steric hindrance. Now, consider the following bromide. You can able to see some bromides here. What is the correct order of their SN1 reactivity? SN1 reactivity is what? Basically tertiary, secondary, primary. What is the first step in SN1 mechanism? Remove halogen, carbocation. Remove halogen, carbocation. Remove halogen, carbocation. What carbocation is this? Dear all, this carbocation connected to one carbon, it's normal primary. This carbocation connected to two carbon, it is secondary. This carbocation also connected to two carbon, secondary. What is Me stands for? Methyl, okay, methyl group. So you have a confusion. We can avoid A, that is least, B or C. Dear all, please write a complete data about this one. B compound, you can able to see what is this carbon CH and this is what CH and this is CH2. You know this is allylic, my dear. Check it all, this allylic or not. See halogen connected, what is this? Sp3. This is what? Sp2, this is again Sp2. This is a allylic, okay? This is a allylic haloalkane. What about this one? This is normal secondary. So allylic or secondary more stable? Allylic, because, you know, let me take a allylic group here. This is the allylic carbocation we have now. Sp2, Sp2, Sp3. Dear all, you know, allylic is more stable because of resonance. Allylic is having stability. So allylic and secondary and primary if it comes, allylic having more stability. Allylic having more stability. So B undergo reaction faster. BCA. BCA. Option B is the answer. BCA. What is the answer? Let me explain once again. Basically the order we are following was tertiary, secondary, primary. But here primary is there, but option B and C both are secondary. Among that two, which is more stable, that B compound contain allylic group because there is Sp2, Sp2, Sp3. So that is allylic. Allylic is more stable than secondary and primary because allylic having more resonance stabilization. Okay, so BCA is the correct answer. Which of the following? Correct, right, my dear? BCA, BCA. Okay. Now, Which of the following reaction does not takes place? Does not takes place. Which is incorrect is the question. You know that the Ag and KNO2, AgNO2, AgCN, KCN are the ambidentate nucleophile. You know very well, if you treated a haloalkane with a KCN, you will get cyanide. If you treated with the AgCN, you will get isocyanide, NC. If you treated with a KNO2, you will get ONO. If you treated with the AgNO2, you will get NO2. Yes or no? Correct, right? So here, which is incorrect? KNO2, if you are using ONO, correct? AgNO2, you will get NO2, correct? AgCN will give you NC, correct? KCN will give you NC. No, KCN will give you CN, cyanide. This is the wrong one in this question. Hope it's clear. You studied about ambidentate nucleophile. Nucleophile having two attacking side, but at a time they use only one. Now here, next question. Which of the following chlorohydrocarbon readily undergo solvolysis? I told you, dear, solvolysis, hydrolysis, something if they ask, you have to follow SN1 mechanism. Here I will tell you a detailed idea about this SN1 mechanism. What is SN1 mechanism? First thing, remove the halogen, make the carbocation. Okay? Remove the halogen, make the carbocation. Remove the halogen, carbocation. Carbocation, and this is the carbocation. Your duty to identify which is more stable carbocation that will undergo reaction faster. Let me give you some clear idea about this area. This is what? This is which carbon? This carbon is sp2 carbon. This carbon is sp2. This is vinyl. So option A is vinyl carbocation. Option A is vinyl carbocation. What is B? The positive charge on benzene ring. On benzene ring. It is like this. The positive charge on benzene. This is called phenyl carbocation. Phenyl carbocation. And this is sp3 carbon. Then it's connected to benzene. This is what? Benzylic carbon. Benzyl carbocation. Benzyl carbocation. And this is what? Carbocation connected to one carbon. This is normal primary carbocation. Primary carbocation. Please note it all. What is the basic idea you studied? Tertiary, secondary, primary. Yes or no? After that, we have some more. Methyl carbocation is the next. Then we have a vinyl and phenyl. Then we have vinyl and phenyl. Please note it. Vinyl carbocation and phenyl carbocations are very less stable, very unstable. So they do not undergo SN2 reaction faster. Study like that. Vinyl and phenyl carbocations are highly unstable. You just leave them. So phenyl and vinyl won't come under our area. Now you have primary and benzyl. We know that benzyl carbocation is more stable due to resonance. So option C is the one undergo reaction faster. Okay, benzyl is more stable. Benzyl and allyl all coming under this area. Benzyl, allyl, these all coming under highly stable carbocation. Then only we have the tertiary, secondary, primary, vinyl and phenyl and all. So this is vinyl, least stable, leave it. This is phenyl, least stable, leave it. This is primary and benzyl. Among that, benzyl carbocation is coming under this area, more stable carbocation. Now, which of the following alkyl halide is hydrolyzed by SN1 mechanism? Means they're asking which will undergo SN1 mechanism faster. SN1 mechanism means remove the halogen carbocation, remove the halogen carbocation, remove the halogen carbocation, remove the halogen carbocation. Dear all, this is methyl carbocation. This is primary carbocation. This is also primary. But you see, this is tertiary because this is the structure of this complete one. Right? This is the carbocation. This is tertiary. We know tertiary will undergo reaction faster. Correct. Which of the following will give an enantiomeric pair on reaction with the water due to the presence of asymmetric? What do you mean by asymmetric carbon, my dear? Asymmetric carbon means where there is a chiral carbon. See this carbon chiral or not? No, because it have two same group ethyl. Leave it. This carbon chiral? No, it have same group. Leave it. Is this carbon chiral? Yes, because it contain hydrogen, iodine, methyl, ethyl. See, all are different. This is the one chiral. What about this? This is having repetition. Right? So this is the one chiral in this question. Next one. Which alkyl halide exhibit complete racemization? I told you racemization means SN1 mechanism. So which will undergo SN1 mechanism faster is the question, my dear. Option A is, let me just expand, okay. CH3 twice CHCl. This is option A. And option B, okay, I'm just taking option B as it is. So option A, if you're checking, if you remove the this is the carbocation, you know, this is secondary. And if you remove this chlorine, this is the carbocation, it is primary. And if you remove this one, you will get primary. But what about this carbocation? Do you remember this carbocation? C6H5, CH2Cl. See, this carbocation is what? Benzyl carbocation, my dear. It is more stable due to resonance. Okay, this is secondary, this is primary, this is primary, this is benzyl. Benzyl is more stable. Benzyl and allyl carbocations are more stable than this primary, secondary. So option D is the one undergo SN1 reaction faster, right? Which will undergo complete. Okay. Okay, that's clear, right? Okay, benzyl is the correct. Next one, my dear, elimination of bromine from 2-bromobutane. What is 2-bromobutane? This one. 2-bromobutane results in the formation of, you know, beta elimination. What is beta elimination reagent? Alcoholic KOH. What is beta elimination? Halogen go from alpha, hydrogen go from beta. You can take either this beta or this beta, but I am selecting this beta because more the double bond we have to make at the more centered position because that will be the more stable. Double bond we need to try to make in the more substituted area. That will be the major product according to Zaitsev rule. So either you can take this one, that will be minor product. This is the major product. So I am taking this bromine, this hydrogen and placing a double bond here. We will get CH3, CH double bond, CH, CH3 as a major product. What is this? Butadiene. Yes, dear all, 2-butene or 2-butene is the major product. So predominantly we get 2-butene. Even you get 1-butene also, yes or no? But that will be the minor product. Maximum try to make the double bond at the center, more substituted area. That will be the major product according to Zaitsev rule. Now, Grignard reagent. What is Grignard reagent? You know, RMGX. Right? Grignard reagent is RMGX, alkyl magnesium halide. Grignard reagent is a very useful starting compound for a number of organic compound can be prepared by. How Grignard reagent is preparing? You know, when haloalkane react with magnesium in dry ether, yes or no? You will place this Mg here. You will get RMGX. This is called Grignard. They are asking you what is the Grignard reagent preparation. Reaction of alkyl halide with a solution of magnesium hydroxide, no. Reaction of alkyl halide with a magnesium powder in the presence of dry ether, yes. B. Reaction of MgCl2, no. Reaction of alkyl halide with the magnesium in presence of alcohol, no. Haloalkane react with the magnesium in dry ether, you will get alkyl magnesium halide. That's called Grignard reagent. Option. Identify the product X and Y in the given reaction. Let me write the reaction for make it more clear. The starting is, dear all, they given CH3, CH, Br, CH3. Okay, this is a haloalkane. They are treating with the magnesium in presence of dry ether. Haloalkane with the magnesium, we get Grignard reagent, right? So Mg, let me place in between this carbon and Br. You will get CH3, CH, Mg, Br along with the CH3. This is our Grignard reagent. You know Grignard reagent ion Mg plus the alkyl group minus, to which they are adding D2O. I told you D2O contain D plus and OD minus. So D plus go to this minus, OD go to this plus. You will get CH3, CHD and then CH3. Byproduct is not given in the option, so just leave it. So where is this compound X and Y? Collect all CH3, CH, Mg, Br. Yes, that is I think option B, right? CH3, CH, Mg, Br, CH3. Yeah, then CH3, CHD and CH3. Correct? Option B. So first reaction, formation of Grignard reagent, then hydrolysis. What is D2O called? Heavy water. They contain D plus and OD minus. Now, chlorobenzene on treatment with chlorobenzene. What is that? Chlorobenzene on treatment with the sodium in dry ether, in presence of dry ether, gives diphenyl. Yes, where we studied this reaction, my dear, diphenyl preparation, what we call Fittig reaction. Yes, Fittig reaction. You know, Wood's reaction is to combine to haloalkene. Fittig reaction to combine to haloarene. Wood's Fittig is to combine one haloalkane with one haloarene. Okay. Question number 76. Aryl halides are less reactive towards, you know that this is a aryl halide, for example, chlorobenzene, and let me take a haloalkane here, chloromethane. Aryl halides are less reactive toward nucleophilic substitution, that you studied very well as a reasoning question in this chapter. You know that the removal of halogen from the benzene ring is very harder due to two reasons, due to partial double bond. Chlorobenzene can undergo resonance and they form a partial double bond between carbon and halogen. Double bond is harder and stronger bond, right? So because of the stronger double bond, removal of halogen is difficult. And also you studied one more reason, due to high S character. Here the halogen connected to sp2 carbon. sp2 means 33.3% S character. But in haloalkane, halogen connected carbon is sp3 carbon, that is only 25% S character. More the S character, more the electronegative the carbon, very tightly hold the chlorine. So because of two reasons, because of partial double bond and high S character, removal of halogen is harder from benzene ring. So the point is, aryl halides are less reactive towards nucleophilic substitution, because when you can remove the halogen, then only you can substitute the nucleophile. So haloarene do not undergo nucleophilic substitution faster because the halogen removal is from benzene ring is harder. So where is the answer given? Formation of a less stable carbonium ion? No. Resonance stabilization in aryl halide? Yes, resonance stabilization. Presence of double bond in alkyl halide? No, it is in haloarene. Inductive effect? No. B. So in haloarene, because of resonance, they form a partial double bond between carbon and halogen. Double bonds are stronger bond, harder to break. So therefore less reactive. Now, the end product Q in the following sequence. Can you tell me the answer, my dear, fast? This is benzene on chlorination. What do you get? Chlorobenzene. Chlorobenzene treated with the sodium and ether. What is that? Fittig reaction. You will get biphenyl. Option C is the correct answer. Fittig reaction. See, Fittig reaction, three different way of question we discuss. Okay. So benzene on chlorination we get chlorobenzene. Chlorobenzene on Fittig reaction we get diphenyl. Chloroform is kept in dark colored. Part 1 video we discussed this one. Chloroform CHCl3 is highly reactive toward oxygen and light. It immediately forms a poisonous gas called phosgene. What is phosgene chemical formula? COCl2, right? So chloroform is kept in dark colored bottle because it is reactive with the clear glass. No. It undergo chlorination in transfer. No. It is oxidized poisonous gas phosgene in sunlight. Yes. Phosgene, the poisonous gas formed in presence of sunlight. What is formed when ethyl magnesium bromide? What is ethyl magnesium? This is ethyl magnesium bromide. It's a Grignard reagent, Mg plus this minus. When react with the water, we already discussed many times this with the D2O, heavy water. H2O contain H plus and OH minus, right? So make the ions. To the negative part, H plus will add. You will get CH3 plus. What is the byproduct? To the MgBr positive magnesium, the OH will attack. So what is this product? Ethane is the product. Basically, Grignard reagent when react with the water form alkane. Grignard reagent when react with the water, it form alkane. That is the point. Now, compared to haloalkane. So I think that question is clear, my dear. And next one. Compared to haloalkane, the reactivity of haloarene toward nucleophilic substitution reaction is, we discussed that point. Compared to haloalkane, the reactivity of haloarene towards nucleophilic substitution reaction is what? Low. Yes or no? We studied haloarenes are less reactive toward nucleophilic substitution because the halogen removal from the benzene ring is harder due to partial double bond resonance, right? So compared to haloalkane, the reactivity of haloarene toward nucleophilic substitution reaction is what? Less. Then, which of the following compound is most easily converted to phenol when heated with the aqueous NaOH solution? You know, this is given chlorobenzene, right? Chlorobenzene, 4-chloronitrobenzene, 4-chloronitrobenzene, then 2,4-dinitrochlorobenzene, 2,4-dinitrochlorobenzene, and 2,4,6 trinitrochlorobenzene. Okay. Question: which of the following compound can be easily converted to phenol? You know, you studied a reaction chlorobenzene to phenol. That's called Dawes process, right? What is the reaction? We take chlorobenzene treated with the aqueous NaOH at 623 Kelvin and 300 atm pressure. What we get? Sodium phenoxide, ONA. This on treated with HCl, we get phenol. This is the reaction we studied. Conversion of chlorobenzene to phenol. What is this process called? Dawes process, right? Dawes process. Here the question, where the Dawes process can happen faster? Where, you know, first of all, we have to remove the chlorine. Then only we can add the OH. You know, chlorine removal from benzene ring is harder due to partial double bond. So, you can able to see some groups are attached here, you know, nitro group. What is nitro group? They're all nitro group is a very strong electron withdrawing group. If there is a strong electron withdrawing group present, what happen? If there is a strong electron withdrawing group present, they withdraw the electron from the chain and make the CCl bond weaker. Make the CCl bond weaker, you can easily break it. So where you can remove the chlorine, faster, that is option D, because there are more withdrawing group. So more the withdrawing group, they withdraw the electron from the chain, make the CCl bond very weak. If it is very weak, easy to break chlorine, easy to bring OH. So option D is the correct answer. Which of the following compound is most easily converted to phenol? Keep in mind, all of you, if there is electron withdrawing group on the benzene ring, removal of halogens are easier. Okay, next one. Chlorobenzene on reaction with the NaOH. Just to be discussed now. Chlorobenzene when react with the NaOH at 300 Kelvin. 300 Kelvin followed by acidic hydrolysis produces. That is same like this reaction. Chlorobenzene react with the NaOH followed by acidification, means HCl. What we get? We get the compound phenol. So chlorobenzene on reaction with the NaOH at 300 Kelvin. Actually, the temperature we are using 623 Kelvin. As I told you, some groups when present here like nitro group, removal of chlorine is easier, so temperature can be reduced. And converted to, first 300 Kelvin followed by acidic hydrolysis. That will give what? Phenol is the product. Now, which of the following is most reactive toward aqueous NaOH? I told you aqueous. Aqueous means they are asking you SN1 reaction. Which will undergo SN1 faster? See dear all, I told you first your duty to make the carbocation. Remove the halogen, carbocation. Remove the halogen, carbocation. Carbocation. Halogen, carbocation. See what kind of carbocation is this first one. This is C6H5. What is C6H5? That is our phenyl carbocation, my dear. This is phenyl carbocation. We discussed phenyl and vinyl carbocations are highly unstable. Leave it. What is this? What is this? C6H5 CH2. This is our benzyl carbocation. You know it is more stable due to resonance. So this is the one can undergo. This is phenyl. This is also phenyl. So option A, C, D are phenyl carbocation. You know phenyl carbocation are highly unstable, but benzyl carbocation is more stable due to resonance. So B will undergo SN1 reaction faster. IUPAC name of the given compound is, what is the given compound given? CH3, CH2, CBr, double bond CH, single bond Cl. This is the compound given. You know halogens are here. Please don't give more priority for halogen because double bond is there. Double bond having more priority than halogen. So I'm starting numbering here 1, 2, 3, 4. Alphabetical order, bromo or chlorine come first. Bromo, right? So 2 bromo, 1 chloro. What is the answer? 2 bromo, 1 chloro. Yes. 2 bromo, 1 chlorobutene. Right. 2 bromo, 1 chlorobutene. So while numbering, we should be very careful, and alphabetical order, be careful. So double bond having more priority than halogen. Okay. Keep in mind. In the preparation of, so I think that question is clear, right? 2 bromo, 1 chlorobutene. Question number 85. In the preparation of chlorobenzene from aniline, the most suitable reagent is. Can you say the reaction which one? Aniline to chlorobenzene. What is the reaction? We know aniline, first we will do diazotization. What is diazotization? Treating with the NaNO2 and HCl at 0 to 5 degree. What we get? Benzene with N2Cl. What is called? Benzene diazonium chloride. This is called diazotization. This on treated with the Cu2Cl2 along with HCl, we get chlorobenzene. We get chlorobenzene. What we need to prepare? Chloro, right? This is our Sandmeyer reaction. Otherwise, you can use copper powder. Copper powder along with HCl. There also you get chlorobenzene. But that is our Getterman reaction. Yes. So, which is the, they asking which is the best method to convert aniline to chlorobenzene? Chlorine in the presence of ultraviolet, no. Chlorine in the presence of AlCl3, no. Nitrous acid followed by heating with the Cu2Cl2. What is nitrous acid, my dear? What is the reagent we are adding in the diazotization step? NaNO2 and HCl, right? See, NaNO2 and HCl, they react together. You get NaCl and HNO2. You know, HNO3 is called nitric acid. HNO2 what we call nitrous acid. So option C is the answer. That's our Sandmeyer reaction. So instead of NaNO2 and HCl, you can write HNO2. That's the point. Okay. Instead of NaNO2 and HCl, you can write HNO2. HNO2 is what? Nitrous acid. That also diazotization. Then Sandmeyer or Getterman. Here Sandmeyer is given. Now in which of the following conversion phosphorus pentachloride? What is phosphorus pentachloride? PCl5 is used. You know what is the function of PCl5? It convert a alcohol to RCl. This is a function of PCl5. Where is a alcohol converted to halogen? Check it all. Where is a alcohol? Yes, that is option B, right? Alcohol converted to halogen. That is in option B. Clear? So what is the purpose of each reagent? Please correct. PCl3, PCl5, all their duty to convert OH to Cl. Then butane nitrile. What is butane nitrile? This is our 2024 board question, my dear. Butane nitrile. What is butane nitrile? CH3, CH2, CH2, CN. You know, nitrile is also called a cyanide. Butane nitrile, the term contains total 4 carbon. See, 4 carbon contained cyanide is this one. Butane nitrile, another name is propyl cyanide. Propyl cyanide. See, butane nitrile or propyl cyanide. That's both are same, okay? This can be prepared by heating with what? We studied cyanide preparation from where? By treating with the KCN. With what? Haloalkane, not with alcohol. Not with alcohol. Haloalkane react with the KCN. This is the reaction we studied. Haloalkane when react with the KCN, we get what? RCN, cyanide. So, butyl chloride or propyl chloride, which will you choose? There already KCN, CN is there. So, we need 3 carbon. So, that is propyl chloride, you take it. What is propyl chloride? CH3, CH2, CH2, Cl. Propyl chloride when react with the KCN, what happened? This KCl go out, you will get CN, CH3, CH2, CH2, CN. Yes, we are getting option D. If you are using butyl chloride, butamine 4 carbon, including the cyanide, 5 carbon comes. That's not our answer. Butane nitrile mean total 4 carbon containing cyanide. Okay, so that is option D, 2024 board question. Next one. Identify the compound B in this following reaction. What is the compound given? They given cyclohexyl bromide, right? Cyclohexyl bromide is given, not benzene, okay? When they react with the magnesium in dry ether, you know, we will get Grignard reagent, put the Mg in between this carbon and halogen. You will get cyclohexyl magnesium bromide. You know, magnesium plus the alkyl group minus in Grignard. When it is react with the water, we studied Grignard reagent. When react with the water, it form alkane. What are the ions in water? H plus and OH minus. So H plus go to this minus 1, you will get cyclohexane, and the byproduct is what? MgBr is there, to which the OH will attack. So what is the product? Cyclohexane is the product. What is cyclohexane? Yes, careful, okay, this is cyclohexene. Cyclohexane is the product. Generally, Grignard reagent, when react with the water, it form alkane. Okay, that we studied already. The alkyl halide is converted to alcohol by alkyl halide, for example, RX, converted to alcohol by which reaction? Which is reaction? Substitution reaction. We are using what? Aqueous KOH, right? What is aqueous KOH? OH is the nucleophile. Nucleophile is attacking, X is leaving. X is leaving, nucleophile is substituting. So alloalkane converted to alcohol, that is by what? Nucleophilic substitution reaction. Option D. A mixture of 1 chloropropane. Okay, 1 chloropropane. You know, this is 1 chloropropane. And 2 chloropropane. This is 1 chloropropane and this is what? 2 chloropropane. When treated with the alcoholic KOH, what is alcoholic KOH, my dear? Alcoholic KOH is beta elimination, right? Yes. What is beta elimination? Halogen go from alpha, one hydrogen go from beta, put a double bond in between alpha beta. You will get the compound propene. Here halogen go from alpha, both are beta are same, so hydrogen go from one beta, you will get a double bond between that. Here also propene, both are same here. So what you will get? A mixture of 1 chloropropane and 2 chloropropane, when undergo beta elimination, we get prop1ene as the major product. You won't get mixture. There is no chance to get prop2ene. Only prop1ene is the chance. 91. A Grignard reagent is prepared by the action of magnesium in dry ether on, haloalkane react with the magnesium in dry ether. You will get RMgX. Which is a haloalkane? That is a question. Which is a haloalkane? C2H5Cl, right? This is alcohol, this is ethane, this is what? Ethyl cyanide. Now, which of the following is most reactive toward SN1 reaction? They are all very important question, mark it. First one, C6H5. What is C6H5? Phenyl. With one carbon, with one methyl, with one Br, and with one more C6H5. That's the first compound. Second one is C8, not C8, okay? This is C6H5. C6H5, CH2Br, benzyl bromide. Option 3, C6H5, CH, one more C6H5, then one Br. And option D, C6H5, then CH, CH3Br. This is the compound we have. What is the first step in SN1 mechanism? Halogen goes, carbocation. Halogen, carbocation. Halogen go remove, carbocation. Yeah, I told you your duty to identify which is the most stable carbocation. This carbocation connected to 3 carbon, it's tertiary. This carbocation connected to 1 carbon, primary. This carbocation connected to 2 carbon, secondary. This carbocation connected to 2 carbon, secondary. Most stable, tertiary. And one more reason. This carbocation contain 2 benzyl rings, so 2-way resonance is possible. Here only 1 benzene ring. Here 2 benzene ring. Here only 1 benzene ring. So more number of benzene ring present, more stable. So which is more stable here? Tertiary as well as 2 benzyl ring is there. So option A is the one undergo. Which is of the following most reactive? Yes, A will undergo reaction faster because it is tertiary carbocation and more benzyl ring is present. CCl bond of chlorobenzene. This is chlorobenzene. Right, this is chlorobenzene. This is the CCl bond. Okay, CCl bond. In chlorobenzene comparison to CCl bond in methyl chloride. This is methyl chloride. This is the CCl bond. Is CCl bond in chlorobenzene in comparison to CCl bond in methyl chloride is. This CCl bond I told you because of resonance it formed double bond. Partial double bond. Double bond is what? Stronger and shorter in length. Compared to, this is single bond, right? Haloalkane can form only single bond. Single bonds are weaker and longer bond, but double bonds are stronger and shorter in length. So where is that? Shorter and stronger. So CCl bond of chlorobenzene is shorter and stronger comparison to CCl bond in methyl chloride. Bromination of methane in presence of sunlight. You know, this is methane. Bromination means adding bromine in presence of light. What is this reaction? Addition of halogen to an alkane in presence of light or heat is called substitution. Free radical substitution reaction. You will get CH3Br. Okay, this is what? Free radical substitution reaction. Light or heat if there, alkane is there, then it is what? Halogen. This is what? Free radical substitution reaction. DDT is prepared by reacting chlorobenzene with. We studied polyhalogen compound, the last topic in haloalkane chapter. DDT, how it is preparing. You know, let me take it 2-chlorobenzene. We studied in class like, we'll take 2-chlorobenzene. Okay, chlorobenzene is one of the reactant. This one we react with another compound called, okay, let me write like this one. You know, aldehyde group, how we write? CHO. This is aldehyde, right? CHO with the CCl3. This is the compound. So this one, when we heated with a concentrated H2SO4, it undergo dehydration. What is meant by dehydration? Removal of water. From this position, let me take 2 hydrogen and this oxygen. H2O cut. What is remaining? Cl, 1 benzene ring. Cl, 1 benzene. This means phenyl ring. Then it's connected to what? C is on which H is there, 1 CCl3 is there. This is the compound DDT. What is DDT full form? Dichloro, diphenyl, trichloroethane. Dichloro, diphenyl, trichloroethane is the short form of DDT. You studied it's used as a pesticide. And DDT is prepared by chlorobenzene with what? What is this? Where is this compound? This is the one, CHOCCl3. What is its name? This compound is called chloral. Because it contains chlorine and aldehyde. Chloral. Okay, chloral is the compound with the chlorobenzene will give you DDT. A compound X with the molecular formula C7H8. You know what is C7H8, my dear? That is toluene. C7H8 is toluene. You know, C6H6 is benzene with 1 carbon extra, that is toluene. Is treated with the chlorine. Is treated with the chlorine in presence of FeCl3. We discussed many times. You know, toluene is a ortho-para directing group. It is chlorination. So, chlorine go to ortho position and para position, right? Ortho position and para position. So, what is the answer? Which of the following compound are formed during? That's option A, right? So, compound X with the molecular formula C7H8. C7H8 is what? Toluene. Toluene when react with the chlorination in FeCl3 will give you orthochlorotoluene and parachlorotoluene. Methyl bromide react with AgF. Yes, AgF we studied in Schwarz reaction. Schwarz. What is methyl bromide? CH3Br. When react with AgF, what happened? This halogen exchange, right? AgBr go out, you will get CH3F. The existing halogen is replaced by fluorine. That is called Schwarz reaction. Schwarz reaction. Yes. And identify the product A and B in the reaction. So, haloalkane react with the AgCN. You know, AgCN will give you isocyanate, KCN will give you cyanide. So, one will give you NC, other one will give you cyanide, right? NC and CN. Very careful. AgCN will give you isocyanate, KCN will give you what? Cyanide. Okay. Next. An organic halogen compound which is used as refrigerant in refrigerator and air conditioning is what? Freon gas. This is all coming under the polyhalogen compound. Okay, freon gas is used as a refrigerant, chlorofluorocarbon. Chlorofluorocarbon. Which of the following reaction follows Markovnikov's rule? You know, in order to follow Markovnikov's rule, what is the condition? The alkene or alkyne should be unsymmetrical, and the adding species should contain positive and negative part. You know, HBr contain H plus minus. Yes, okay. Chlorine can't be applied, Br2 cannot be applied. The adding species should contain positive and negative parts. So either option A or C. What is C2H4? C2H4 is ethene, my dear. Ethene is a symmetrical alkene because both of the carbon having same number of hydrogen. There is no carbon with less and more hydrogen. So not applicable. What about C is the answer? C3H6. What is C3H6? That is propene. Propene when react with HBr, yes, we can say negative part goes to carbon with less and positive because the propene is a unsymmetrical alkene. So it is applicable. C3H6 plus HBr is the correct answer. So in order to undergo Markovnikov and anti-Markovnikov rule, what is the condition? The alkene or alkane should be unsymmetrical and the adding species should contain positive and negative. Clear, my dear student? Hello dear students, here we are going to discuss the aldehydes, ketones and carboxylic acid 100 MCQs. Now we are discussing the 100 MCQ as 4 parts. First part contain 25 questions, like 4 parts we have. So after completing overall the MCQs, you will get a clear idea about which all questions, which all area you have to be concentrate more in this chapter. Remember, it's the lengthiest chapter, more important chapter. Okay. Let's go to question number 1. Here is the question number 1 for you. Study the following sequence of reaction and identify compound X and Y. Study the reactions first, okay? Then you attend this session. Say, first one. You can see toluene is given here, right? Toluene. Toluene react with the chlorine and light. Where is this reaction we studied? Side chain chlorination. So whenever you add chlorine, 2 times when you add chlorine to toluene, it becomes benzene with a CHCl2. That is called benzyl chloride. So compound X is benzyl chloride. Where is benzyl chloride? Yes, this one, benzyl chloride. Benzyl chloride on hydrolysis, these 2 H2, this 2 Cl cut it, it becomes CHO. That is benzaldehyde, right? Benzaldehyde. Yes, this one. Option D is the answer. So what is this reaction? Toluene, when react with the chlorine in presence of light, it will give you benzyl chloride. That's on hydrolysis, you will get benzaldehyde. It's a preparation of benzaldehyde from which one? Toluene. So benzyl chloride is this one, benzaldehyde is the final product. Next one, arrange the following compound in increasing order of their reactivity in nucleophilic addition reaction. We discussed in class, nucleophilic addition reaction is carried by aldehydes more than ketones. Aldehydes will undergo more nucleophilic addition than ketone because aldehyde contain less bulky groups. So let us see butanone. What is butanone? 4 carbon with a ketone. Okay. Next one is propanone. Okay, propanone means 3 carbon with a ketone. Propanol. Okay, it's an aldehyde. And ethanol. What is that? What is ethanol? 2 carbon with aldehyde. Ready. If you consider this is ABCD, you know aldehydes are more reactive than ketone towards nucleophilic addition. So among these 2 aldehyde, which one? This one. Where less bulky group, where is less carbon present, then more nucleophile can attack. More attack of nucleophile. So D, ethanol is the highest, then propanol. Where is that? Ethanol and propanol. That is only option A. Next word propanone, then butanone, because propanone contain 2 methyl group, but here it contain methyl and ethyl group. So remember, more bulky group when it comes, nucleophile cannot attack this carbon, right? So we discussed that aldehydes are more reactive than ketone toward nucleophilic addition. So aldehydes are more, where aldehyde contain less bulky group, where more reaction happen. Keep in mind. So ethanol, propanol, propanone, butanone, option A itself, that's a correct answer. Next, find the product of the following reaction. What is this reaction? See all of you, it's our acetophenone, right? Benzene with the COCH3, what we call acetophenone. When a ketone react with the amine, all of you, we studied amine and ammonia derivatives, right? We discussed the hydrazine, phenylhydrazine, which one? Semi-carbazide, many things. So these is also contain ketone and an amine. If it amine come, take this H2 and take this O. Means basically water you remove. Just to join. What is left? Benzene with CH3 double bond connected here. N, it's connected to CH2, CH3. Where is this compound? All of you just check it. C on which one? CH3 and double bond N CH2, CH. That's option which one? B is the correct answer. So whenever a aldehyde or ketone react with the amine derivative, how can we understand amine derivative? They contain NH2 group. So just to take the oxygen from our compound and H2 from the amine and just to join them. That's it. Very simple. So this is the compound. And one more thing, remember all of you, that may not be discussed in theory part. Aldehydes when react with aldehydes, carbonyl compound when react with the amines. These are called what? Amines. The product is called what? Schiff's base. What we call Schiff's base. When carbonyl compound react with the amines, these are called what? NH2 group, what we call amines, and the product is called what? The addition product, what we call Schiff's base. Okay, keep in mind. We'll discuss in one another question in detail. So here is the product. Next one, addition of water to alkyne occur in acidic medium and in the presence of mercury 2 plus ion as a catalyst. Yes, we studied. To an alkyne when we add water in presence of HgSO4 and H2SO4, we get enol first. That undergo tautomerism. Sometime we will get aldehyde, sometime we will get ketones. Correct. Question, which of the following products will be formed on addition of water to but1-ine? Let's try. What is but1-ine? CH3, CH2, C triple bond CH. This is but1-ine, to which they are going to add what? H2O. You know, H2O contain the ion H plus and OH minus. So we can follow Markovnikov's rule here. So negative part goes to carbon with less hydrogen. Positive part goes to carbon with more hydrogen. You will get the product as CH3, CH2, COH, double bond CH2. Right? And this product, you know, it contains ene and ol. It contains alkene and alcohol together. So what we call it as enol. And it will undergo tautomerism. It will undergo tautomerism. What is tautomerism? The alcohol hydrogen shift to this carbon. Means this hydrogen reached here. So what is the product? CH3, CH2, C double bond O, CH3. You are getting butanone. So where is butanone? Where is this product, my dear? That is option 2. CH3, CH2, C double bond O, CH3. Okay. So to an alkyne, when you add water, it follow, if it is unsymmetrical alkyne or alkene, it follow Markovnikov's rule. It is happening in presence of what? Mercuric sulfate and H2SO4. Okay. So to an alkyne, when you add water in presence of this catalyst, you will get enol first. That undergo tautomerism will give you what? Aldehydes or ketone. Here it is a ketone. Next one. Which of the following compound is most, this is a repeated question for exam, my dear. Which will undergo most reactive toward nucleophilic addition, reaction with the HCN. These all are nucleophilic addition. Remember, aldehydes are more reactive than ketone toward nucleophilic addition because aldehyde contain less bulky group. Okay, so which of the following compound is most reactive toward? Most reactive means check aldehyde is there or not first. Yeah, this is an aldehyde, this is an aldehyde, this is a ketone, this is a ketone. Because ketone, both side bulky group will be there. Nucleophile can't attack. So among this aldehyde, which one is the least size or the less bulky group? Of course, this one, right? So option A. Here phenyl, big bulky group, so nucleophile cannot attack. So it should be, if it want to be most reactive, it should be an aldehyde and less bulky group. So most reactive is option A. Next one. What is the correct order increasing acidic strength? Okay, acidity they are asking. We studied acidity mainly depends on the presence of withdrawing group and donating group. Withdrawing group will increase the acidity. Remember, what is, okay, first compound is given as phenol, right? Phenol. And next one is given what? Ethanol, CH3, CH2OH. Next one is chloroacetic acid. Chloroacetic acid, okay, acetic acid with chlorine. And what? Normal acetic acid, CH3COH, okay. We know, my dear, carboxylic acids are more acidic than alcohol, no doubt. Carboxylic acid more acidic. So, see, this one is more acidic. Among this one, this is more acidic because chlorine, there is an electron withdrawing group. Electron withdrawing group is there, it make more acidity. So, this is the most acidic one. Where is chloroacetic acid, the highest one? Chloroacetic acid, then acetic acid. That is option 3. Okay, 3 is actually I am writing here. This is option 3. So, chloroacetic acid, then acetic acid. Next, among these two alcohol, which one we already studied in alcohol chapter, phenol is more acidic than normal aliphatic alcohols, right? Because it gives phenoxide ion. So, option 3 is the correct answer. Keep in mind all of you. Point is, carboxylic acids are more acidic than alcohols. Where more electron withdrawing group present, it will be more acidic in nature. Right, next. The reagent which does not react with both acetone and benzaldehyde. Acetone is basically what? Acetone is a ketone, benzaldehyde is an aldehyde. So which reagent do not react both aldehyde and ketone? Which one can you say? We studied sodium hydrogen sulfide, NaHSO3, and phenyl hydrazine, okay, filling solution, okay, then Grignard reagent. Can you say we studied a sodium hydrogen sulfide to react with both aldehydes and ketone. Phenyl hydrazine, yes, react with both aldehydes and ketone. Filling solution. Filling solution is only, Filling's test is only given by aliphatic aldehyde. It won't give by ketone. So, Filling's reagent is only react with aldehyde, not with the ketone. Grignard reagent, yes, it react with both aldehydes and ketone, give you alcohols. Cannizzaro reaction is not given by, in order to give Cannizzaro reaction, there is no alpha hydrogen, that is a condition. Yes or no? In order to give Cannizzaro reaction, no alpha hydrogen. Here they are asking which Cannizzaro reaction not given by, which means they contain a alpha hydrogen. Which one contain alpha hydrogen? Option 4. Because this is the aldehyde. Aldehyde main functional group connected carbon is called alpha carbon. Alpha carbon contain hydrogen is called alpha hydrogen. Yes, it contain alpha hydrogen, so it won't give Cannizzaro. What about this one? This is the aldehyde group, so this is the alpha carbon. See, no alpha hydrogen. See, this is the main functional group, so this is alpha carbon. See, there is no alpha means alpha hydrogen. Here no alpha hydrogen. So main functional group is aldehyde. Aldehyde connected carbon is called alpha carbon. And alpha carbon containing hydrogens are called what? Alpha hydrogen. So Cannizzaro reaction not given means they contain alpha hydrogen. That is option 4. Which product is formed when the compound benzaldehyde is treated with a concentrated aqueous KOH? What is benzaldehyde? Benzaldehyde, benzene with the CHO. Benzaldehyde react with which one? Concentrated KOH. Can you identify which reaction is this, my dear? We discussed in class. This is called our Cannizzaro reaction. Because Cannizzaro reaction, the compound do not contain alpha hydrogen. Yes, benzaldehyde, no alpha hydrogen, and base is concentrated. We know what happened. Cannizzaro reaction means the reaction between two same species, right? So let me take one benzaldehyde plus one another benzaldehyde. How to write the product in Cannizzaro? One compound, write it as its alcohol. So benzaldehyde will become benzyl alcohol plus the other compound, write it as which is base is using here K, right? So the second compound, write it as the corresponding potassium salt of acid. So we can write it as what? Cook, right? So where is this? Where is this COOK and CH2OH? That is option 2 is the answer. So how to write Cannizzaro? How you understand that it's Cannizzaro? Base is concentrated and the compound do not contain alpha hydrogen. So we can treat one compound, convert into its corresponding alcohol, which means CHO, make it CH2OH. The other one becomes CHO, becomes acid actually, COO, but potassium or sodium if there, that will replace the hydrogen. So you will get Cook or COONA if it is NaOH. So answer is which one? That is the same example we discussed in Cannizzaro as an example. Study all of you. So the answer is this option 2. Next one. Structure of A and type of isomerism in the above reaction are respectively. Structure of A. Okay, let us check it. What is this reaction, my dear? It is an alkyne to which they are adding mercuric sulfate. So it's an addition of water. So let's try. So the compound is CH3C triple bond CH, to which when you add water in presence of mercuric sulfate and H2SO4, H2O contain H plus and OH minus. It follow Marconi-Kos rule. So H here, you will get CH3, COH, double bond CH2. We will get a compound called enol. It will undergo tautomerism. They said which isomerism, right? We know enol undergo which isomerism? Enol undergo tautomerism. And what happened? This hydrogen reached here. You will get CH3, COCH3. You will get propanol. Yes, ready. So question. Structure of A. What is the structure of A, my dear? What is the name of this compound A? You know, alkene is there, alcohol is there. Let me put 1, 2, 3 here. So 2, we can say that total 3 carbon, right? Proper first position alkene. So proper 1 ene and second position alcohol. That's a IUPAC name. So proper 1 ene, 2 ol, and the isomerism is what? Tautomerism. So proper 1 N 2 ol. Option 4 correct, my dear. Okay, proper 1 N. Yeah, proper double bond is there. Alcohol is the main priority group. So I am starting from here. 1, 2, 3. Total 3 carbon. Therefore proper first position alkene, second position alcohol. Proper 1 in 2 ol. And what is the isomerism? That is tautomerism. Ready. Next one. Compound A and C in the following reactions are. So let me take the first compound. What is the first compound? CH3CHO, ethanol. What happened? Ethanol react with the methyl magnesium bromide along with the H2O. I'm writing product directly, my dear. How to write the product directly? To an aldehyde, when you add Grignard reagent followed by hydrolysis, very simple. Take the alkyl group from the Grignard reagent, put it on this carbon. And finally, the O become OH. Okay, the O become OH. Finish. So both of the steps I am doing together. So I will get CH3, CH. Now the new CH3. Okay, and now this O becomes what? OH. This is what happened after this step. So this is the compound A. This compound A, they are heating with the H2SO4. You know, H2SO4, when you are heating with an alcohol, it undergo dehydration. What is dehydration? OH take from alpha, hydrogen take from beta, put a double bond here. You will get propene. Right? We will get propene. Okay. This is your compound B. Now, propene when undergo hydroboration oxidation, we studied in alcohol chapter where propene become what? Propanol. Right? Propene become what? Propanol. CH3CH2OH. So what is this compound, my dear? This is propan 2-ol, right? This is compound A is propan 2-ol and compound C is which one? Propan 1-ol, right? Propan 1-ol. So question, compound A and C. Compound A and C show which isomerism? See, propan 2-ol and propan 1-ol shows which isomerism? That calls what? Position isomerism, right? Positional. See, propan 2-ol and propan 1-ol, their position of the alcohol group is different. So it will show which one? Positional isomerism. Okay, clear? Which is the most suitable reagent for the following conversion? Analyze the reaction. There is nothing happened to the double bond, right? Nothing happened to the double bond, but here ketone converted to what? Carboxylic acid. Ketone converted to carboxylic acid. So it should be a what? A strong oxidizing agent. Tolerance reagent, you know, it react only with aldehyde, so it is not possible. Benzoyl peroxide no needed. Peroxide effect is no needed here. I2 with the NaOHN solution. Yes, I will go with the 3. What is this I2 and NaOH? That is our iodoform test. Iodoform test. What is iodoform test? Let me tell you. CH3, CH double bond, CH single bond. CH2, CO, CH3, right? You know, iodoform test means, you know, we discussed that in order to give iodoform test, it should contain CH3CO group. Yes, it is there. So let me react with the I2 and NaOHN once you heated. We discussed detail in our class. During iodoform test, you will get total 4 products where 3 of them are always common. What are the 3 common? Iodoform, NaI and H2O. One is different. They're asking here. See, among the CH3CO group, this carbon becomes CHI3. So, what is left? The left overall become a acid. Left part or remaining all becomes an acid. So, it becomes CH2COO. And if it is sodium is there, okay, sodium salts will be there. Basically, it becomes a carboxylic acid. That's what they given there. So, this is our iodoform test, my dear. So, in the how to write iodoform product is very simple. Among the COCH3, the CH3 part becomes CHI3. Remaining the entire part, write it as the acid. That's it. If sodium is there, sodium replace the hydrogen. That's it. Okay. Next one. Which of the following compound will give butanol on oxidation with the alkaline KMNO4 solution? We know butanol is a ketone. If you want ketone by oxidation, it should be a secondary alcohol. secondary alcohol on oxidation, we will get a ketone. Butanol is a primary alcohol, butan-2-ol is a secondary alcohol. Yes. Check it all. Is it butan-2-ol? Yes. Butan-2-ol on oxidation. What happened? Oxidation means removal of hydrogen. It becomes what? Butan-2-on. Right. So remember, this is the point. Secondary alcohol on oxidation, you will get ketone. Alkaline KMNO4 is an oxidizing agent. Ready. In Clemmensen reduction, what is Clemmensen reduction? Aldehydes or ketone react with the zinc amalgam and HCl. We'll get hydrocarbon. In Clemmensen reduction, carbonyl compound is treated with what? Zinc amalgam and HCl. Zinc amalgam and HCl. We are using what? Zinc, ZnHg, right? Zinc amalgam, right? We are using zinc amalgam and HCl is the reagent. Okay, next. When acetaldehyde, what is acetaldehyde? Acetaldehyde is CH3CHO. Ethanol is also called acetaldehyde. Acetaldehyde is heated with a Fehling solution. What is Fehling solution overall? CuO, copper oxide. Along with a base, when you heat it, aldehyde become carboxylic acid. And what happened to CuO? CuO become Cu2O, cuprous oxide, reddish brown color. So the question, when acetaldehyde treated with a Fehling solution, it gives a red precipitate of what? Cu2O, cuprous oxide. Oxidation of cyclohexene. What is cyclohexene? This is what we call cyclohexene, right? Cyclohexene. Using acidified KMNO4. Dear all, KMNO4 is a very strong oxidizing agent. So whenever we are treating an alkene with a KMNO4, this is the way. Break the double bond. See this, both of these carbon become carboxylic acid. So what is this? C becomes COOH. And what is this? CH2. Next to CH2. Here also CH2. Here also CH2. Here is COOH. Right? This compound is called adipic acid. Remember all of you? Adipic acid. Short form, let me write. One acid in between 4 CH2 group. This is called what? Adipic acid. 2 carboxylic acid, middle CH2 4 time is called what? Adipic acid. So remember, cyclohexene on strong oxidation, double bond break, you will get 2 carboxylic acid. That product is called adipic acid. Option A is the answer. Next, which of the following order of relative strength of acid is correct? Which order of acidity is correct? My dear, analyze the compound. Here one is given chlorine, one is given fluorine, one is given bromine. They are withdrawing group. Halogens are withdrawing group. Which is the most stronger withdrawing group where more acidity? Which is the most strong withdrawing group? Fluorine, then chlorine, then bromine. So we can say fluorine 1 is greatest, then chlorine, then bromine. So that's option D. Which is the most suitable reagent for this conversion? What is this conversion, my dear? That's already we discussed the same question. Here you see double bond, nothing happened. The ketone becomes carboxylic acid. That should be our iodoform test. Where is iodoform? I2 and NaOH solution. Okay? So the same one question we discussed. The formation of cyanohydrin from a ketone is an example of. What is that? When a aldehyde or ketone treated with a hydrogen cyanide, the product what we call it as cyanohydrin. We discussed under which topic? Hydrogen cyanide addition is called which one? Nucleophilic addition reaction. Nucleophilic addition reaction. Okay, remember, addition of hydrogen cyanide is a nucleophilic addition reaction. Next, which aldehyde will give Cannizzaro reaction? If it want to give Cannizzaro reaction, alpha hydrogen should not be there. So see this aldehyde connected carbon is alpha. Yes, it contains alpha hydrogen. So it cannot give. This is the aldehyde and this is actually CH2. Okay. This aldehyde, yeah, this already alpha hydrogen is there. Check it. Option C is our answer. What is option C? C connected to 3CH3 group, right? C connected to 3CH3 group. Okay. And it contains which one? CHO. Yes. Check it all. Here aldehyde is the main group. Main group connected carbon is called what? Alpha. Alpha carbon contain hydrogen, what we call alpha hydrogen. Yes, see, there is no alpha hydrogen. So it can give what? Cannizzaro reaction. Option C is the correct answer. Carboxylic acids are more acidic than phenol and alcohol because, let me take a carboxylic acid, for example, benzoic acid, and let me take a phenol. Why carboxylic acids are more acidic always than phenol? When carboxylic acid lose H plus ion, we are getting carboxylate ion. When phenol lose H plus ion, we are getting phenoxide ion. This carboxylate ion is more stable than phenoxide ion. Because here, when you're drawing the resonance structure of this one, the oxygen carry negative charge. That is more favorable. Remember, carboxylic acid when lose hydrogen, you will get carboxylate ion. Phenol when lose hydrogen, you will get phenoxide ion. Where carboxylate ion is more stable than phenoxide ion. So, carboxylic acids are ready to lose H plus ion. So, therefore, the main answer we can call it as option C, resonance stabilization of their conjugate base. What do you mean by conjugate base? When this one lose this H plus, remaining compound what we call the conjugate base, it is highly stable due to resonance. Therefore, carboxylic acids are more acidic than phenol. Propionic acid with the bromine. What is propionic acid? CH3, CH2, COOH, right? Propionic acid react with the bromine in presence of red phosphorus. Can you identify which reaction is this? This is our HVZ reaction, Haloalkanes-Haloarenes reaction. Where this bromine get added, right? We have to remove one alpha hydrogen, put bromine on this place. But they were asking you a dibromo product. Dibromo means you have to remove 2 hydrogen and put 2 bromine. So, always in HVZ reaction, you should remove alpha hydrogen. This is alpha carbon. So, these 2 are alpha hydrogen. Remove these 2 alpha hydrogen, put 2 Br there. So, you will get CH3, C, Br, and then we have what? COOH. This is the product. Where is this? That is option D. CH3, C, yes, C, Br2 and COH. Okay. So, whenever there is a carboxylic acid which contain alpha hydrogen, react with the bromine or chlorine with the red phosphorus, you will get what? Alpha position halogen comes by removing hydrogen. Here they need dibromo. Dibromo means you have to take 2 hydrogen and put 2 Br. Clear? Next one. The reaction in which hydrocarbons are formed when aldehydes and ketone are reduced with amalgamated zinc. Zinc amalgam means which reaction? Clemmensen reduction and HCl. Clemmensen reduction, right? Clemmensen reduction. Zinc amalgam means Clemmensen reduction. Next up. Which of the following method cannot produce aldehyde? Cannot produce aldehyde. Many methods we studied preparation of aldehyde. Oxidation of primary. Yes, primary alcohol on oxidation we get aldehyde. Dehydrogenation. What do you mean by dehydrogenation? Removal of hydrogen, or also you can call it as oxidation. So dehydrogenation means oxidation, okay, because dehydrogenation means removal of oxygen. Removal of oxygen is called oxidation. Oxidation of secondary alcohol, no. Oxidation of primary alcohol give you aldehyde. Oxidation of secondary alcohol give you what? Ketone. This is not a method. So option B. Yes, alkenes on ozonolysis we will get aldehyde. Hydration of ethine, yes, also that we will get. So secondary alcohol on oxidation, you will get ketone, not aldehyde. So B is not a method. 25. Which of the following reaction can produce ketone? Can produce a ketone? That same question. Oxidation of primary alcohol give you aldehyde, no ketone. Dehydrogenation means what? Oxidation. Oxidation of primary. They see, they're making confusion. Oxidation and dehydrogenation meaning same, okay. Dehydrogenation of tertiary alcohol, no. Oxidation of secondary alcohol, yes. Oxidation of secondary alcohol give you what? Ketone. Question number 26. Conversion of propine to acetone require 3 important reagents. Identify which of the following is not one of the 3. What is this reaction actually? Propine. Propine is this one. Alkyne to a ketone they were asking. Alkyne to ketone. Yeah, that is our addition of water in presence of mercuric sulfate and H2SO4. First Markovnikov's addition, then you will get enol, then it undergo tautomerism, you will get aldehyde or ketone. So they were asking, so which all reagents you need in this reaction? water you needed, mercuric sulfate, sulfuric acid, everything you needed except which one? Zinc dust. So they are basically asking whether you know the reaction completely or not. Okay. Next, what is the catalyst used in the hydrogenation of acetyl chloride to produce ethanol? What is acetyl chloride? Acetyl chloride is CH3COCl. Ethanoyl chloride is also called acetyl chloride. This acetyl chloride, if you want to convert it into ethanol, which reagent we are using? My dear, can you tell me which reaction is this? This is our Rosenmunder reduction, first name reaction. Acid chloride when react with a hydrogen in presence of palladium and barium sulfate. One HCl go, you will get CHO. Preparation of aldehyde from acid chloride by addition of hydrogen and palladium and barium sulfate. Palladium over barium sulfate. Palladium over barium sulfate is called what? Rosenmunder reduction. Okay, palladium and barium sulfate. Which of the following carbonyl compound can be prepared from Rosenmunder reduction? Same question. Which one you can prepare? Which one carbonyl compound can be prepared? Okay. Methanol, acetone. You know, ketones cannot prepare by Rosenmund. Rosenmund is used to prepare aldehydes. Methanol. What is methanol? Methanol is not possible, my dear. At least one carbon should be here. Benzaldehyde is possible. Let me take you benzoyl chloride. Benzoyl. This is benzoyl chloride. When you react with the hydrogen in presence of palladium and barium sulfate, what happened? One HCl go, one H come to this side. Yes, you will get benzaldehyde, my dear. So option D is possible. Option D is only possible. Which of the following is required in Stephen reaction? What is Stephen reaction? Cyanide when you treated with a stannous chloride, right? What is stannous chloride? SnCl2 along with HCl. First you will get imine. Imine on hydrolysis you will get what? Aldehydes. So which of the following is required? That is our stannous chloride SnCl2 is what required. That's called Stephen reaction. Next one. Which of the following compound helps in reducing ester to aldehyde? My dear, under Stephen reaction we studied one topic. If you want to convert a cyanide into aldehyde, we have an alternate reagent other than Stephen reaction, that is called dibal H. Can anyone say, can anyone remember what is the full form of dibal H? Diisobutyl aluminium hydride. This reagent we are using to convert cyanide to aldehyde. Even a ester also you can convert it to aldehyde by dibal H. So, in order to convert an ester into aldehyde, what we can use? Dibal H. I think that is the only one compound we know from this one, right? Okay, dibal H. Identify X in the following reaction. What identify X in the following reaction? Can you identify which reaction is this? See, toluene converted to benzaldehyde. Three methods we studied. One is Ittard reaction. One is treating with which one? CrO3. And one is with a side chain chlorination. Which reaction is this? With a carbon disulfide and all. This is our Ittard reaction. This is our Ittard reaction. Remember, toluene first treated with a CrO2Cl2 along with the CS2. That is called what? Chromyl chloride. Where is CrO2Cl2? This one. This is our Ittard reaction. Okay, remember, to study the theory, you can say, toluene when react with the chromyl chloride CrO2Cl2 along with the CS2, first you will get a chromium complex, right? A big chromium complex. That's on hydrolysis you will get benzaldehyde. So the compound is chromyl chloride. Acetyl chloride, again. What is acetyl chloride? CH3COCl. Acetyl chloride react with something to give butan 2-on. What is that? Butan 2-on. Okay, what is butan 2-on? This is butan 2-on. Check it all. This is a acid chloride, right? From acid chloride, how we prepared a ketone? Can you remember the method of preparation? Acid chloride, how to convert into ketone? We studied by treated with a dialkyl cadmium. Dialkyl cadmium. When acid chloride react with the dialkyl cadmium, we can get ketone. So where is that? Which one? Okay, I will go with. Okay, see this part already there in this one. So eth is needed. So eth is we needed extra. So let me go with the diethyl cadmium. What is diethyl cadmium? C2H5 twice CD. What is this process? Very simple. CD go with the Cl as CdCl2. So CH3CO will combine with the C2H5. Yes, that's a product. Remember, if you want to prepare a ketone from an acid chloride, react with a dialkyl cadmium. Okay, so diethyl cadmium. What is formed after the hydrolysis of the product of the reaction between benzonitrile? What is benzonitrile? Benzonitrile means this one. Let me write here. Benzonitrile means benzene with a cyanide. This is called benzonitrile. And a methyl magnesium bromide, CH3MgBr, Grignard reagent. You know, Grignard reagent when react with the cyanide, the product is a ketone. So how the mechanism we discussed in class, the alkyl group attack on carbon and N become N minus. So we will get benzene with the C double bond N, to the C already attack CH3, N become N minus, to the N minus this Mg plus Br will attack. Finally, very simple, H2O while you adding, you know, just remember simple, cut the C double bond, put this oxygen on carbon, H2 on nitrogen. So you will get benzene with the what? C double bond OCH3. What is benzene with the COCH3? We call acetophenone. What is the product called? Acetophenone. Yes, option B. So remember all, cyanide when react with the Grignard reagent, we will get a adduct. That's on hydrolysis, you will get a ketone. Okay, next one. Friedel-Crafts benzoylation of benzene give. What is benzoylation mean? Benzene treat with a benzoyl chloride. Benzene treat with what? What is this? Benzene. What is this? Benzoyl chloride. What is Friedel-Crafts acylation? Means anhydrous AlCl3. What happened? This group come to our benzene ring. You will get benzene with the CO and one more benzene ring. This is called what? Benzophenone. What is called? Benzophenone. So, benzene when undergo reaction with the benzoyl chloride, it like same like our Friedel-Crafts acylation. This is called benzoylation and you will get benzophenone. 35. Identify the reagent for the conversion of butadiene to ethanol. See, butadiene is what? An alkene. Alkene to aldehyde. Alkene to aldehyde is ozonolysis. What is ozonolysis? Adding ozone, then zinc and water. Option A, finish. See the conversion. Alkene, if you want to convert into aldehyde or ketone, reaction is ozonolysis. Next. Which of the following reaction does not give benzaldehyde? Does not give benzaldehyde. Rosenmund reaction, yes, it can give, already discussed. Ittard reaction, yes, that purposefully to make benzaldehyde. Getterman-Koch reaction, yes, that is to benzene to benzaldehyde. Friedel-Crafts acylation, no. Friedel-Crafts acylation will give you mostly ketones. Friedel-Crafts acylation cannot give benzaldehyde. Ester is formed by a reaction between what? They are all esterification. Ester is formed by the combination of one acid and one alcohol. One acid and an alcohol. Ester is formed by a reaction between acid and alcohol. Aldehydes and ketone undergoes dash reaction. Both aldehydes and ketone can undergo what? Nucleophilic addition reaction. That's only we discussed in classes. Nucleophilic addition reaction, right? Because both of them contain which group? Carbonyl group. So nucleophile can easily attack here. Next. What is the correct order of the reactivity of the following toward nucleophilic addition? Again, what is methanol? Methanol is HCHO. What is ethanol? Ethanol is CH3CHO. What is acetone? Acetone is CH3COCH3. That is what acetone. So my dear, if you consider that A, B, C, we know aldehydes are more reactive toward nucleophilic addition. And where aldehyde were less bulky group, were more reaction. So here you see small group, here you see bulky group. So A is more reactive, then B and then ketone. So let's go with option A itself. Methanol, ethanol and acetone. Ready. What is the correct order of the reactivity? Again. See, benzaldehyde. What is benzaldehyde? Benzene with the CHO. Benzophenone. What is benzophenone? Benzophenone means benzene with the CO and one more benzene ring. Benzophenone. What is acetophenone? Acetophenone is benzene with COCH3 is called acetophenone. Ready, my dear? You know, aldehydes are more reactive. So this is aldehyde. So it's more reactive. These are ketone. Among these two ketone, which is more reactive, I will go with this because it's small bulky, LS big bulky group. Here both are big bulky groups. So first one benzaldehyde, then acetophenone, then benzophenone. So benzaldehyde, acetophenone, benzophenone, that is option D can be tried. Which of the following is the most reactive toward hydrogen cyanide, HCN? My dear, where we studied hydrogen cyanide addition, that is also nucleophilic addition. Indirectly they are asking you. So which will undergo HCN addition faster and all means they are asking you which will undergo nucleophilic addition faster. So most reactive, right? So acetophenone, I am just writing. Let me just do one thing. Ketone you cut first. Acetophenone is a ketone. That's all. Okay. Remaining are benzaldehyde. What? Okay. Benzaldehyde is there. Next para-nitrobenzaldehyde is there. Para-nitro. Next para-tolualdehyde. What is meant by tolualdehyde? Aldehyde with the toluene. Okay. Here you see all are aldehyde. Only what is the difference? You have a electron withdrawing group, right? You know, nitro group is a electron withdrawing group. Alkyl groups are electron donating group, which will increase the nucleophilic addition. Remember all of you, withdrawing group. Because if there is a withdrawing group, they will withdraw the electron, make this carbon more positive. So nucleophile can attack easier. So remember, electron withdrawing group increase the nucleophilic addition faster. So I will go with the para-nitrobenzaldehyde. Now the hydrolysis of the addition product of acetone and methyl magnesium. What is acetone? CH3COCH3. Okay. Acetone, they are addition with the what? Methyl magnesium iodide. Hydrolysis of the product formed by this. So secondly, they are hydrolyzing. What is this? I told you how to write the product in detail. This is Grignard reagent. Grignard reagent contain Mg plus and alkyl minus. This alkyl definitely attack on this carbon. Finally, the O become OH. Finish. Okay. So the alkyl group from the Grignard reagent put it on this carbon and O finally make it OH. Finish. So what is the product? CH3, COH and then CH3 and one more CH3. What is this compound is called? What is this compound is called? This is called, what is this group? Tert-butyl. So this compound is called what? Tert-butyl alcohol. Okay. Option C, tert-butyl alcohol. The following is an addition product of the reaction between dash and sodium bisulfite. What is sodium bisulfite? That is our NaHSO3 addition. If you want to get this one, CH3CH, this is the contribution from our compound. These are getting through the reaction. So let me tell you one thing. Let me try this one. Okay, CH3, CH3COH. What is this aldehyde? Ethanol. Because I took this CH3 and H. This is the main part, the aldehyde or ketone. So CH3COH when react with the NaHSO3. Okay, let me write it for understanding. I'm writing this compound as CH3COH. What is this aldehyde? Ethanol. Plus sodium hydrogen sulfide, that's a sodium bisulfite, let me add. You know, sodium bisulfite contain Na plus and HSO3. So HSO3 will attack on this carbon, O become O minus. To the O minus, this Na will attack. You will get CH3, CH and O becomes what? ONA. You know, HSO3 directly please don't write. HSO3, how you should write? OSO2H, because from HSO3, oxygen is the one making bond. Okay, and what happened? The sodium and hydrogen ions can switch it. You will get CH3, CH and OH and OSO2Na. Yeah. So if you want to get this product, you just analyze about this part. Yes, CH3CH. So that is getting from which aldehyde? Ethanol. So where is ethanol? Ethanol is what? Acetaldehyde. So when acetaldehyde react with the sodium hydrogen sulfite or sodium bisulfite, you will get this product. Now the following acetal, we studied now what is acetal. What is acetal? When an aldehyde react with the alcohol, we get acetal, hemiacetal first. Again when it react with the one more alcohol, you will get acetal. So the following acetal shown is formed by the reaction between dash and dash in the presence of dry HCl. My dear, so you analyze about this compound. That's again very clear. What is this compound? Ethanol. Okay. So this compound is what? Ethanol. So let me write the product here. CH3COH. That is ethanol. This one, let me react with, this is the alcohol. So 2 carbon is coming means the ethanol they are adding. What is ethanol? CH3CH2OH. You know very well, in CH3, in alcohol, what is the ions you have? You have the ions like, we can write it as, if you're writing ROH, you know, R plus and OH minus, right? Similarly, you have CH3, CH2 plus and OH minus. So OH is the nucleophile. They will attack on carbon, O become O minus. To the O minus, CH2, CH3 will attack. So you will get CH3, CH, then who is attacking here? OH. Then who is coming to this side? To this one, you are getting OCH2, CH3. Okay. This is called hemiacetal. This again, when you treat it with one more alcohol, CH3, CH2OH, one OH and H water you cut, you will get CH3, CH, then OCH2, CH3. Again, here OCH2, CH3, we will get it. It's a reversible reaction. And this is called hemiacetal, and this product is called what? Acetal. So question, what we need to treat it? That's no doubt ethanol, not ethanol and ethanol. What can we write? Yeah. First compound is, this is ethanol, to which what you are adding? Ethanol, right? Ethanol and ethanol, right? Ethanol and ethanol. So the following acetal is shown by the formation reaction between ethanol and ethanol. Yes, you will get this product. So where we studied this all reaction under nucleophilic addition. Okay, my dear student, listen carefully. Next one, acetone. What is acetone? Acetone is nothing but propanol. Acetone react with the ethylene glycol. What is ethylene glycol? Let me write acetone in another way. CH3COCH3. This is called what? Acetone. What is ethylene glycol? OH, CH2, CH2OH. Hope you remember. It's undergo a cyclic formation. This H2O we cut. We get CH3, CCH3, O, CH2, CH2, O. You'll get this ketol. What do you get? Ketol. You will get cyclic ketol. Ketone, when react with the ethylene glycol, the product is called what? Ethylene glycol ketol. Ketol. Okay. Which of the following product is formed when an aldehyde react with an amine in acidic medium? That's what we discussed. For example, aldehyde. Aldehyde is what? CHO. And amine. Amine means RNH2, which contain NH2 group. We studied aldehyde and ketone, how it behave with the ammonia derivative. Just O and this H2 cut. You will get RCH double bond NR. This is called a Schiff's base. What we call? Schiff's base. So my dear, aldehydes when react with the amines, the product, the addition product, what we call? Schiff's base. The oxidation of toluene to benzaldehyde by chromyl chloride is called Ittard reaction, right? Ittard. What is chromyl chloride? CrO2Cl2. Toluene we can convert it to benzaldehyde by treating chromyl chloride is called what? Ittard reaction. Aldehyde other than formaldehyde when react. We studied that theory like this one in alcohol chapter. Grignard reagent when you treated with methanol. What is methanol is also called? Methanol is also called what? Formaldehyde. Formaldehyde, you get always primary alcohol. Any Grignard reagent when you treated with other aldehydes. Other aldehydes mean except methanol, you will get secondary alcohol. Any Grignard reagent when you treated with any ketone, you will get always tertiary alcohol. We already studied in alcohol chapter. So here, aldehyde other than formaldehyde when react with the Grignard reagent to give an addition product, which on hydrolysis give you, which alcohol? Secondary alcohol. You will get secondary alcohol. Which of the following will not give aldol condensation? My dear, in order to give aldol condensation, alpha hydrogen should be there. Which do not give aldol condensation mean no alpha hydrogen. Where there is no alpha hydrogen, you can say benzaldehyde. Check it all the remaining option, okay? You see benzaldehyde is this one, right? Benzaldehyde is this one, which is the alpha carbon, aldehyde connected carbon is alpha. See, this not contain any hydrogen. So it do not contain alpha hydrogen, so it cannot undergo aldol condensation, because in order to undergo aldol condensation, alpha hydrogen should be there. Okay. Benzoyl chloride. What is benzoyl chloride? Benzene with COCl. Benzoyl chloride on reaction with the hydrogen and palladium and barium sulfate. Which is this reaction? Our Rosenmund reduction. What is Rosenmund? One H and Cl cut it. You can make it as benzene with the what? COH. Benzaldehyde. You will get benzaldehyde. Okay. Benzoyl chloride on reaction with the hydrogen in palladium and barium sulfate will give you what? Benzaldehyde. Our Rosenmund reduction. What is a test to differentiate between pentan 2-on and pentan 3-on? You know, pentan 2-on we can write like this, right? This is the structure of pentan 2-on and this is the structure of pentan 3-on. Ready? Which test can be used to distinguish between them? I will go with the iodoform test, because iodoform test is given by the aldehydes and ketone which contain this group. See, this group is there in pentan 2-on, not there in pentan 3-on. You know, iodoform color is yellow color. So this will give yellow color, this won't give yellow color. So I will go with which one? Iodoform test. Let's go with iodoform test. Which of the following does not undergo Cannizzaro? Does not undergo Cannizzaro means they contain alpha hydrogen. They contain alpha hydrogen. Benzaldehyde, no alpha hydrogen. 2-methyl propanol, paramethoxy benzaldehyde, 2,2-dimethyl propanol. I'm just trying. You try the structure, okay. The condition is what? Alpha hydrogen does not undergo Cannizzaro means alpha hydrogen should be there. Cannizzaro, you know, Cannizzaro reaction mean no alpha hydrogen. No alpha hydrogen mean it can undergo Cannizzaro reaction. Here they're asking they do not undergo means they contain what? Alpha hydrogen. Okay. So let me try B, C. Okay. Anyway, benzaldehyde do not contain alpha hydrogen. Cut it. B, C and B and D. Let us try. What is B? 2-methyl propanol. 2-methyl propanol. Okay. Check it all. Is it contain alpha hydrogen? Yes. See, this is the aldehyde. This is the alpha carbon. Yes, it contain alpha hydrogen. If it contain alpha hydrogen, they do not undergo Cannizzaro. So B can be. What about D? 2,2-dimethyl propanol. This is propanol. 2,2-dimethyl. Yes. See, on this carbon, no alpha hydrogen. Okay. So remember all. Finally, in order to undergo aldol condensation, alpha hydrogen should be there. In order to undergo Cannizzaro reaction, alpha hydrogen should not be there. So here they are asking which do not undergo Cannizzaro means they contain alpha hydrogen. That is option B. Which among the following is most reactive towards nucleophilic addition again? See, this all are same carbon number, only difference fluorine, chlorine, bromine, iodine. I told you that electron withdrawing group will increase the reactivity. Which is the most withdrawing group? Fluorine. So let's go with option A. More the strong withdrawing group, easily it can undergo nucleophilic addition. The IUPAC name of this compound. What is this compound? CH3, CO, CH, on which CH3 and CH3. What is the IUPAC name of this compound? Ketone is the main group here. So 1, 2, 3, 4. So 3-methyl butan 2-on. 3-methyl 2-butanone. Ready? 3-methyl butan 2-on. What is the IUPAC name of ethyl isopropyl ketone? What is ethyl? CH3, CH2. What is isopropyl? One CH connected to 2 CH3 is called isopropyl on a ketone. Ready? This is the compound. So how to number it? Ketone is in the middle. So let me start 1, 2, 3, 4, 5. 2-methyl pentan 3-on. 2-methyl penta 3-on. Let's go with option B. 2-methyl penta 3-on. Ready? The catalyst used in Rosenmund reduction. What is the catalyst in Rosenmund reduction? Palladium and barium sulfate. Acetone react with the iodine. What is acetone? CH3, CO, CH3. Remember this name, okay? Acetone is nothing but propanol. Acetone reacting with the iodine to form iodoform. So iodine, if it want to give NaOH also should be there. Heat. It's giving iodoform in the presence of. Okay, that's they're asking. Okay. In order to give iodoform test along with iodine, what should be there? NaOH should be there. Aldehydes and ketone are distinguished by which of the following tests? Aldehyde and ketone. Lucas test, you know, it is for alcohol, not that. Tolerance test, yes, tolerance test is given by only aldehyde, it is not given by ketone. So that is the distinguishing test. Okay, question, what is the product D in the last product they are asking? Let us start. Acid is given, CH3COOH is given, ethanoic acid. You know, ethanoic acid treated with a thionyl chloride. What happened? Acid treated with a thionyl chloride. OH remove, put chlorine. It become acid chloride. It become acetyl chloride. This on reaction with the benzene in presence of anhydrous AlCl3. That is our Friedel-Crafts acylation. So this group, put it on benzene ring. You will get benzene with the COCH3. You are getting acetophenone. Acetophenone, when react with the hydrogen cyanide, it undergo nucleophilic addition. How nucleophile add? H plus is there, Cn is there. You know, nucleophile will attack on carbon, O become O minus. To the O minus, this H plus will attack. You will get benzene with C, CH3, Cn and OH. Cyanohydrine. You know, any aldehyde or ketone react with the hydrogen cyanide. What is the product is called cyanohydrine. Note over, it's on HOH. HOH is nothing but hydrolysis. You know, cyanide on hydrolysis, it will give you what? Carboxylic acid. So we can write that benzene with COH, COOH and CH3. This is the compound D, where it is benzene, carbon, one CH3, one COH and one OH, right? That's option D. So once again, all of you, acid when react with the thionyl chloride or PCl3 or PCl5, it will give you what? Acid chloride. Acid chloride when react with the benzene in anhydrous AlCl3, Friedel-Crafts acylation, we are getting acetophenone. Ketone when react with the HCN, the product is called cyanohydrine. Cyanide on hydrolysis will give you what? Carboxylic acid. Product correct, right? Okay. No problem. Okay, fine. Next one. Which of the following reaction will not result in the formation of carbon-carbon bond? In through which reaction carbon-carbon bond is not forming? Good question. Friedel-Crafts acylation. Friedel-Crafts acylation. You just check it. This is Friedel-Crafts acylation. Here you see this carbon and this carbon is making a bond, right? That's a bond is there. Woods reaction, of course, Woods reaction means two alkyl groups are joining. Carbon-carbon bond is there. Cannizzaro reaction, yes. Cannizzaro reaction and Riemer-Tiemann reaction. Riemer-Tiemann we already studied in alcohol chapter. Which one? Phenol to salicyl aldehyde. There is a carbon-carbon bond. Cannizzaro. Cannizzaro reaction means what, my dear? We discussed now one example. Benzaldehyde react with the benzaldehyde in presence of a concentrated base. What happened? One compound convert to its corresponding alcohol and the other compound convert into corresponding carboxylic acid, but the potassium comes here. So here is one compound converted to some other, where there is no carbon-carbon bond formation. So remember, in Cannizzaro reaction there is no carbon-carbon bond formation. In the following sequence of reaction, what is the final product is Z? What is this? Ethine when react with the mercury. Mercury means addition of water in presence of what? HgSO4. You know, water contain two ion, H plus and OH minus. Since it is a symmetrical compound, add H plus to one carbon, OH to one carbon. You will get CH, OH, double bond, CH2, enol. This enol undergo which isomerism? Tautomerism. So what happened? This hydrogen shift to this. Overall you will get CHO and CH2, CH3. What is this? CH3, CHO, what we call? Ethanol. So product is what? Ethanol. Not over. Sorry, not over. This is Hexa and this compound they are treating with the what? Methyl magnesium. Okay. So this one they are treating with the methyl magnesium halide with what? Hydrolysis. Already told you what happened. What happened? Grignard reagent, when you add to an aldehyde or ketone, very simple. Take the alkyl group from the Grignard reagent, put it on this carbon and O become OH. So we will get CH3. Then this CH3 and this and this O become OH and this CH3. It become propan-2-ol. Propan-2-ol when undergo oxidation. We know secondary alcohol on oxidation, what we get, my dear? You will get a ketone. What is this? Propan-2-on or propanol. So to an alkyne, when you add a water with a mercuric sulfate, you will get enol. Enol undergo tautomerism. You will get here aldehyde. Aldehyde, we already studied, my dear. Any Grignard reagent, when you treat it with other aldehydes, which means except methanol, you will get secondary alcohol. Secondary alcohol on oxidation, you will get a ketone. Ready? Which of the following does not answer iodoform test? In order to give iodoform test, if it is an alcohol, it should contain this group. If it is an aldehyde or ketone, it should contain this group. Which do not respond. N-butyl alcohol. Let me just draw the shape of this one. N-butyl alcohol means this is N-butyl alcohol. It do not contain that CH3, CHOH group, right? Let's go with option A. Sec-butyl. What is sec-butyl, you know? Sec-butyl means this is the one called the sec-butyl alcohol. See, it contains CH3, CHOH group, so it will give. What is acetophenone? Acetophenone means benzene with the COCH3. See, it contains that group. What is acetaldehyde? Acetaldehyde is CH3CHO. See, that contain that group. So N-butyl alcohol do not contain that particular group, so it do not give. An organic compound of molecular formula C3H6O did not give silver mirror test. You know, silver mirror test means our tolerance test, right? It does not respond to tolerance test, means it's a ketone. Okay, an organic compound of molecular formula. This is a ketone, very sure, because it do not give silver mirror test with the tolerance reagent, but it give an oxime with a hydroxylamine. What is hydroxylamine? NH2OH. You know, hydroxylamine reacting with the aldehydes and ketone. Already said there, they said that they do not give tolerance. So that means it's a ketone. Okay, what it can be? It should be a ketone. Where is a ketone? That is option B. That's it. Very simple. So dear all, it react with the hydroxylamine means, you know, hydroxylamine when react with an aldehyde or ketone, we get oxide. So it react with the hydroxylamine mean it can be an aldehyde or it can be a ketone. But it do not give with the tolerance test mean it's not an aldehyde, it's a ketone. Where is a ketone? That is option B. Propanol on treatment with a dilute. Propanol. What is propanol? CH3, CH2, CHO. Propanol on treatment with a dilute sodium hydroxide. Dear all, dilute NaOH means what? This is an aldehyde with alpha hydrogen. This is dilute base. This is our aldol condensation. Aldol condensation. What is aldol condensation? One aldehyde react with its own. Means the same one another aldehyde. Do you remember one shortcut method we studied how to write the aldol condensation product? From the second compound, take one alpha hydrogen, give to this oxygen and connect these two carbon. Finish. You will get CH3, CH2, CHOH. Now this carbon CH on which one CH3 is there, one CHO is there. This is the product. Yeah. Where is this product identified? CH3, CH2, CHOH. Not option A or option B. CH3, CH2, CHOH, CH3, CHO. Yes, option C is the correct answer. So how we understand it's an aldol condensation? Base is dilute and the reactant contain alpha hydrogen. So study all of you aldol condensation properly. Aldehydes that do not undergo aldol condensation. Do not undergo aldol condensation mean no alpha hydrogen in the compound. Propanol. Propanol is CH3, CH2, CHO. See, it contain alpha hydrogen. So one can be. Trichloroethanol. What is trichloroethanol? CCl3CHO. Trichloroethanol. Yes, this is the alpha carbon, no alpha hydrogen. No alpha hydrogen. So second can be. 2-phenyl ethanol. Ethanol means 2 carbon and second position aldehyde. 2-phenyl ethanol. This is the alpha carbon. It contain alpha hydrogen. Not. Ethanol. What is ethanol? CH3CHO. Yes, it contain alpha hydrogen. Benzaldehyde. Already we know it do not contain alpha hydrogen. So 1, 2, 5. 1, 2, 5 is not there. Question, aldehyde that do not undergo aldol condensation. Do not undergo aldol condensation means no alpha hydrogen. Benzaldehyde also no alpha hydrogen. So 1, 2, 5 should comes. Okay, my dear, I'm just correcting here. 1, 2, 5. Just to cross check it whether there is a mistake or not. Question. See, in order to give aldol condensation, alpha hydrogen should be there. So do not respond aldol condensation means aldehyde that do not undergo aldol condensation means there should not be any alpha hydrogen. Alpha hydrogen not present in. So this no alpha hydrogen, right? Sorry for that one. No alpha hydrogen, right? This one contain alpha hydrogen. Okay, not possible. This one do not contain alpha hydrogen, correct? And this one do not contain alpha hydrogen. This one contain. Benzaldehyde do not contain. 2 and 5. Yeah. 2 and 5. Yes. Option B is, sorry. So, in order to do not undergo aldol condensation means what? No alpha hydrogen. This one contain alpha hydrogen, right? Sorry. This one contain alpha hydrogen. This one alpha hydrogen. This one hydrogen. These two do not contain alpha hydrogen, right? Next. Which of the following compound will undergo Cannizzaro? Undergo Cannizzaro means no alpha hydrogen. Which one undergo aldo? This is what C. C is what? Benzaldehyde. Here all benzaldehyde do not contain alpha hydrogen. This is the alpha carbon. C, no alpha hydrogen. So, no alpha hydrogen means an undergo Cannizzaro. Match the following. Clemmensen reduction. What is Clemmensen reduction? Zinc amalgam and HCl. Rosenmund reduction, hydrogen with palladium and barium sulfate. That's enough, I think. A2B3. A2B3, where it is? A2B3C. Anyway, iodoform test mean iodine and NaOH, right? C with the C, right? C with the fourth one, okay. And Cannizzaro reaction mean concentrated base should be there. So D with the first one, correct. And the product X in the following reaction is, what is this? This is an aldehyde, this is an aldehyde, right? And base is NaOH. Whether it can undergo Cannizzaro reaction or aldol condensation. See, CHO, right? There is no alpha hydrogen here. While seeing the product, is very clear that it undergo Cannizzaro reaction. Cannizzaro reaction, what happened? One aldehyde become corresponding alcohol. The other side become its salt of acid. Sodium is the metal here. So COONA. Where is this? COONA and CH2OH. COONA and CH2OH. That's it. It's Cannizzaro reaction. So one aldehyde become corresponding. Simple. One CHO you made into CH2OH. Other CHO made into COONA. If it is NaOH, Na. If it is KOH, COOK. That's it. In a set of the given reaction, acetic acid yield a product C. What is the product C? Let's find. First reaction. Acetic acid when react with the PCl5. Acid when react with the PCl5, what happened to the OH? OH become Cl. This on react with the benzene and anhydrous. Friedel-Crafts acylation. Put this group, it is on benzene. So benzene, you will get benzene with the COCH3. This on treated with the grignard. Again grignard. What is grignard? Grignard Mg plus the alkyl group, you know. What is alkyl group? C2H5. Put the alkyl group on this carbonyl carbon. So C2H5 come to this carbon and O become OH. Done. So benzene with CCH3 and OH to this, who will attack? C2H5. That's it. Where is this product? CH3, C, C2H5, OH and C6H5. Option D will be the answer. Which of the following will not undergo HVZ? In order to undergo HVZ, Hell-Volhard-Zelinsky reaction, the carboxylic acid must contain alpha hydrogen. So do not undergo alpha hydrogen means, do not undergo HVZ reaction mean no alpha hydrogen in the compound. Propanoic acid means, you know, this one. Yes, it contain alpha hydrogen. So not that. Ethanoic acid is this one. It contain alpha hydrogen. 2-methyl propanoic acid. 2-methyl propanoic acid. Yes, it also contain alpha hydrogen. 2,2-dimethyl propanoic acid. See all? 2,2-dimethyl propanoic acid. See, this is the alpha carbon, no alpha hydrogen. So option D. Which of the following cannot reduce filling solution? Remember, filling solution is given by only aliphatic aldehydes. So aliphatic aldehydes, right? So formaldehyde is aliphatic, acetaldehyde is aliphatic, acetic acid is there. See, formic acid is what? HCOOH, right? Acetic acid is CH3COH, right? And formaldehyde is HCHO and acetaldehyde is CH3CHO. Remember all? Formaldehyde, so the fillings test is given by only aliphatic aldehydes, okay? So this is an aliphatic aldehyde. This aliphatic mean normal chains. Aliphatic, both are acid. But have you noticed in formic acid there is an aldehyde group. In formic acid there is a HCHO group or CHO group. So this is what a purely a carboxylic acid. So B is a carboxylic acid. So why not A? A is also a carboxylic acid, but they contain an aldehyde group. So it can give the rest. Option B is the answer. Which of the following acid do not form anhydride? Do not form anhydride. We discussed like this one. Carboxylic acid, when react with another carboxylic acid along with acid or heat or P2O5 and heat, it dehydrate, means water eliminate, you will get acid anhydride that we studied. So which one, acid anhydride means general formula we know RCOOCOR. I will go with the option, all are acid here, I will go with option A. What is formic acid? HCOOH. See, even HCOOH undergo reaction with one more HCOOH. Even if you remove water, will you get this formula? No, where you get alkyl group, there is no alkyl group in this acid, right? So formic acid cannot undergo or cannot give which one? Anhydride. Chromic acid, okay? Acid. Next. Methyl ketones are usually characterized through. What is mean by methyl ketone? Methyl is this, ketone is this. So methyl ketone can give which test? Iodoform test. So no, the aldehyde or ketone, they contain CH3CO group. That is called methyl ketone. That will give you iodoform test. HVZ reaction is used to prepare. During HVZ reaction, what's happening? We will take one hydrogen from the alpha position. We will place one halogen on that alpha carbon. So it will give you alpha halocarboxylic acid. Alpha halo acid. My dear, for example, this is the acid. Suppose you are treating bromine with the red phosphorus followed by hydrolysis. What to do in HVZ reaction? Take one alpha hydrogen, put that halogen on that. So you will get CH2Br and COOH. That is called alpha halo acid. Okay, alpha halo acid. An alkene C7H14. Okay, C7H14 is an alkene. Ready? It undergo reductive ozonolysis. Yes, it undergo ozonolysis. Gives an aldehyde with the formula C3H6O and a ketone also. What is the ketone formula? Very simple, dear all. Very simple. Very simple. Total how many carbon in this alkene? 7 carbon. Among that, 3 carbon goes to aldehyde. So where is the remaining 4 carbon? 4 carbon will be in a ketone. What is 4 carbon contain ketone here? It can be 2-butanone, right? Option A, 2-butanone. Is it correct or not? So 7 carbon total in the alkene. So if let me just try that compound. Okay, what it can be? C3H6. Okay, CH3, CH2, CH, double bond, C, CH3, CH2, CH. This will be the compound. Because 3 carbon this side, when how to make the breaking, right? Cut the double bond, 1 oxygen left, 1 oxygen right. This is the aldehyde, this is the ketone, CH3CO, CH2, CH3. See, aldehyde contain 3 carbon and the ketone contain total 4 carbon. That is what 2-butanone. Let's start. Benzaldehyde can be prepared by the hydrolysis of which compound? Benzaldehyde by the hydrolysis of which compound? I will go with the benzyl chloride. Do you remember? Do you remember? First we will treat toluene with which one? Chlorine in presence of light. What actually we said in class is one H remove, one chlorine. That's a side chain chlorination. You will get CH2Cl. This is called benzyl chloride. It's again react with the chlorine in presence of light. You will get benzyl chloride. This benzyl chloride on hydrolysis, you will get benzaldehyde. So what is a compound? Benzyl chloride on hydrolysis give you benzaldehyde. Which of the following acid has the smallest dissociation constant? Dissociation constant is called Ka. Ka value directly proportional to acidity we studied. Dissociation constant is what? Ka. Ka value increases mean acidity increases. So they were asking you smallest Ka value mean which is the least acidic they are asking. Least acidic is which one? See here fluorine is there on this carbon. Fluorine is a withdrawing group. You know withdrawing group make more acidity. Here also fluorine is there but little far away. Anyway they are very strong. Withdrawing group make more acidity. Here bromine is far away. Bromine is very close. So A and B are highly acidic because fluorine is there. Fluorine is more withdrawing group make more acidity. Your answer is either C or D, which is weakest acid. I will go with option C because here bromine is far away from acid. Here bromine is close to acid. So here its withdrawing power will be more. Here withdrawing power is less. So C is the answer. The most suitable reagent for the conversion. What is this? This is a primary alcohol to aldehyde. Which is the best reagent to convert a primary alcohol to aldehyde? PCC, pyridinium chlorochromate. Iodoform test is not given by. Yes, my dear, iodoform test is not given by. Let me try. 2-pentanone. 2-pentanone mean this is the compound. Yes, it contains that CH3CO group, so it will give. Ethanol. What is ethanol? CH3CHOH. Yes, it contains that group. Ethanol. Ethanol means CH3CHO. Yes, it contains that group. But 3-pentanone you see CH3CH2, CO, CH2, CH3. It do not contain particular group. So 3-pentanone cannot give, which test? Iodoform test. The product formed in aldol condensation is, they're all aldol. Remember all. Aldol, one another name is called beta hydroxy aldehydes or ketones. Because in aldol, what do you mean by aldol? What do you mean by aldol? Aldol means it contains aldehyde and alcohol. You try with the compound, okay? You will get like this one. Aldehyde, you will get it. You check any one of the aldol reaction we studied. Where aldehyde, I think we already discussed that. Aldehyde is there. Aldehyde connected carbon is called alpha. You check it all of you. The beta carbon contain the hydroxy group. Check any of the aldol product. So this is called beta hydroxy aldehyde or beta hydroxy ketone. Option this second one, a beta hydroxy aldehyde. Consider the following reaction. What is the compound C? Okay, I am trying. First reaction, CH3Br reacting with Mg. What happened when a haloalkane react with Mg? You will get Grignard reagent CH3MgBr. This on treated with the HCHO. We already discussed, my dear. Any Grignard reagent when you treated with the methanol or formaldehyde, always you will get primary alcohol. So one carbon here, you will get 2 carbon contain alcohol, that is ethanol. Ethanol, okay, that is followed by hydrolysis, you will get finally what? Ethanol. So what is CH3CH2OH? That is ethyl alcohol or ethanol. Benzaldehyde and acetaldehyde can be distinguished by, you know, this is benzaldehyde and this is what? Acetaldehyde. Benzaldehyde and acetaldehyde can be distinguished by, can we go with the iodoform test? Yes, because iodoform test is given by this one, it do not contain that CH3CO group. Failing solution is, what is failing solution A and failing solution B? Tell me, my dear students, those who study the theory. Failing solution A is copper sulfate 5H2O, blue color, and the failing solution B is sodium potassium tartrate, Rochelle salt. So what is that? Copper sulfate and Rochelle salt. 3. which can be reduced to corresponding hydrocarbon by zinc amalgam and HCl. Zinc amalgam and HCl means what? Clemmensen reduction. You know, Clemmensen reduction is happening on what? Aldehydes and ketone. Aldehydes and ketone, when react with the zinc amalgam and HCl, you will get hydrocarbon. So I will go with the ketone. See, this is acid, this is amide, this is ester. You know, Clemmensen reduction is given by what? Aldehydes and ketone. So this is a ketone. Ready. The enolic form of acetone is, what is enolic form? Remember all. You know, acetone is CH3COCH3. Let me write one of the hydrogen like this. Okay, CH3COCH3, one of the hydrogen I am writing like this. What is enolic form? Remember all. Enol. This hydrogen shifting to this carbon. So this hydrogen reached here. So what is the product? CH3COH double bond CH2. Check it. This contain ene and ol. This is called the enolic form. In this enolic form, how many sigma bond, pi bond and lone pair is the question. So dear all, let me just expand this compound. Okay, I'm just expanding. This is what? CH3 COH double bond CH2. This is the complete form. And you know, the oxygen contain 2 lone pair. Okay, total how many sigma? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sigma, and there is only 1 pi bond and there are 2 lone pairs. What is the option? What is the option? 9 sigma bond, 1 pi bond, 2 lone pair. Option A. So this is the enolic form. Okay. Next one, ethane can be obtained from ethanol. What is ethanol? CH3CHO. Ethanol can be converted to what? Ethane, CH3CH3. What is this reaction? Aldehyde converted to hydrocarbon. That is either Clemmensen or Wolff-Kishner. What is Clemmensen? Clemmensen is there, zinc amalgam and HCl is there. What is the IUPAC name of crotonaldehyde? Dear all, crotonaldehyde is a special compound which is given in textbook. Study all of you. This is called crotonaldehyde. Crotonaldehyde, this is the compound. So aldehyde is main group. So 1, 2, 3, 4. So this is but 2-ene 1-al. But 2-ene 1-al. But 2-ene 1-al. That is called what? Crotonaldehyde. Okay. Next, what is the IUPAC name of tartaric acid? What is tartaric acid? Some common compounds. Okay. Tartaric acid is COOH, CHOH, CHOH, and then one more COH. Total 4 carbon in the chain, where first and fourth are acid, second and third hydroxy. So what is the name? 2,3-dihydroxy. 2,3-dihydroxy butane 1,4-dioic acid. Let's go with option 1. Yes all? Butane 2,3-dihydroxy butane 1,4-dioic acid. Ready? Now, which of the following is the strongest acid? See, already there pKa values are given. pKa value. Remember, Ka value increases mean acidity increases, but pKa value increases mean acidity decreases. So question, strongest acid. Strongest acid mean what? Lowest pKa. Where is lowest pKa? That is first one. Which compound is most reactive toward nucleophilic addition? Most reactive mean it should be an aldehyde and less a bulky group. Which one is that? That is very simple. This ketone, ketone, ketone. This is the only one aldehyde, right? What is pH stands for, my dear? pH is phenyl, okay? So this compound is actually what? PHCOCH3. This is the compound. pH is phenyl group. So on this ketone, this is ketone, this is ketone, this is the only one aldehyde. So most reactive are aldehyde. Now what is this final product here? What is this zinc amalgam and HCl? Zinc amalgam and HCl mean Clemmensen reduction, where CO group become CH2. So it become CH2, CH3. So what is the product? That is compound 4 is the answer. CO group becomes CH2. That's it. Whatever the aldehyde and ketone, the CO group becomes CH2. Finish. So answer is 4. What is this reaction? Can you identify what is this compound? You know, this is a carbon, 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 carbon. Okay. So let me take the compound as CH3, CH2, C triple bond, CH. That is our addition of water reaction. Addition of water with what? Mercuric sulfate. Right. You know, H2O contain H plus and OH minus. So OH come to this one. Same example we discussed in this first session. So CH3, CH2, COH, double bond, CH2. You will get enol and it undergo tautomerism. What is tautomerism? This will shift here. You will get CH3, CH2, C double bond O, CH3. You will get it. Where is this compound? Where is this compound ketone CH3, CH2, C? Yeah, that is option 1. CH3. This is what CH3. This is what CH2. This is CO and then CH3. In the carbonyl group of aldehydes and ketone, what is carbonyl group means? CO group, right? This is called a carbonyl group. Okay, not clear. I'm just writing like this one. C double bond O. Okay. Question: what is the nature of the double bond between carbon and oxygen and type of hybridization of carbon? See, my dear, this carbon oxygen means 1 sigma, 1 pi bond. What is the hybridization of this carbon? We discussed that in carbonyl compound, the hybridization of the carbon is what? sp. This is trigonal planar shape, sp2. sp2 is the hybridization of the carbon. So what is the answer? The carbonyl group, aldehyde and ketone. What is the nature of double bond between carbon and oxygen? 1 sigma, 1 pi. Okay, so 1 sigma and 1 pi and sp2 hybridization. Let's go with option C. Okay, and we study this one. In carbonyl compound, when a nucleophile attack on the carbonyl, so then the compound becomes like this. Now it becomes tetrahedral shape where the hybridization is sp3. Now they are asking only about carbonyl compound. By dash, ketone can be prepared in one step. How can you prepare ketone in one step? Yes, there is an option, oxidation of secondary. Yes, oxidation of secondary alcohol give you a ketone. Why I'm going fast means, you know, there's a video lecture, so you can stop the video and see, we can analyze faster, okay? Which of the following is the most suitable catalyst for the esterification of acetic acid and ethanol? See, when an acid react with the alcohol, we get an ester, right? We get an ester. This is happen in presence of a mineral acid. Okay, esterification is happen in presence of which one? A acid catalyst. Well, for example, yeah, HCl gas, HCl, H2SO4 acids. Benzoic acid react with, what is benzoic acid? Benzene with COOH is called benzoic acid. Benzoic acid react with the phosphorus pentachloride, PCl5. What happened? The OH becomes Cl, that's it. What is this compound is called? Benzoyl chloride. Benzoyl chloride. Okay. Acid when react with the PCl5 or PCl3 or SOCl2, we get acid chloride. Next, other than ethanoyl chloride, what are the byproduct formed when ethanoic acid react with the PCl3? Ethanoic acid when react with the PCl3, we already studied this reaction in our haloalkane chapter, where there is an alcohol, that's it. Acid when react with the PCl3, the OH becomes what? OH becomes Cl and this become what? H3PO3. Option A, H3PO3. Which aldehyde will give Cannizzaro reaction? If it giving Cannizzaro reaction mean no alpha hydrogen. Where there is no alpha hydrogen, option C. Many times we discuss CHO, this is the alpha carbon, no alpha hydrogen. Which will give Cannizzaro, right? Yeah, okay, fine. Which of the following ketone has the common term acetone? What is acetone? Acetone is CH3COCH3, that is our propanone. But that is not the right. Which of the following ketone has the common name acetone? What is acetone? Another name. Dimethyl ketone. Dimethyl ketone. Yes, option A. Dimethyl ketone also can be said. What is diisopropyl ketone? IUPAC name. What is isopropyl? This group is called isopropyl. Diisopropyl mean, yeah, one more is there. In between there is a ketone. This is the compound called diisopropyl ketone. What is its IUPAC name? 1, 2, 3, 4, 5. So 2,4-dimethyl. Where is that? 2,4-dimethyl B. 2,4-dimethyl pentan 3-on. Ready? We are going to discuss biomolecules most important 100 MCQs. Welcome to the part 1. session. 25 questions we can discuss at a stretch. We have the first question. React with nitric acid gives what's the result? We know glucose we can write like CH2OH and CHOH 4 times, and then we have CHO. Glucose when react with the nitric acid, we know nitric acid we may study it as a strong oxidation. So then glucose and the aldehyde group and the primary alcohol, both of them become acid, right? Both of them becomes acid. CHOH 4 times COH. When glucose react with nitric acid, we will get both of that. Aldehyde become acid, even the primary alcohol become acid, and it is called what? Saccaric acid, right? Saccaric acid. So what is the product is called? Saccaric acid. What about gluconic acid? Glucose when react with the bromine water, right? Bromine water, you will get which one? Gluconic acid as the main product. Second question, which of the following is not a polysaccharide? Not a polysaccharide. You know, cellulose is a polysaccharide. Fructose, yes, fructose is a monosaccharide, correct. And what about starch? Starch is actually a polysaccharide. Glycogen is also polysaccharide. In this chapter, we discussed only 3 polysaccharides, which are starch, cellulose, and glycogen, right? Fructose, glucose, these all are what? Monosaccharide. Question 3, which of the following is a non-reducing sugar? Sucrose. The only one non-reducing sugar specified, that is what? Sucrose. You know, all monosaccharides are which one? The reducing sugar. Only the non-reducing sugar is which one? Sucrose. The functional group which is found in a amino acid is, you know, amino acid general formula is RCHNH2COOH. So amino acids contain both amine and acid group, basic and acidic group. So COOH is there, NH2 is there, that means both A and B are there. Careful, okay. So when you see the acid means, you immediately don't read all option, which is the most correct answer. So functional group which is found in amino acid is both acid and amine group. Next, the vitamin absorbed from intestine along with the fats are. So they're asking you which is a fat soluble vitamin. You know, vitamin A, D, E, K are the fat soluble vitamin. Vitamin B and C are water soluble except vitamin B12. So vitamin A, D, E, K are the fat soluble vitamin. So vitamin absorbed from intestine along with the fat are A, D, E, K. So A and D, okay. A and B, no, B not possible, C not possible, B not possible, right? Option A. Vitamin A, D, E, K are fat soluble. Vitamin B and C are water soluble except vitamin B12. The helical structure of protein is stabilized by. The helical structure of protein, alpha helical structure of protein is stabilized by which bond, my dear? Hydrogen bond. You know, one turn CO group, another turn NH group, they are connected through which bond? Hydrogen bond. Alpha helix, beta pleated, these are the 2 secondary structure of protein. They are stabilized by hydrogen bonding. Hydrogen bonds, okay, not which one, the bands, hydrogen bonds. Which of the following has a branched chain structure? Branched structure. Amylopectin, amylocellulose, nylon. What is that? Amylopectin. You may study starch having 2 components, right? Starch is a polysaccharide. They contain 2 components. One is amylose and one is called amylopectin. Amylopectin. You know, amylose is linear chain, whereas amylopectin is a branched chain. So branched one is which one? Amylopectin. Glucose react with acetic anhydride. What is glucose again? CH2OH, CHOH 4 times, then we have CHO. Glucose and react with the acetic anhydride. What is acetic anhydride? CH3, COO, COCH3. We may study total 5 acetic anhydride. We have to take it because acetic anhydride will react with the 5 OH group in this one. Where is 5 OH? This 4 OH group and this OH group, that is eliminated, and the COCH3 come to this one. We have CH2, this OCOCH3 come to this one. You will get CH2 OCOCH3 and here CHOCOCH3 4 times and we have CHO. What is this compound is called? Glucose pentaacetate, because 5 acetic anhydride we are adding, you will get 5 acetate group here. That's called glucose pentaacetate. Glucose pentaacetate. What this reaction shows that glucose, when react with 5 molecules of acetic anhydride, we get glucose pentaacetate. This shows that glucose contain total 5 OH groups. Next one. Which of the following has not a glycosidic linkage? Which of the following has not a glycosidic linkage? You know, glycosidic linkage is the bond between two monosaccharides, right? You know, sucrose. Sucrose is a disaccharide which contain glucose and fructose. They are connected through glycosidic. Amylose. Amylose is a linear chain of starch which contain many monosaccharide connected through glycosidic. Galactose, my dear, galactose is just a monosaccharide. Between two monosaccharide, the bond what we call glycosidic linkage. Here galactose is just a monosaccharide. And what about maltose? Maltose is a disaccharide which is composed of 2 alpha D glucose. Yes, they are connected through glycosidic linkage. Amino acids are the building blocks of which one? Proteins, right? Proteins are made up of amino acids. Which carbohydrate is an essential constituent of plant cell? Which one? The cellulose, right? The cellulose is the one which is making the plant cell the outer covering. Enzyme in the living system is enzymes in the living system. What do you mean by enzyme? Biological catalyst. So they are catalyzers, the biological reaction. You know what is a catalyst? Catalyst is the term we are normally using in a chemical reaction. If it is in a biological system, the catalyst is called what? Enzymes, right? Enzymes are biological catalyst. What is the number of chiral carbon in beta D plus glucose? You know what is the open chain structure of glucose, my dear? What is open chain structure of glucose? CH2OH, OHH, OHH, then we have HOH, then we have HOH, then we have CHO. This is the open chain structure of glucose. What is beta D and alpha D? Beta D and alpha D are the cyclic structure of glucose. Do you remember how to draw the cyclic structure of glucose? What is the structure of beta D glucose? We will write here CH2OH, then H, OHH, then we have HOH, then OHH, then on this carbon, H right side, OH left side, and connected through the oxygen. This is the structure of the compound, which one? Beta D plus glucose, right? Beta D plus glucose. What is mean by beta D alpha D difference? On the first carbon, if OH is left side, it's beta. If the first carbon OH right side is called alpha. So this is beta D glucose structure, correct? In this one, how many chiral carbons are there? Okay, let us count. This carbon, you check it all. This carbon connected to OH, H, one O, and then another group. Yes, chiral. This carbon CH, OH, different group, up and down. Yes, chiral. This is chiral, even this also chiral. This is not a chiral. This means this is not chiral. So this carbon connected to same element, hydrogen. You know what is a chiral carbon? Carbon, all 4 bonds should connected to 4 different groups, right? So total there are 1, 2, 3, 4, 5. 5 chiral carbons are in beta D glucose and alpha D glucose in anomers. Which one is correct statement? Which one is correct? Starch is a polymer of alpha glucose. Yes, that's a correct statement, right? Starch is fully made up of what? Alpha D glucose. Amylose is a component of cellulose. No, amylose is a component of starch. Protein are composed of only one type of amino acid. No, different type of amino acids can join. Glycine, alanine, valine. In cyclic structure of furanose, these are 4 carbons and 1 oxygen atom. Now the furanose structure and all, you remember, that's different one. It's wrong. Which base is present in RNA but not in DNA? You know, DNA contain the bases A, ATGC, whereas in RNA they are AUGC. Question, which base is present in RNA but not in DNA? That is what? Uracil, right? RNA contain uracil, instead DNA contain what? Thymine. So which base is present in RNA, not in DNA? Uracil. Glycogen is a branched chain polymer of alpha D glucose unit in which chain is formed by C1, C4 glycosidic linkage. whereas branching occur by the formation of C1C6 glycosidic linkage. Structure of glycogen is similar to what? Where we studied the C1C4 and C1C6 linkages and all in the branched polymer amylopectin, right? Branched, which one? Amylopectin. Amylose is linear, cellulose is linear, glucose, that's a normal one. Amylopectin is the branched polymer that's having very close structure to which one? Glycogen, that is also branched one. Which of the following polymer is stored in the liver of animal? Which one? Glycogen. Glycogen is the polysaccharide which is stored in liver, muscles and brain. And sucrose is a disaccharide. Yes, sucrose on hydrolysis, what you get, my dear? You will get alpha D glucose and beta D fructose, right? Sucrose on hydrolysis you will get one alpha D glucose, one beta D fructose. So what you get? Is it giving you 2 molecules of glucose? No. 2 molecules of glucose, 1 molecule of fructose, 1 molecule of glucose and 1 molecule. Yes, option 3 is the correct answer. Okay, 1 molecule of glucose and 1 molecule of fructose. Which of the following pair represent anomers? What are anomers, my dear? Anomers are isomer. They are in cyclic form. So first of all, the non-cyclic form we can cut it. See, this is not cyclic, right? Cut it. This is not cyclic, cut it. Anomers we are especially saying in cyclic compounds. These two are the cyclic one. Check it. In the cyclic form, only one carbon configuration should be different. Same formula, but only one carbon configuration is different. Can you identify where it is? See, if you check this carbon OH right, this carbon OH left. This carbon OH right, this carbon OH right, this carbon H same, this carbon OH same. Okay, see, in these two compound, I think only this carbon configuration is different, right? Here OH right, H left, here OH left, H right. Remaining, I think all are same. See, yes, this is the anomer. What about this case? Here OH right, here OH left. Here OH right, here OH left. See, more than one carbon configuration different mean it's not anomer. So anomers mean same formula, only one carbon configuration is different. See this carbon OH right, here the OH is on left. Remaining all these, see all these are same or not? All these part is what? OH, H, OH, yes, same. So this is the anomer. Which of the following disaccharide is a non-reducing sugar? Non-reducing sugar, we studied only one example here, that is which one? Sucrose. You know, sucrose is made up of alpha D glucose and beta D fructose. So identify which is alpha D and beta D fructose here. Very simple, my dear. The glucose structure you may study that we write in which one? The pyranose ring structure, and fructose we will write in furanose ring structure. Yes or no? This is the glucose and fructose Haworth representation. Where it is? You can see here both are pyrene ring. Here one is pyrene, one is furan ring. Yes, this is the one can be possible. See here all are what? Have you noted? This is pyrene. These all are pyrene. This is pyranose ring. This is furanose ring. Glucose expressed in pyranose ring. Fructose expressed in furanose ring. Then which of the following acid is a vitamin? So vitamins, clear the table is given. What is the other name of vitamin and their deficiency causes and their source? Very important. Which is a vitamin, dear? Ascorbic acid, that is another name of vitamin C. Vitamin C is also called ascorbic acid. You know the deficiency causes what? Scurvy. And dinucleotide. What do you mean by dinucleotide? Two nucleotides are joined by two nucleotides together by phosphodiester linkage, you know. Between which carbon atom of pentose sugar nucleotides are these linkages present? You know, third carbon with the fifth carbon, 5' 3'. Between two nucleotide, between one nucleotide and another nucleotide, between two nucleotide, the connection is between C3 and C5. First, third and fifth carbons are connected. What is the linkage is called? Phosphodiester linkage. The bond between two nucleotide is called phosphodiester linkage. Nucleic acids are the polymers of nucleotide. You know, we have a nucleoside first. What do you mean by nucleoside? Nucleoside means it contains a pentose sugar. A pentose sugar with a nitrogen base. This is called nucleoside. From this nucleoside, if you add a small thing, you will get nucleotide. Nucleotide mean the same nucleoside, this nucleoside with a phosphate group extra. That is called nucleotide. Many nucleotides join, you will get which one? Nucleic acid. Nucleic acid, that's our DNA and RNA. So nucleoside, nucleotide, nucleic acid. Nucleoside contain a pentose sugar with a base. This plus a phosphate group is called nucleotide. Like many nucleotide join, you will get nucleic acid, that is our DNA and RNA. So nucleic acids are the polymers of which one? Nucleotide. Many nucleotides are joined, you are getting nucleic acid. Next one question, my dear. Which of the following statement is not true about glucose? It is an aldohexose. Yes, glucose contain a aldehyde group and 6 carbon. Therefore, it's called aldohexose. On heating with HI, it forms N-hexane. Yes, glucose when heated with a hydrogen iodide, we get normal hexane, which shows that all 6 carbon in glucose are in a straight chain. It is present in furanose form. No, glucose present in pyranose form, right? Glucose present in pyranose form. This is pyran. Furan is which one? This one. That is fructose. Okay. Glucose present in furanose form, not in, glucose present in pyranose form, not in furanose. And each polypeptide in a protein has amino acid linked with each other in a specific sequence. This sequence of amino acid is called what? Primary structure of protein. What do you mean by primary structure of protein? Definition you studied. It is a specific and sequential arrangement of various amino acid on a polypeptide chain. That is called primary structure of definition is given. That's the answer. Option A. Question number 26. DNA and RNA contain 4 bases each. Which of the following base is not present in RNA? Which one, my dear? Thymine. Right? RNA contain bases are A, U, G, C. Adenine, uracil, guanine and cytosine. Thymine is not in RNA, it is in DNA. Right? Which is not present in RNA, thymine. Which of the following B group vitamin can be stored in our body? See, vitamin B and C are water-soluble vitamin. Water-soluble vitamin. You know, water-soluble vitamin cannot stored in our body. It is excreted through urine. But exception is there, vitamin B12. Vitamin B12, which is not a water-soluble one, completely not water-soluble, it can be stored in our body. So, which of the following B group vitamin can be stored in our body is vitamin B12. Except vitamin B12, all vitamin B and C are water soluble, right? Can't store in our body. And 3 cyclic structures of monosaccharides are given below. Which of these are anomers? What are anomers? Anomers mean only 1 carbon configurations are different. You check it all. See this compound, let me take it, this carbon. Here OH on right side, here OH on left side. And this carbon, OH on right side, I think this OH same, here these are same, these are same. Yes, these 2 compound when you consider, only the first carbon configuration is different, remaining all are same. So 1 and 2 can be anomers. What about this one? See here 1 carbon extra, right? 1 carbon extra. Formula should be same. Anomers, isomer, right? So here 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. No. So these 2 are same formula and just 1 carbon configuration is different. So 1 and 2 are which one? Anomers. 1 and 2 are anomers. Optical rotation of some compounds along with their structures are given below here. Which of them having D configuration? We studied D and L configuration. Very simple, very simple. They all D and L, there is no relation with the dextro and levo, okay? Not that. There is small d and small l. DL giving you the arrangement, configuration. So if you want to analyze that, very simple. See the second last carbon. Just check the second last carbon. So this is the second last carbon where OH right side, then it is D form. If OH left side, L form. That's it. See the second last carbon, this one. OH right side, D form. Second last carbon, yes, this is OH right side, yes, D forms. Here all are in D configuration. So 1, 2, 3. So if you want to check in a carbohydrate whether it is D or L, very simple trick is that see the second last carbon where OH right or not, just OH right, D, OH left, L. Carbohydrates are classified on the basis of their behavior on hydrolysis and also as reducing or non-reducing sugar. Sucrose is a, they're asking you the properties of sucrose. Is sucrose is a monosaccharide? No, sucrose is a disaccharide. Yes, we have an answer, disaccharide. Is it a reducing sugar? No, sucrose is the only one we studied as a non-reducing sugar. And is a polysaccharide? No, it's a disaccharide, right? So sucrose is a disaccharide. Amino acids are classified into acidic, basic and neutral, as per the number of COOH group and NH2 group present. Question, which of the following are acidic? Which of the following are acidic? See, first compound, it contains one amine group, one acid group. Amine is basic, this is acidic. So equal number mean that will be neutral. In the second question, 2 acid is there, 1 amine is there. So more acid group mean, yes, it will be acidic. It contains only one basic and one acidic, it will be neutral. And this one contain, yes, 2 acid, one, which one? Basic. So this is also what? Acidic. So which all are acidic here? The second and fourth one are acidic. So more number of COOH group present than NH2, it will be acidic. If opposite mean, if more NH2 group than acid, it will be basic. Equal number of acid and basic will be neutral. Next one. Which of the following compound is found abundantly in nature? That is in plants. Which one? Cellulose. The most abundant carbohydrate, that is cellulose, that is in nature. Which of the following treatment will convert starch directly to glucose? We studied 2 preparation of glucose in this chapter. One is laboratory preparation, one is commercial preparation. So they are asking starch, that is a commercial preparation. What is starch chemical formula? C6H10O5N times. When starch dissolved in N number of water in presence of a dilute acid, for example H2SO4, at a 393 Kelvin and 2 to 3 atm pressure, we will get N number of which one? C6H12O6, that is glucose. So starch is fully made up of alpha D glucose. On hydrolysis in presence of an acid, you will get glucose. So they're asking which of the following treatment will convert starch into glucose? Heating with a dilute H2SO4, that is the acid we are using. On oxidation with a mild brominating agent, bromine water, glucose is oxidized too. You may study, my dear, glucose when react with mild bromine water, mild oxidation, whereas strong oxidation done by nitric acid, you will get 2 different products. Glucose on bromine water, you will get gluconic acid. Glucose on nitric acid, you will get saccaric acid, right? Saccaric acid. So glucose on mild oxidation with the bromine water, you will get gluconic acid. Where is gluconic acid? Option C. During acetylation of glucose, it need X moles of acetic anhydride. How many moles? 5 moles. How it is? Glucose structure CH2OH, CHOH 4 times, and we have CHO. My dear, I hope you all studied the theory very well. We will treat with the acetic anhydride. What is acetic anhydride? CH3COOCOCH3. How many acetic anhydrides we use? That's a question. We need total 5. Why 5? Because 5 OH groups are there. Here 1 OH, here 4 OH. All that OH replaced by the OCOCH3. So you will get the compound CH2 OCOCH3, CHOCOCH3, 4 times, and we have CHO. What is called? And the name itself giving you the idea. What is the name of the final product? Glucose pentaacetate. Total 5 acetate groups are there because we added 5 acetic anhydrides. The letter D in carbohydrate signify, don't write, my dear, that is not dextro. Dextro and levo related to small d, small l, or plus or minus. Capital D, capital L just represent configuration. That means arrangement, okay? That is nothing but configuration. Pick up the incorrect statement. Incorrect. Okay, first. Glucose exists in 2 different crystalline form, alpha D glucose and beta D glucose, okay? Cyclic structure of alpha D glucose and beta D glucose is called pyranose structure. Yes, we write in pyranose, whereas fructose we will write in furanose. Alpha D glucose and beta D glucose are enantiomer. No, they are anomers. Alpha D glucose and beta D glucose are not enantiomer, they are anomers. What are anomers? Same formula, but they are differ only in the configuration of one carbon. They are anomers. The anomeric carbon, okay, not aromatic, anomeric carbon in D plus glucose. Not aromatic one, dear, anomeric, okay, anomeric, that's a question. Which is the anomeric carbon in D plus glucose? See, the anomeric carbon in D plus glucose is, you studied the first one, the open chain structure of glucose, you know, even in the NCERT question, last part we discussed how to write the cyclic form. So, in the open chain structure of glucose, you know, CHO is their top. The first carbon and fifth carbon just connected, we'll get the alpha D form and beta D form, right, anomers. Where anomeric carbon is which one? C1 carbon, first carbon. Because in the first carbon, only the configurations are different. So remember, in glucose, the anomeric carbon is C1 carbon. In fructose, the anomeric carbon is C2 carbon. What is it meaning? In glucose, the first carbon in which the configurations are different. In fructose, the cyclic form, second carbon configurations are different. Anomeric carbon in glucose is C1, anomeric carbon in fructose is C2. Alpha and beta forms of glucose are what? Anomers. So, what is the answer, right? Anomers of glucose. The correct statement about the following disaccharide. The disaccharide is given to you. This is a pyranose form. This is a furanose form. So, that is basically which one, the sucrose identity. First ring 1 is pyranose. Yes, dear all, this one is called, this hexagon part is called, this is our pyranose ring structure. This is our furanose ring structure. Ring 1 is pyranose with alpha glycosidic linkage. Yes, this is what, you know, this is actually what sucrose. It is made up of alpha D. What is this? This is alpha D glucose unit and this is beta D fructose unit. So, ring 1 is pyranose with alpha glycosidic linkage. Yes. Ring 1 is furanose. No, ring 1 is pyran, ring 2 is furan. And ring 2 is pyran. No, ring 2 is pyranose with beta. No, alpha D is the connection from alpha D glucose. Which one of the following sets of monosaccharide forms sucrose? Sucrose is made up of what? Sucrose is made up of alpha D glucose and beta D fructose. And you know, glucose is expressed in which ring? Pyranose ring, whereas fructose in which ring? Furanose ring. So overall, can you say the answer? Alpha D galacto, no. Alpha D glucopyranose and beta D fructofuranose. Yes, B. Sucrose is made up of alpha D glucopyranose. Glucose is in pyranose structure. Beta D fructose is in furanose structure. What are the hydrolysis product of sucrose? Sucrose is made up of alpha D glucose and beta D fructose. Alpha D glucose and beta D fructose. Basically, glucose and fructose. Glycosidic linkage is a bond between two monosaccharides. Two monosaccharides are connected through glycosidic linkage, and what is that type of bond? It is a type of ether linkage. You can see there is a ROR connection. Remember all of you, glycosidic linkage is a ether linkage, whereas peptide linkage is a amide linkage, because it contains CONH connection. This is amide linkage. And we have phosphodiester linkage, that is the bond between two nucleotides, that is a type of ester linkage. Please note this point, all of you. Okay, glycosidic linkage is a type of ether linkage. Peptide is containing amide linkage. Phosphodiester contain ester linkage. Glycosidic linkage is present in. Glycosidic linkage is present between what? Monosaccharide, right? So where is that? Option B. Amino acids connected through, my dear, peptide bond, and nucleotides are connected through phosphodiester bond. Study the structure of the maltose and mark the incorrect statement. Maltose is made up of what, my dear? Maltose is a disaccharide made up of alpha D glucose and alpha D glucose. Both are alpha D glucose. Two alpha D glucose units are present in maltose. Question incorrect. Maltose is composed of 2 alpha D glucose units. That's a correct statement. C1 of 1 glucose linked to C4 or other unit. Yes, in the maltose, alpha 1,4 dash glycosidic linkage is present. First carbon of 1 glucose connected to fourth carbon. Correct. It is a non-reducing sugar. They are all non-reducing sugar. Only one example we studied, that is sucrose, non-reducing sugar, no maltose and all reducing sugar. That is the incorrect statement. It is a disaccharide. Yes, it is a disaccharide. And the glycosidic linkage involved in linking the glucose unit in amylose part of starches. We have two components for starch. One is which one? Amylose, and one is what? Amylopectin. Amylose and amylopectin. Amylose units are connected through alpha 1,4 dash glycosidic linkage, only linear chain. But you know, amylopectin contain linear and branched. In linear, alpha 1,4 dash, in branch alpha 1,6 dash. Where in linear chain alpha 1,4 dash, in branches alpha 1,6 dash is the connection. So the glycosidic linkage involved in linking the glucose unit in amylose part is, amylose is C1C4. C1C4 alpha linkage, C1C4 alpha linkage, C1C4 alpha 1,4 dash glycosidic linkage. What is the basic formula of starch? What is starch? C6H10O5N times. This is starch. C6H10O5N times starch is the formula. Starch is composed of 2 polysaccharides which are amylose and amylopectin. Starch is made up of amylose and amylopectin. 49. The cellulose, in cellulose, D-glucose units are joined by, my dear, cellulose is a polysaccharide. It is fully made up of beta D-glucose connected through 1,4 dash. So therefore, beta 1,4 dash glycosidic linkage. Cellulose is a polysaccharide. It is made up of beta D-glucose connected through first and fourth carbon. So 1,4 dash glycosidic linkage with beta. Remember whether alpha or beta, that you can understand from the monosaccharide. Cellulose is made up of fully beta D-glucose and connection is 1,4. So beta 1,4 dash glycosidic linkage. 50th question, carbohydrates are stored in human body as the polysaccharide. Which one? Glycogen. In animal body, carbohydrates are stored in the form of what? Glycogen. Glycogen is present in liver, muscles and brain. Don't forget. Here we have the question, a compound which contain both dash and dash is called an amino acid. Amino acids, you know, they are the building blocks of protein. They contain both acidic and basic group, right? Amino and carboxylic acid group. The amino acids in polypeptide chain are joined by dash linkage. Which linkage? Peptide linkage. So what is the answer? Option B, right? They contain amino and carboxylic acid and they are connected through peptide linkage. Question 52. Which of the following is not true about an amino acid? They are constituents of all protein. Yes, proteins are made up of amino acid, correct? Alanine. Do you remember structure of alanine? Alanine is NH2, CH2, COOH. That is first one. Glycine. Alanine is which one? NH2, CH3 and COOH. This is called alanine. Alanine having one amino group and one carboxylic acid group. Yes, correct. Most naturally occurring amino acids have D configuration. No, it's clearly given in textbook. Most naturally occurring amino acids having L configuration. So C is the correct answer. Glycine. What is glycine? Glycine is NH2, CH2, COOH. Glycine is the only naturally occurring amino acid which is optically inactive. You know, glycine, this carbon is not chiral. In glycine, there is no chiral carbon, so that's optically inactive. Remaining are optically active, majority. Amino acids are classified as acidic, basic, neutral. We already discussed this one. Question, which of the following are acidic in nature? Come on all. This compound contain one acid, one amine group. So same number of acid and amine mean it's neutral. Leave it. This contain 2 acid and this is 1 amine. So more acid group mean yes, it's acidic. This one contain 1 acid, 1 base, so equal number, neutral. This contain more acid than 1 base, so this is also acidic. So 2 and 3 are acidic, right? 2 and 3 are acidic. Option D is the correct answer. 2 and 3 are acidic in nature. Amino acid generally exist in the form of zwitter ion. This means they contain, carefully listen all of you. What is the general form of amino acid? R, CH2, NH2 and COOH. How they exist in zwitter ionic form? This is basic, this is acidic. So basic group can donate the lone pair, acidic group can donate the H+. So by donating the lone pair, they will take the H+, you will get R, CH, NH3 plus and COO minus. You know, this can be switched, right? This can be switched, therefore we mention a reversible arrow. Carefully listen all. In the normal amino acid, the COOH group is the acidic group and NH2 group is the basic group, correct? But when they convert it to zwitter ion, now this one can donate a H+, so this is become acidic, this can gain H+, so this group become basic. So they are asking in zwitter ionic form which is the acidic group and basic group. Okay, very careful. This means they contain acidic NH3 plus and basic COO minus. Check it where it is. Acidic NH3 plus. The basic NH3 plus group and acidic CO minus, basic NH2 and acidic H plus, basic, yes. See option D, basic COO minus group and acidic NH3 plus group. Remember, in normal amino acid, if they are asking this is acidic, this is basic. But when they convert it to the zwitter ion, they get switched. This is basic and acidic. Which compound can exist in a dipolar or zwitter ionic structure? Which of the following compound can exist as zwitter ion? Zwitter ion existence is for an amino acid. So they are asking which is an amino acid. Amino acid can contain what? NH2 and COH group together. Check it where it is. This one contain acid group but amine group is not there. But this compound, yes, it contain both NH2 and COH group, right? Option B is the amino acid. See, this contain no only acid, this also an acid. So zwitter ionic form is given basically as per this chapter given by amino acid. There which is they're asking you which is a amino acid. That is option B. Next one question we have. The melting point of amino acids are higher than the corresponding halo acids because amino acids can exist in zwitter ionic form, right? Because of the zwitter ionic dipolar species, they are having high melting point. So amino acid exists as zwitter ion resulting in strong dipole-dipole attraction. Yes, that's why. Remember all, melting point of amino acids are higher because they exist in which form? Zwitter ionic form. Amino acids are optically active due to the higher molecular mass. No, they are interact with the water. No, that's the main reason. Proteins are condensation polymers of. You know, proteins are made up of what? Amino acid. Which amino acid? Alpha amino acid, right? Alpha amino acid. What is the general formula of amino acid? RCH NH2 COOH. Correct. See, this acid is the main functional group here. Main functional group connected carbon is called alpha. See, alpha amino. Alpha position, amino is 0. Alpha amino acid is the one. Which of the following represent peptide chain? Peptide chain. Peptide chain means protein chain, amino acid. I told you, peptide chains contain what? CONH bond. That's amide linkage. You check where alternate CONH group is coming, that system. Here you have CONH with one more NH and all. No. CONH CH2, that's see there is a large gap between NH something. No. You check it all where we have CONH in a frequent order. Yes, that is in option C. Can you see? CONH after a gap, again CONH. So this CONH group should be a alternate after a frequency. That's after a frequent manner. This is called what? The peptide linkage. So peptide linkage is very easy to identify where we have a CONH amide linkage in a particular gap. Next one, in fibrous protein, polypeptide chains are held together by. In fibrous protein, we know two protein chains are running parallel. They are held together by very strong hydrogen bond, and especially we have one more disulfide linkage. So I think they mention here hydrogen bond. So basically this chapter, they ask you what is the bond stabilizing alpha helical structure, fibrous protein. These all are what? Hydrogen bonds. Primary structure of a protein. Can you define what is primary structure of protein? It is a specific and sequential arrangement of various amino acids in a protein chain. Sequence in which alpha amino acids are linked to another. Yes, that's called primary structure. Specific and sequential arrangement of various amino acids. Sequence which amino acids of one polypeptide chain are joined to another. Sequence in which alpha amino acids are linked to one another. Yes. B can be possible. Sequence in which amino acids of one polypeptide chain, no, not with other, only single. Most common type of secondary structure of proteins are, tell me all. What are the two common secondary structure of protein? Alpha helix and beta pleated, right? Alpha helix and beta pleated. Alpha helix and beta pleated sheet structure. Denaturation of protein leads to the loss of its biological activity by. During denaturation, what all changes happen? Primary structure remains same. Secondary and tertiary structure completely disturbed and lost its biological activity, right? So denaturation of protein leads to the loss of its biological activity by loss of primary. No, primary structure do not disturb. Loss of both primary and secondary structure not possible. That's D, I think, loss of both secondary and structure. Remember, during denaturation, primary structure nothing happen. Secondary and tertiary structure completely disturbed. It's lost its biological activity. On boiling egg, boiling of egg is a denaturation. On boiling egg, what structural changes are taking place? They're asking during denaturation, what all changes happen? Color of the egg, color is not the factor. Secondary and tertiary structure are destroyed, but primary structure remain intact. Yes. During denaturation, secondary and tertiary structure completely disturbed, primary structure remains same. Vitamin C must be supplied regularly in diet because vitamin C and B are water soluble vitamin, dear all. Water soluble vitamin, if you eat, what happened? That dissolved in water content in our body. They excreted through urine. We can't store in our body for a long time. So vitamin C must be supplied regularly in diet because it is water soluble, hence excreted through urine and can't be stored in our body. Yes, option A. Clear? Question 65. Deficiency of vitamin E causes muscular weakness. Muscular weakness. You know, rickets is because of vitamin D. Scurvy is because of vitamin C. Beriberi is because of vitamin B1. Please study the vitamin each deficiency causes. Match the vitamin. Yes, match the vitamin here with their deficiency. Vitamin B1 causes beriberi. This is A. A with the third one. A with the third one, only option this one. Anyway, vitamin B2 causes chelosis. Vitamin B2 causes chelosis. Vitamin B12 causes pernicious anemia. And vitamin B6 causes convulsion, that is D, right? So study the table carefully, my dear. One more. Nucleic acids are, nucleic acid, that means DNA and RNA are, which one? Long chain polymers of what? Nucleotide, right? Nucleic acids are formed by the combination of many nucleotides. A nucleoside on hydrolysis give, what they're asking you, what is nucleoside contain? A nucleoside contain a pendo sugar. Pendo sugar, you know the carbon number 1, 2, 3, 4, 5. A pendo sugar with a nitrogen base on the first carbon. This combination what we call a nucleoside. A pendo sugar with a nitrogen base. A nucleoside on hydrolysis give a aldopendose and a nitrogenous base. Yes. An aldopendose and phosphoric acid, a aldopendose nitrogen base and phosphoric acid. Now this is a aldopendose, that means pendo sugar, nitrogen base is the only nucleoside. With a phosphoric acid, if it comes, that become nucleotide. Okay, careful. Guanine is an example of, you know, adenine, thymine, guanine, cytosine, uracil. These all are nitrogenous base, right? It's a nitrogenous base present in DNA and RNA. Bases common to RNA and DNA. You know, RNA contain AUGC and DNA contain ATGC. So what all bases common? AGC are common in both. So bases common to RNA and DNA are AGC, that is option A, adenine, guanine, cytosine. In DNA, the complementary bases are, in DNA, one strand if it contain adenine, always other strand thymine, one strand guanine, other strand always cytosine, here through double bond, here through triple bond. So adenine and thymine, guanine and cytosine are the base pair, okay? Adenine with the thymine, guanine with the cytosine. A unit in nucleic acid which contain base, sugar, phosphate. A nitrogen base, a sugar and a phosphate. What it is called? Nucleotide. Only the nitrogen base and pentose sugar, this is called nucleoside. With the phosphate group, what we call nucleotide. If one strand of DNA contains, so one strand DNA contains adenine, thymine, guanine, cytosine, thymine, guanine and adenine means, what is the complementary strand contain? See, adenine always bonded to thymine, guanine always bonded to cytosine, remember. So adenine means the other strand should be thymine. Thymine means adenine, guanine means cytosine, cytosine, guanine, thymine, adenine, TAGCAT. So where is this strand present, all of you? TACG, AACT. I think it's option D, right? Yes. Correct, all of you? TACGAACT. Correct. 74. Match the following. What is a nucleoside? A nucleoside contains sugar and nitrogen base. Sugar and nitrogen base. This is the one, A. So nucleoside A matching with the third. A matching with the third, only first one. What about nucleotide? A base, the pentose sugar and phosphate group. Sugar, base and phosphoric acid. This is B. Yes. DNA contain thymine, right? DNA contain thymine. So C, and RNA contain uracil, D. Right, all of you? So match the following, symbol. Study the theory very well. One more, match the following. Peptide linkage is matching with which one? Peptide linkage is matching with what? Protein, right? So A, it's matching with the third one. A matching, third one, C. Nucleic acid, what it contains? Nucleic acids are made up of nucleotide. So B. Hydrolysis of cane sugar. Hydrolysis of cane sugar, sugar. Cane sugar is sucrose. Sucrose is called a invert sugar, right? Sucrose is initially dextrorotatory. On hydrolysis, it becomes levorotatory. There is a invert sugar. So inversion is happening in this one. Starch is a, yes, polysaccharide, D. Overall, C. RNA molecules are of three types which are based on their different function, which all. mRNA, tRNA, rRNA, right? We have messenger RNA, not translation, messenger RNA, ribosomal RNA and transfer RNA. Yes, messenger RNA, mRNA, ribosomal RNA, rRNA, transfer RNA, tRNA. These are the different type of RNA. Glucose on heating with HI gives simple reaction. Glucose on heating with hydrogen iodide, we get normal hexane. What is this normal hexane? Indicate that all 6 carbon are in a straight chain, right? So normal hexane is the answer. Glucose on heated with HI. Which one of the following is an amino acid? Amino acid, they basically contain NH2 group and COH group. That's it. This one not having, this only having NH2, it's an amide actually. So which one, dear? Option D. Yes, it contains NH2 and COH. This is our first amino acid, glycine. Right? NH2 and COH should be there. What is the final product of starch digestion is? Starch is fully made up of, what is the chemical formula of starch? C6H10O5 enzymes. Starch is fully made up of which one? Glucose. Starch is fully made up of alpha D glucose. Protein found in a biological system with a unique 3-dimensional structure and biological activity is called what we call native protein. A native protein have a unique 3-dimensional structure and a biological activity is called native protein. This native protein we are subjected to denaturation. Correct. Now, vitamin A is called, different vitamins are there, their other name deficiencies compulsory to study, my dear. Vitamin A is called retinol. Vitamin A, ascorbic acid is vitamin C and all you may study. So, retinol is what? Vitamin A. Other names, study all the first question we discussed from this one. Nucleotides are joined together by phosphodiester linkage, option D. Scurvy is caused due to the deficiency of which one? Vitamin C. Vitamin C. Scurvy is because of the deficiency of vitamin C. Vitamin C is also called what? Ascorbic acid. Which of the following reagent does not react with the glucose? Does not react with the glucose. Hydroxylamine. Yes, we reacted with the glucose. We got glucose oxime. Hydrogen cyanide, we reacted with the glucose. We got glucose cyanohydrin. With the bromine water, glucose give you gluconic acid. But 2,4-DNP reagent, 2,4-DNP test, Schiff test, sodium hydrogen sulfide test, these all are not given by glucose. You know, glucose, that aldehyde group won't remain for a long time because when it forms the cyclic form, aldehyde group is not remaining. 2,4-DNP test is actually given by all aldehydes, but glucose, even though it contains a aldehyde, it's not giving the test because that aldehyde group converted to some other when converted to cyclic form. Which among the following is a water-soluble vitamin? Water-soluble vitamins are which one? Vitamin B and C except vitamin B12. So vitamin C, yes, water-soluble is a water-soluble vitamin C. You know, vitamin A, D, E, K are fat-soluble vitamin. What are the hydrolysis product of lactose? You know, lactose is a disaccharide. Lactose is made up of which one? Beta-D glucose and beta-D galactose. Beta-D glucose and beta-D galactose. So we can go with option A, right? Beta-D galactose and beta-D glucose. Alpha-D glucose are the monosaccharide of which one? Maltose. Alpha-D glucose and beta-D fructose, that is for sucrose. Lactose is by beta-D glucose and beta-D galactose. Which of the following is incorrect about glucose? It contains 4. What is the structure of glucose? I think they are asking structure based question. We have CH2OH, then we have OHH, OHH, then we have HOH, then we have OHH, then we have CHO. Question, read it once again. Which of the following is incorrect for glucose? It contains 4 CHOH group. Secondary, right? What is this meaning? This carbon having 2 bonds. Yes, this carbon, see, these all carbons are secondary alcohol. It contains CHOH, CHOH, CHOH. Yes, 4 are there, correct? It contains 1 CH2OH. Yes, it contains 1 CH2OH. It contains 1 CHO group. Yes, 1 aldehyde group. It contains 1 CO group. No, the CO group, which especially the ketone group, is not in glucose. That is in which one? Fructose, right? So it contains 4 CHOH. Yes, that's everything correct. The amino acid which can be synthesized in the body are known as. Amino acid we classify into 2, essential and non-essential. The amino acid which can be synthesized in the body, that is called what? Non-essential amino acid. What is essential amino acid? The amino acid which cannot synthesize in body, only getting through food, is called which one? Essential amino acid. So amino acid which can synthesize in the body, it is non-essential. Sucrose is a dash. You know, sucrose is a dextrorotatory one. And on hydrolysis, it give a product mixture contained from hydrolysis gives dash. It become what? Levo in nature. Right? You know, sucrose on hydrolysis, it will give you glucose and fructose. Sucrose is initially dextrorotatory. On hydrolysis, it will give you dextro, glucose and levofructose. Overall, the sign of the dextro and levo will be big negative. That will be overall, it will be levo. So dextro become levo, that is called, sucrose is called invert sugar. So sucrose is a dextrorotatory compound and the product mixture obtained from hydrolysis is levorotatory in nature. So dextro become levo. Dextrorotatory becomes levorotatory. Which of the following statement is incorrect with respect to starch? First, it is a reducing carbohydrate. It is a polymer of alpha-D glucose. It gives blue color with iodine. It consists of branched chain. Question, which is incorrect with respect to starch? Which all are the most familiar to you? It is a polymer of alpha-D glucose. Correct or not? Which one they are asking? Starch, right? Yeah, starch is made up of alpha-D glucose. It gives blue color with iodine. Yes, starch give a blue color with iodine forming the complex. It consists of branched chain. Yes, so starch contain amylose and amylopectin, where amylopectin is branched one. Correct. It is a reducing carbohydrate, so that is the incorrect statement, non-reducing. Okay. The branching in the dash component of starch occurs by the glycosidic linkage between. Which is the branching component of starch? Amylopectin, right? Amylopectin. Amylopectin, the connection is between C1 and C6. C1 and C6. So option D, amylopectin, C1, C6. So branching in amylopectin component of starch occur by the glycosidic linkage between C1 and C6 are the connection. Deficiency of vitamin B1 causes. Vitamin B1 deficiency causes, dear, beriberi. Deficiency of vitamin B12 causes pernicious anemia. And deficiency of vitamin D causes what? Rickets. Type of bond between two nucleotide. What is the name of the bond between two nucleotide is called? That is phosphodiester linkage. That is an ester linkage, right? Difference between two nucleotide is ester linkage. What is the correct general formula of carbohydrate? CXH2O white time. What is the correct general formula of a carbohydrate? CXH2O white time. Carbohydrates that yield 2 to 10 monosaccharide unit on hydrolysis are called what? Oligosaccharide. If that carbohydrate dissolve in water, if it giving 2 to 10 monosaccharide, what we call? Oligosaccharide. If a monosaccharide contain an aldehyde group, it is known as aldose. With the 6 carbon, you can call aldohexose. With the 5 carbon, aldopentose, like that. So if a carbohydrate contain aldehyde group called aldose, if it contain ketone group is called ketose. How much percentage of constituent of starch in amylopectin? Amylose is around 15 to 20%, remaining 80 to 85% is which one? Amylopectin. Amylopectin is around 80 to 85% of which one? Starch, dear all. So I think the majority of the chapter, the concept, all the MCQs we completed. So study the theory very well again and go through the questions once again. 100 MCQs are there, PYQs are there, NCERT questions are there, more than enough. So repeated question. From this you can see the repeated question for your upcoming board exam also. Go and study, all of you, and keep doing hard work. All the best. Hi students, welcome to Brilliant Qatar. In this session we are discussing the most important 100 MCQ from the chapter Alcohol, Phenols and Ethers, one of the important organic chapter. Let us start from question number 1. Out of the following, this is the 2024 board MCQ question. Out of the following alkene, the one which will produce tertiary butyl alcohol. What is tertiary butyl alcohol? You know the structure, right? This is our tertiary butyl alcohol. Ready? These all are alkenes. How we can convert alkene to alcohol? That is our first preparation in the chapter. Alkene on acid hydrolysis, we will get alcohol. So which alcohol on acid hydrolysis? What do you mean by acid hydrolysis? Add water in acid medium. So where you will get the tertiary butyl alcohol? Here it's very clear, option D. Let me just show you the reaction. CH3 is the compound, double bond CH2, right? This is the compound D. To which when you add H2O in presence of acid, H2O contain H plus and OH minus ion. What is Markovnikov's rule? We will follow normal Markovnikov's rule. Negative part goes to carbon with less hydrogen, positive part goes to carbon with more hydrogen. We will get tert-butyl alcohol, right? So option D is the compound which give you tert-butyl alcohol on acid catalyzed hydration. Ready? Question number 2. When phenol react with bromine water, bromine water is a highly brominating agent, right? Strong brominating agent, bromine water. If you use phenol is a very strong ortho-para directing group. bromine water is ready to give maximum bromine. So what happened? All the bromine goes to all the ortho and para position. You will get 2,4,6 tribromophenol, and its color is, just note it all, it's a white precipitate. Phenol on strong bromination, we get 2,4,6 tribromophenol, which is a white precipitate. Okay, so you will get a white precipitate here. Moving to question number 3. Which of the following compound is formed when secondary alcohol are oxidized? You know, primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. Secondary alcohol on oxidation we get ketone. Ready? So remember all. Primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. What about tertiary alcohol? They do not undergo oxidation. Okay. Next question number 4. Which of the following process does not result in the production of alcohol? Which of the method is not belongs to the preparation of alcohol? Acid catalyzed hydration of alkene. Just we discussed alkene on acid catalyzed hydration, we get alcohol. Ready? Free radical halogenation. No. B do not give you any alcohol. What is free radical halogenation of alkane to an alkane? When you add halogen in presence of light, that is our substitution reaction. What happened? You will get haloalkane, not alcohol. Reduction of aldehyde. Yes, aldehyde on reduction we get primary alcohol. Hydroboration oxidation. Yes, we studied hydroboration oxidation is a method of preparation of alcohol. So B is the answer. 5. Conversion of trialkyl borane to an alcohol does not require. Do you remember hydroboration oxidation reaction? Let me just to show you that. We have propanol. We have I think we will start from the alkene propene, right? Propene. You know, hydroboration oxidation is a preparation of alcohol from alkene. This is the one example given in textbook. Take propene and we are treating with a diborane. What is diborane? B2H6. When you treat with a diborane, you will get the compound CH3, CH2, CH2, thrice B. What it's called? Trialkyl borane. This is called hydroboration. Hydrogen and boron addition called hydroboration. Next step, oxidation. Oxidation is done by the help of hydrogen peroxide, base and water. Hydrogen peroxide, base, water. You will get the compound propanol, right? Propanol is the product. So propene to propanol is carried by hydroboration oxidation. Question: which of the following is does not require in the oxidation in the last step? We need water, hydrogen peroxide and base. We don't require diborane. Diborane is required only in the first stage, right? The conversion of trialkyl borane to this alcohol does not require diborane because diborane used in the first reaction. Next one, which of the following alcohol is not polyhydric? What do you mean by polyhydric? Many OH group means more than two OH group if they contain, they are called a polyhydroxy. So which of the following alcohol is not polyhydroxy? 2 or more, that called what? Polyhydroxy. Okay, what is propylene glycol? Propylene means total 3 carbon with, you know, what is glycol? Glycol means 2 OH group on adjacent carbon. What is ethylene glycol? Ethylene glycol means ethylene on which 2 OH group. Ready? What is cyclohexanol? Cyclohexanol is this one. And what is benzene 1,2-diol? Benzene 1,2-diol. Question: which is not a polyhydric? What is the answer? Option C. What do you mean by polyhydrics, dear? They contain 2 or many OH group. These all are polyhydroxy. This is monohydroxy. Next one. Among the following alcohol, which would react fastest with the concentrated HCl and zinc chloride? What is concentrated HCl and zinc chloride? Lucas reagent, right? What is the purpose of Lucas reagent? To distinguish between primary, secondary, tertiary alcohol. See, Lucas test is given by which alcohol faster? Tertiary. Lucas reaction given by tertiary alcohol faster than secondary and primary. You know, tertiary alcohol give immediate turbidity. Secondary alcohol give turbidity after 5 minutes. Primary alcohol do not give precipitate, only by heat. So question, among the following alcohol, which would react fastest with Lucas mean tertiary. Which is a tertiary alcohol, dear? 2-methyl-butanol. 2-methyl-butanol, right? This is the tertiary alcohol. 2-methyl-butanol is the tertiary alcohol. Yes or no? All right. So pentanol is primary, not that. Pentanol not secondary. So 2-methyl-butanol is the secondary, and therefore it will give the Lucas test faster. Next question. Heating of phenyl methyl ether. What is phenyl? This is what phenyl. This is what methyl and ether. Phenyl methyl ether is nothing but anisole. Okay. Is reacting with what? HI. Heating with HI. You know, hydrogen iodide contain H plus and I minus. Do you remember the ether bond breaking, dear? In aromatic ether, what is the condition? In aromatic ether, this is the condition. After breaking, we should get phenoxide ion. What is phenoxide ion? Benzene with O minus. After breaking, so which bond break? We can break it this one. So you get phenoxide and methyl. To the O minus, this H plus get attacked. You will get phenol as one of the product. Plus to the CH3, iodine will attack, you get CH3I. So what is the product? Heating of phenyl and will produces phenol. Yes, phenol is there. Actually, one more product is there, methyl iodide. Question number 9. The alcohol, okay, 8 over, right? Okay, 9. The alcohol which is also known as wood spirit, that is methanol. Wood spirit is what? Dear, there is in one page in your textbook of alcohol phenol chapter they given. Methanol and ethanol industrial preparation. Okay, please carefully study that. Methanol is also called wood spirit, right? Wood spirit because it's produced by the is a byproduct of the wood distillation. Next one, find out the correct order of acidic strength among the following. Phenol, water, ethanol. What is the order? You know, phenol is more acidic than normal alcohol, and we have water and we have normal alcohol, aliphatic alcohol, ethanol. You know why phenol is more acidic, dear? When it lose this H plus ion, it giving more stable phenoxide ion. Therefore, phenol is more acidic. And water, you know, water contain HOH, right? And ethanol means what? C2H5OH. You know the main factor affecting acidity, EWG. EWG is there, electron withdrawing group is there, that make the compound more acidic. Electron donating group decrease the acidity. You know, alkyl groups are plus I effect. They are EDG. EDG decrease the acidity. Therefore, ethanol least, then water, then phenol. So correct order, dear, phenol greatest, okay? Correct order, phenol, water and ethanol, option B. Question number 11. Which of the following reagent may be used to distinguish between phenol and benzoic acid? Dear, phenol, if they mention in distinguishing test, then there is a very special name reaction is there, which you made it in the practical also. That is our neutral ferric chloride test. What happened when phenol react with the neutral ferric chloride? Neutral ferric chloride, hydrogen combined with Cl, HCl goes. Iron combined with the phenoxide, Fe combined with the phenoxide ion 6 times and 3 minus. It form a complex having violet color. This is a clear cut a distinguishing test of which one? Phenol. Phenol when react with a neutral ferric chloride, you will get a violet colored complex. This is only given by phenol compounds. So phenol one. So neutral ferric chloride is the best reagent to distinguish between phenol and acid, because acid do not respond this test. Next question number 12. Rate of dehydration of alcohol. Dear, dehydration is elimination, right? Removal of water, right? Elimination mainly follow which mechanism? That's SN1, stability of carbocation. General, okay, general. Beta elimination, dehydration. These all reactions follow SN1 mechanism. You know SN1 mechanism, what is the order? Tertiary, secondary, primary, right? So tertiary, secondary, primary, then methanol, option B. Question 13. Phenol on heating with a phenol on heating with a chloroform and NaOH gives salicyl aldehyde. Yes, we know salicyl aldehyde. What is the complete reaction actually? First you will get sodium phenoxide and CHCl2. This again we react with NaOH and this one acid. we will get which one? Salicyl aldehyde. What is salicyl aldehyde? OH and CHO. What is salicyl aldehyde preparation is called known as Reamer-Tiemann reaction. If it is salicylic acid, what you call? Kolb's reaction. Next one, 14. Which of the following is a secondary alcohol? Option A, 2-methyl-butan-2-ol. 2-methyl-butan-2-ol. Here it's tertiary, right? Because OH connected carbon connected to 3 carbon. It's tertiary. Option B, 3-methyl-butan-2-ol. 3-methyl-butan-1-ol. Here this OH connected carbon only connected to 1 carbon. It is primary, not that. 2-methyl-butan-1-ol. 2-methyl-butan-1-ol. Again this OH connected carbon connected to 1 carbon. It's primary. 3-methyl-butan-2-ol. 3-methyl-butan-2-ol. Yes, the OH connected carbon connected to 2 carbon. Yes, it is secondary. That is option D. So how you judge it? Primary, secondary, tertiary? The OH connected carbon directly connected to how many carbon? If the OH connected carbon connected to 1 carbon, it's primary. 2 carbon, secondary. 3 carbon, tertiary. Next one. When salicylic acid is heated, what is salicylic acid here? Salicylic acid is alcohol and acid in the adjacent position. That's called a salicylic acid. Is heated with a zinc dust. What is the main product? Do you remember? Phenol, when treated with the zinc, it becomes benzene. Because Zn take this oxygen out, ZnO eliminate. So what is left? Benzene with the COOH. What is benzene with the COOH? Benzoic acid. You know, phenol when react with, okay, phenol, we studied this reaction here. Phenol when react with the zinc dust, it become benzene. Yes, that's what happened. But acid remain the same. Ready. Next one. What is the general formula of an aliphatic alcohol? What are aliphatic alcohol? We can write ROH, right? Aliphatic alcohol means there is an aliphatic alkyl group and alcohol OH group. Next one, which of the following is true regarding polyhydric alcohol? What do you mean by polyhydric alcohol? They contain OH group, 2 or many. So it should have 1 or more, no? It should have 2 or more OH group. They are called what? Polyhydric alcohol. Which of the following type of alcohol contain a bond between sp2 hybridized carbon and OH group? Can you say dear? See, that is very clear. You may study it in haloalkane chapter also. Vinylic. What is a vinyl group? CH2 double bond CH. This is called vinyl with alcohol. Now you see the alcohol connected to which carbon? sp2, right? sp2 carbons are there. So which of the following type of alcohol contain a bond between sp2 hybridized carbon and OH, right? sp2 hybridized carbon is on vinylic, option D. Which of the following term does not describe this compound? Is it a primary alcohol? Yes, because the OH connected carbon connected to 1 carbon, it's primary. Is it monohydric? Yes, because it contains only 1 OH group. Is it allylic or vinylic? Check it all. The alcohol connected carbon, this is what? sp3, this is what? sp2, this is what? sp2. Can you say what is this pattern? sp3, sp2, sp2 is allylic. Right? It's an allylic alcohol. It's not a vinylic. What is meant by vinylic? The alcohol connected is sp2, again sp2. What is allylic? sp3, sp2, sp2. Ready? Next one. Choose the most suitable classification of the shown compound. Most suitable classification. Is it a secondary alcohol? No, because the OH connected carbon connected to 3 carbon, it is tertiary. Is it allylic? Let me check. OH connected carbon, this is what? sp3, this is what? sp2, this is again sp2. Yes, this is what? Allylic, correct? Allylic alcohol. Is it dihydric? No, it's monohydric because it contains only 1 OH, not benzylic. Ready? Next one, choose which of the following is not a vinylic, not a vinylic. What is mean by vinylic alcohol? The alcohol connected to sp2, again sp2. That is called vinylic. So here OH connected is what? sp2. How to check it sp2? Double bond connection is there or not? There sp2. So sp2, sp2. Yes, it's vinylic. Here alcohol connected to what? sp2, sp2. Yes, vinylic. Here alcohol connected to sp3, sp2, sp2. No, this is not vinylic. What about this OH connected to sp2, sp2, vinylic. So option C is not vinylic, it is allylic. Right. Next one. Which of the following is not an aromatic ether? Means aromatic means what? Benzene should be there. Right. What is the first compound? C6H5 means what? Phenyl. So OCH3. Yes, it's an aromatic ether. Option B, dear. What is option B? CH3, OCH2, CH3. Is it contain any aromatic? This is both are aliphatic, right? So this contain phenyl, phenyl, phenyl. Phenyl means what? Benzene, aromatic. Next one. What is the correct order of acidity of alcohol? Which alcohol is more acidic? Let me take it a primary alcohol. Let me take a secondary alcohol. And let me take a tertiary alcohol, right? Tertiary alcohol. Which alcohol is more acidic? Can you say, dear? What is the difference between primary, secondary, tertiary alcohol? The number of alkyl group. Only one alkyl group, two alkyl group, three alkyl group. You know, alkyl groups are EDG plus I effect. Alkyl groups are electron donating group. They will decrease the acidity. So where more alkyl group, where less acidity. So what is the order? Primary greater than, secondary greater than, tertiary is the order of acidity. Question 24. What is the IUPAC name of salicylic acid? What is salicylic acid? Salicylic acid mean OH and COOH on adjacent. Here which is the main functional group? Acid. So this is 1, this is 2. So what is the name? 2-hydroxybenzoic acid. 2-hydroxybenzoic acid, option 3. Next one, which of the following alcohol produce turbidity immediately when react with the Lucas? Lucas reagent turbidity given by tertiary alcohol faster. Which is a tertiary alcohol? No doubt, tert-butyl. You know what is tert-butyl? This group is called tert-butyl alcohol. Ready? When reacted with this one. Which compound results in the formation of the most stable carbocation on dehydration? We said that dehydration follow SN1 mechanism. Stability of carbocation is the factor. Let me check it. Option A. Option A is what? CH3 thrice and OH. What is the first step in dehydration? The OH leave, you will get a carbocation. See all? It is a tertiary carbocation. So this will undergo reaction faster. So what is the stability order of, what is the reactivity order of dehydration? Tertiary greater than, secondary greater than, primary. Ready? So tertiary will undergo reaction faster. On treatment with the excess bromine water, phenol give, we discussed that phenol when treated with the bromine water, it will give you 2,4,6 tribromophenol white precipitate. 2,4,6 tribromo, right? There is a 2,4, yeah, that's all. 2,4,6 tribromophenol. Don't forget the color, white precipitate. Next, the reagent used for converting ethanol. What is ethanol? C2H5OH to what? Acetic acid, CH3COH. Dear, a primary alcohol, if you want to directly convert into acid, we need a strong oxidizing agent. What is a strong oxidizing agent here? Acidified potassium permanganate, KMNO4. Acidified KMNO4 is the strongest oxidizing agent. It will give you a primary alcohol directly to what? Acid. Now, the reagent used for the formation of 1-phenyl ethanol. What is that 1-phenyl ethanol? Eth means 2 carbon, 1-phenyl ethanol, right? This is the compound, okay? 1-phenyl ethanol. If you want to get this compound from benzaldehyde, what is benzaldehyde? Benzene with what? CHO. What is the reagent? Here, benzaldehyde on benzene 1 carbon. But in the product, there are 2 carbons. So we need to increase 1 carbon extra, mean bring the Grignard reagent. What is the Grignard reagent here? Methyl bromide. Yeah, this one. Methyl bromide and magnesium. What is methyl bromide? CH3Br. What happened that react with the Mg? You will get CH3MgBr. That is our Grignard reagent. So take our Grignard reagent all. You know Grignard reagent CH3MgBr. What are the ion? Mg plus and CH3 minus. So this will at nucleophile attack on this. O become O minus. To the O minus MgBr we will attack. You will get CH O minus MgBr and here CH3 attack. What is the last step? Acid hydrolysis. Add water in presence of acid. What are the ions in water? H plus and OH minus. So H plus go to this O minus, OH minus go to this Mg. You get CH benzene, CH, CH3, OH. So answer is which one? Option 4. So if you want to increase one carbon in aldehydes and ketone, mostly Grignard reagent is the attacking one. Next one, methyl alcohol react with, what is methyl alcohol? CH3OH. Methyl alcohol react with sulfuric acid at 4, sulfuric acid H2SO4 at 413 Kelvin. Please remember dear, 413 Kelvin. We know alcohol when heated with the acid at 443 Kelvin, it undergo dehydration. But at 413 Kelvin, it forms ether. If you use methanol, it will give the ether, that is methoxymethane. Methoxymethane. If you use ethanol, you will get ethoxyethane like that. Okay. So careful. Alcohol when heated with the acid at 443 Kelvin, dehydration. At 413 Kelvin, ether formation. Next one. Which of the following has the highest boiling point? Highest boiling point. Propanol, it's an alcohol. Propane is a hydrocarbon. Methoxyethane is an ether. And N-butane is again hydrocarbon. See, mainly the one which is depend on the boiling point is what? Mass and the hydrogen bonding. Which one make more hydrogen bonding in this one? Alcohol make more hydrogen bonding. You may study the general order of the boiling point here. Just note it all. The boiling point order is mainly one. Main boiling point is for carboxylic acid, then alcohol, then aldehydes and ketone, approximately same one, then ether, and then we have hydrocarbon, that is been alkane and alkene all. Okay, so main functional group, these are the just a priority order of their acidity. Alcohol is the highest acidic among this one, option A. 32. What is the order of the acidity? Dear, remember this point carefully. Electron withdrawing group increase acidity, electron donating group decrease acidity. Remember that point, okay? Chlorine is an electron withdrawing group. You know, chlorine is a slight donating and withdrawing in this benzene. And alkyl groups are pure EDG. Nitro is a very strong EWG. And methoxy group also a strong donating group. So who make more acidity? Withdrawing groups, right? Which is the most withdrawing group? Nitro, then chlorine, okay? Among nitro and chlorine, nitro is the more withdrawing. So it make more acidity. So third one greatest, then first one. Third one, first one, right? And what about this 4 and 3? Methyl and methoxy, when you consider, methoxy is more donating. More donating means least acidic. Okay. Therefore, fourth one is least. Ready? Next one. The final product formed when benzyl ethyl ether. What is benzyl group? Benzene with an sp3 carbon. This is called benzyl. Benzyl ethyl. Okay. Benzyl ethyl ether react with the hydrogen iodide. Okay, hydrogen iodide. This is also our ether bond breaking. Remember, we have H plus and I minus. Where which bond you can break, whether the left one or the right one. Which will you break? I am going to break the left one. If you break the left one, oxygen always get negative, carbon get positive. What is this group is called? Benzyl. Benzyl carbocation is highly stable due to resonance. So break this bond here if you have benzyl group. So to the plus, the minus comes. So what is comes here? To the benzyl iodine attack. What do you get? Benzyl iodide. Benzyl iodide. Benzyl iodide. What is the other one? To the O minus, this H will attack. So what do you get? C2H5OH, ethanol. Benzyl iodide and ethanol get formed. 34. The major product formed when anisole. What is anisole? Benzene with OCH3. Anisole when react with the bromine in ethanoic acid. It's bromination. Anisole is a ortho-para directing group. So what you get? Ortho-bromo-anisole and you get ortho-bromo-anisole and para-bromo-anisole. Okay, ortho-bromo and para-bromo. You know, in MM, ortho and para-bromoanisole, which is the main group, para is the majorest one. So the major product will be para-bromoanisole, option A. 35, formaldehyde react with grignard. Remember dear, what is formaldehyde? HCHO. Formaldehyde when react with the Grignard reagent, you will get always primary alcohol. The other aldehydes when react with the Grignard, that means other than methanol or formaldehyde, ethanol, propanol, other aldehyde when we use, always you will get secondary alcohol, and any ketone when react with the Grignard reagent, you will get tertiary alcohol. Please remember, okay? So formaldehyde when react with the Grignard reagent, we will get primary alcohol. 36. Phenol can be obtained by dash of sodium phenoxide. What is sodium phenoxide? Sodium phenoxide is ONA. To which what we will add actually HCl. So Na and Cl cut. Yes, we will get phenol. So what is HCl addition process we call? Acidification. Sodium phenoxide on acidification we get phenol. 37. Cumene hydroperoxide. Hope you remember the cumene preparation. What is cumene? Cumene is a isopropyl group. A isopropyl group on benzene is called cumene. First, when react with the oxygen, what we will get? The oxygen get added in between this C. You will get OOH. OOH. And the CH3. What do you call this compound? Cumene hydroperoxide. This on acid hydrolysis, we get the product as what? Phenol and acetone, right? Propanone. These are the byproduct. Phenol is the main one, acetone is the byproduct. So cumene hydroperoxide is this one. On treated with acid, what you get? You get phenol and acetone. 38. Identify the compound X. Where is X in this compound here? This simple reaction. How you convert benzene to, what is this benzene with the SO3H is called? Benzene sulfonic acid. How you convert benzene to benzene sulfonic acid? Treated with a fuming H2SO4 called what? Oleum. Fuming H2SO4, what you call? Oleum. So benzene treated with the oleum, we get benzene sulfonic acid. Next one, which of the following is the least soluble in water? Least soluble in water. See, all are alcohol, right? All are alcohol. You know, alcohols are highly soluble in water because they can form very strong intermolecular hydrogen bond with the water. But all are alcohol, which one is less soluble? What is the condition? Butyl, pentyl, hexyl, heptyl. As the number of carbon increases, the solubility decreases. So which one having greatest carbon? N-heptyl, so solubility lesser. Question number 40. Which of the following has the highest boiling point? Highest boiling point. Here again, all are alcohol. Alcohols have high boiling point due to strong intermolecular hydrogen bond. So, and you check where you know, branches increases, boiling point decreases. Mass increases, boiling point increases. So, proper, we can cut it. Anyway, very simple. Proper butyl-pent. Pent having the greatest number of carbon. As the number of carbon increases, boiling point increases. Next one. Monochlorination. Monochlorination means one chlorine we are adding of toluene. Alright. So let me toluene. What is toluene? Benzene with a CH3. Toluene when undergo chlorination in presence of light. What happened? Chlorine goes to, you know, substitution. Substitution means chlorine goes to this position, right? You will get benzene with a CH2Cl. What you call this compound here? Benzyl chloride. Ready? Followed by hydrolysis with aqueous NaOH. What happens if you treated with aqueous NaOH or aqueous KOH? The NaCl out, OH group comes, you will get benzyl. This group is called benzyl, okay? OH comes. What is the product here? Benzyl alcohol is the product, option 4. 42. How many alcohol with the molecular formula C4H10OR? Chiral in nature. You know what is chiral? The carbon, all 4 bonds are connected to 4 different groups or atoms. Let me write the possible structure of the compound faster, okay? Total 4 carbon, right? Okay, we can write butane 1-ol. Okay, next we can write butane 2-ol. Yes, butane 2-ol. Next, now let me change the position of the alkyl group. I can write this another alcohol and I can write a tert-butyl alcohol also. So these are the possible structure of which one? This alcohol with the 4 carbon. Here, how many of them are chiral? I will say there is only one. Only one is chiral. Which one? The second one. You see, this carbon, you check it out. This carbon is chiral. Because this carbon connected to OH group, H, methyl and ethyl. See, all four are different. You check other group, there is no chiral carbon in this one. So among these four, there is only one is chiral in nature. 43. What is the correct order of the reactivity of alcohol in this reaction? What is HCl and ZnCl2? Lucas reagent. Lucas reaction follows the order tertiary greater than secondary greater than primary. You know, tertiary will give immediate turbidity because it follow SN1 mechanism. So tertiary, secondary, primary, option 3. This is what? Ethanol. Ethanol can be converted into ethanol. A primary alcohol, if you want to convert into aldehyde, we have many reagents, PCC, anhydrous CrO3, copper at 573. Which is the best reagent to convert a primary alcohol to aldehyde? PCC, that is our pyridinium chlorochromate. Best reagent to convert a primary alcohol to aldehyde is PCC. 45. The process of converting alkyl halide. What is alkyl halide? For example, RCl. Into alcohol, what is that? ROH is called, which reaction? Removal of chlorine, substitution of OH group. What do you call that? Nucleophilic substitution. Nucleophilic substitution, right? You studied in haloalkane chapter. Removal of halogen, bringing OH group. What is that called? Nucleophilic substitution. We are treating with the aqueous KOH and all right. Next, 46. What is the IUPAC? Simple question. Here, chlorine is there, OH is there. Which is the main functional group? OH. So this is 1, 2, 3, 4, 5, 6. 5-chloro. What is the answer? Option 3. 5-chlorohexane-2-ol. Ready? Simple. Question number 47. What is the IUPAC name of metacresol? What do you mean by cresol, dear? Cresol mean phenol with a methyl group. Phenol with a methyl group is called cresol. Meta means we place it in the meta position. So 1, 2, 3. 3-methyl phenol. 3-methyl phenol. So we have 3 compounds like this one. Orthocresol, metacresol, paracresol. Change the position. Okay. And what is the IUPAC name of this ether? Ether is given as CH3, CH and CH3. Then OCH3. How to name this ether? See the ether left and right. Where is the biggest chain? Left. So select the parent 1, 2, 3. So this is the branch methoxy. Where the methoxy presents second position. So 2-methoxypropane. 2-methoxypropane is the compound, right? 2-methoxypropane. Next, which of the following compound will react with the sodium hydroxide solution in water? Dear all, sodium hydroxide is a base. So what they're asking actually, which is more acidic? The one which is reacting more with the sodium hydroxide, that indicating which is more acidic, okay? So which of the following compound will react with the sodium hydroxide solution in water faster, right? Which of the following compound will react with the sodium hydroxide solution in water faster, okay? That's actual question. Which is more acidic here? This is aliphatic alcohol, aliphatic alcohol, aliphatic alcohol. This one is phenol, dear. We know phenol is more acidic because when it loses this H plus ion, it forms phenoxide ion. Okay. Remaining all OH is connected to the alkyl group. Alkyl alcohols are very least acidic than which one? Phenol. Next one. Phenol is less acidic than. Phenol is less acidic than which compound? Can you say, dear? Phenol is less acidic, or from the option which is more acidic. I will go with this nitro, because nitro is a electron withdrawing group. You know, electron withdrawing group make the compound more acidic, right? So nitro, ortho, nitro, phenol. You know, methyl and methoxy all are EDGs. They will decrease the acidity. Next, which of the following is most acidic in nature? I will just draw the structure. First one is benzyl alcohol, alright, benzyl alcohol. Second one is cyclohexanol, alright. Third one is phenol, alright. Next one is metachloro. Fourth one is metachlorophenol. Which is more acidic, dear student? Dear, tell me. This is like a aliphatic. OH is not on benzene. OH, this is not benzene. This is, yes, this is highly acidic. It's also, phenol is more acidic than normal alcohols, right? Aliphatic alcohol. So what about with the among D, third and fourth, which one? Chlorine is an EWG. EWG, electron withdrawing group, make more acidity. So let's go with the fourth option. Question number 52. Mark the correct order of decreasing acid strength. Let us see here. All are phenol, all are acidic, right? Nitro is an EWG, methoxy is EDG, nitro is EWG, methoxy is EDG. You know, withdrawing group make more acidic. So B and D are more acidic. Among B and D, which is more acidic? I will go with the para instead of meta, because para position, whatever the group present, that effect will be more. If para position nitro group present, its withdrawing effect will be more. So para having greatest, therefore B greatest, then D. So option 2. BD, after that without any EDG, this one, and then B and E, when you check it, what you can say? I told you para position, if any group comes, its effect will be more. Here you see methoxy, the electron donating group is in para. So in para effect, that para position, if methoxy present, its donating effect will be more. Donating effect will be more. So this one more donating, therefore least acidic here. Ready? Question number 53. Arrange the following compound in increasing order of boiling point. Boiling point mainly depend on two factors here. One is mass. Greater the mass, greater the boiling point. Second one, functional group and branching. So here all are alcohol, right? Propanol, butane 2-ol, butane 1-ol, pentanol. See, propanol mean 3 carbon with OH. Butane 2-ol mean 4 carbon with second position OH. Butane 1-ol means 4 carbon OH. And pentane 1-ol means 5 carbon with OH. Which one having greatest mass? Pentane 1-ol. So greatest. Among butane 2-ol and butane 1-ol, which one having greatest boiling point? Butane 1-ol, because there is a branch in butane 2-ol. Branches comes, what happen? Boiling point decreases. And this one. So which is the correct increasing order? Like I think it's option A. Pentane 1-ol is the highest, then butane 1-ol, then butane 2-ol, then with less carbon, propane 1-ol. 54. The carbon, oxygen, hydrogen bond. Please remember all. In alcohol, what is alcohol general formula? For example, let me take methanol. CH3OH, right? CH3OH. You know, oxygen contain 2 lone pair. Let me take an ether, methoxymethane. What is methoxymethane? CH3OCH3. There is a lone pair, Ready. You know what is normal tetrahedral structure? Let me take it for example, methane. Tetrahedral bond angle is 109.5 degree. Okay. Tetrahedral bond angle is 109.5 degree. Question. The carbon, oxygen, hydrogen bond angle in alcohol is slightly less than the tetrahedral bond angle. You know what is the reason? The lone pair repulsion in the alcohol. Lone pair repulsion is more. So this bond come close. So in alcohol, the bond angle is less than tetrahedral. Correct. They already mentioned that. Whereas, why the carbon, oxygen, carbon bond angle in ether is slightly greater than this tetrahedral? You know, it's around 110 degree. Why in ether the bond angle is greater than this tetrahedral? Because of the bulky group. The bulky group will do not come closer, they will repel, so bond angle increases. So what is the answer? Option A of the repulsion between the two bulky groups. So remember all. In alcohol, why the bond angle is lesser? Because of lone pair repulsion. In ether, what is the bond angle greater? Because of the bulky group repulsion. Ready? Next one. An alkene is already we discussed here. What is this alkene? Propene. Propene when treated with what is this? Diborane. You will get trialkyl borane. That's on hydroboration over. Next to oxidation we will do it. Propene become propanol. We did already this question, so I'm just writing the answer here. Propanol. Next, choose the correct X and Y from this one. Choose the correct X and Y. What you understood from the first figure here? NaBH4. Come on, what is NaBH4? It is a reducing agent. It converts aldehyde to primary alcohol, ketone to secondary alcohol. So dear, this is a ketone. No doubt, ketone becomes secondary alcohol. So that become OH. What is this? It's not an ether, dear. This is RCOOR. It is an ester. Ester do not disturb by NaBH4. Don't touch it. Okay. So ester remain as it is CH2CO OCH3. This is the first product. Okay, here also NaBH4. NaBH4 will reduce ketone to secondary alcohol and aldehyde to primary. Can you see there is an aldehyde group? Yes, that become alcohol. So what is the product? CH3, CH2, CH3 and CHO become CH2OH. Check where these changes are present. So OH, CH2, CO, CH3, CH2, CH2, right? Option C, dear. See, OH, then the ester is remain as it is and finally becomes CH2OH. Question number 57. 1 mole of ethyl acetate. What is ethyl acetate? You know, this is acetate, CH3, COO, C2H5. This is called ethyl acetate. Ester. Ester when react with the excess of LiAlH4. You know what happened? You know what is LiAlH4? Reducing agent. Ester when reduced, you will get 2 alcohol. How we get 2 alcohol? Very simple, dear. Just to cut the CO bond, only to understanding, okay? Ester and react with the LiAlH4, that bond break. Which bond? CO bond just to break. How many carbon left side? 2 carbon. 2 carbon alcohol is what? Ethanol plus. How many carbon right side? 2 carbon. Again you will get ethanol or ethyl alcohol. So you will get 2 ethanol molecule. So what is that? 2 moles of ethyl alcohol. So ester on reduction we get 2 alcohols. Next one. Tertiary butyl alcohol can be prepared by tertiary butyl alcohol. What is tertiary butyl alcohol? This is the tertiary butyl alcohol. Right. It's a tertiary alcohol. I told you that if you want to get a tertiary alcohol, you should take a ketone with what? Grignard reagent. Ketone when react with the Grignard reagent, you will get tertiary alcohol. So aldehyde, no. Acetone and methyl. What is acetone, dear? Acetone is propanone. Yes, acetone is propanone plus what? Methyl magnesium iodide. Yes, that is our Grignard reagent. So formaldehyde will give primary alcohol, we discussed. And even this also possible, right? Butanone, it's a ketone and a Grignard reagent. So option B or D, how to judge it? See, acetone contain 3 carbon and the methyl magnesium contain 1 carbon. So total 4 carbon. Yes, we need 4 carbon. So answer is option B. Why not option D? Butanone already contained 4 carbon and methyl magnesium, the Grignard reagent 1 carbon. So your compound should contain 5 carbon. No, we need only 4 carbon, right? So that is what B. So remember, ketone when react with the Grignard reagent, we get tertiary alcohol. Now, in the following sequence, what is the final product Q? What is happen? Benzene react with the oleum. Benzene when react with the oleum. What is oleum? Fuming H2SO4. We get benzene sulfonic acid. Benzene sulfonic acid first react with the NaOH. Second, on acidification, you will get phenol. It's a preparation of phenol from benzene. So compound is what? Phenol. Dear, in the textbook, you studied 4 preparation of phenol, right? One is from benzene, one is from aniline, one is from cumene and all, right? So those kind of reaction and those process chlorobenzene also there. Next one, 60. Cumene on reaction with the oxygen followed by, we already discussed cumene on reaction with the oxygen. First you will get cumene hydroperoxide. That's on acid hydrolysis. You will get phenol and acetone. What is the product? Phenol and acetone. Where is phenol and acetone, dear? Phenol, C6H5OH is phenol, CH3COC, right? Anisole. Sorry, phenol and acetone. Which of the following reaction will not yield phenol? I just told you there are 4 preparation of phenol in textbook, which is not a preparation of phenol. Come on, dear. Chlorobenzene. How you convert chlorobenzene to phenol? Dose process. What is dose process? First aqueous NaOH, then at 623 Kelvin and 300 atm pressure, then followed by acid hydrolysis. Correct? Yes, you will get phenol here. Aniline, first diazotization, then warm water. Yes, we get phenol. Benzene, oleum, NaOH plus. Yes, just we discussed. This is again dose process, but you see here dose process means chlorobenzene starting with what? Aqueous NaOH at 623 Kelvin and 300 atm. They used 100 atm, 298 Kelvin. No, it won't give you phenol. Question number 62. Orthonitrophenol. You know what is orthonitrophenol? What is orthonitrophenol here? Orthonitrophenol. This is orthonitrophenol. We studied that there is a intramolecular hydrogen bond, which is a weak hydrogen bond. What about paranitrophenol? That's having intermolecular hydrogen bond, which is strong hydrogen bond. Question: why orthonitrophenol is less soluble in water than meta and para? Orthonitrophenol having intramolecular hydrogen bond, which is a weak bond. Weaker the hydrogen bond, lesser the boiling point. So orthonitrophenol shows intramolecular hydrogen bonding. Yes. Next, for the reaction, this is what ethanol with the hydrogen halide, you will get alcohol when react with the hydrogen halide, you will get haloalkane. What is the order of reactivity? Many times we are discussing that. If you consider HF, HCl, HBr, HI, which one is more reactive here? HI, because down the group size of the halogen increases. When size of the halogen increases, the bond become weak, easy to break, easy to undergo reaction. So HI, HBr, HCl, right? Option B. Which of the following is the proper method to prepare N-hexane from N-propyl alcohol? No, N-propyl alcohol, that's propene, okay? Not N-propyl alcohol, propene, right? Propene. So what is propene here? Propene is which one? This one. So propene, how you can convert it into hexane? So 3 carbon is there, product contain hexane, double mean Woods reaction. Okay, so let me bring one bromine on the second position. So what we can add here, HBr in presence of what? Peroxide. Let me first convert into a haloalkane. According to Andy Marconikov's rule, negative part goes here, positive part goes here. You will get CH3, CH2, CH2Br. Right? Next we have treated with what? Sodium and dry ether. The alkyl group double. This is propyl. Yes, it converted to what? Hexane. So which is the best reagent to convert propene to hexane? That is HBr peroxide and sodium and dry ether. If you want to double the number of carbon, what is the reaction? Woods reaction in this chapter. Now arrange the following alcohol in the order of increasing reactivity toward sodium metal. So I told you, sodium metal, sodium hydroxide, these all indicating what? Which is more acidic. The one which is reacting sodium faster, sodium hydroxide faster, all indicating what? Which is more acidic. Dear, this is a tertiary alcohol, right? Just expanding. Is it? Tell me fast. Is it a tertiary alcohol? Yes, it is tertiary. This is secondary. This is primary. What is it asking? Arrange the follow. Which is more acidic? Which is the acidity order of alcohol? Primary greater than, secondary greater than, tertiary. So third one is having the highest, then second one, then first one. Third, second, first, option C. Dear, the one which is reacting with the sodium faster, sodium hydroxide faster, indicating what? Which is more acidic. Don't forget, okay? So which is more acidic here? Primary. Next one. Out of 2-chloroethanol, let me draw the structure of 2-chloroethanol, right? 2-chloroethanol, all right? 2-chloroethanol and ethanol, all right? Which is more acidic and why? I will go with this one. Because chlorine is an EWG. EWG make the compound what? More acidic. What is that EWG effect is called? Minus I effect. So 2-chloroethanol is more acidic due to plus I effect. No. 2-chloroethanol is more acidic due to minus I effect of chlorine. Yes. 67. What is the correct order of the strength of the acidity? Come on dear. All are alcohol. So check. Alkyl groups are EDG. Nitro group is EWG. There are 2 nitro group EWG. EWG make more acidic. Here more EWG, more acidic. So fourth one is the highest, then third one, then first one, then last with the EDG. So fourth greatest, then third one, then first one, right? Option D, right? Fourth is the highest because it contains more withdrawing group. Then third one, only one withdrawing. Then first one, and why the second one is very least? Because it having EDG. EDG bring the acidity down. Next one, paranitrophenol is stronger acid than phenol. Paranitrophenol. Dear, this is phenol, para position nitro. They are saying this is more acidic than which one? Phenol, alright. And while paracresol is weaker acidic than which one? what do you mean by paracresol? Paracresol means phenol with the CH3. Okay, OH and CH3 together is called cresol. So why this is the nitro group one which contain is more acidic than phenol. Nitro is an electron withdrawing group or minus I effect group. How they make more acidic? Now electron withdrawing group means they will withdraw the electron from the chain and they will reduce the electron density on the OH bond. They will reduce the electron density on OH bond, so you can lose the hydrogen faster. Ready all? So nitro group is an electron withdrawing. When electron withdrawing group withdraw the electron from the OH bond, the OH bond get weaker, so you can easily give H plus, it become more acidic. What about if there is an EDG present? EDG when present, they will give electrons to OH, make the electron density on OH bond greater and the bond becomes stronger. If it is stronger, can you remove H plus? No. So what is the answer here? CH3 group decreases the electron. No. Electron donating group increase. Okay. Nitro group decrease the electron density on oxygen hydrogen bond, making para-nitrophenol stronger acid. Ready. Question 69. An unknown alcohol is treated with a Lucas reagent to determine whether alcohol is primary, secondary, tertiary, alright. Which alcohol react fastest and by what mechanism? Which alcohol give immediate turbidity? Tertiary alcohol, right? Tertiary alcohol will give immediate turbidity by through SN1 mechanism. Tertiary alcohol by SN1 mechanism. Now consider the following reaction sequence. Okay, let me just take the compound one by one. CH3, CHOH and CH3. They are reacting with a concentrated acid and heat. What happened? Alcohol heated with an acid? Dehydration. What is dehydration? OH and H. Water take it, a double bond, you will get it. You will get an alkene, propene. Ready. So this is the compound X. This propene to which they are adding dilute acid dilute acid and water, right? Water. What is this process called? Acid hydrolysis. You know, H2O contain H plus and OH minus. It follow Marconi-Kos rule. Negative part goes here, positive part goes here. You will get propan to all the compound back. So this is Y. So question, what is the X? What is this two product? So one is propene. I think so option A, right? One is propene. Then what is that last one? Propan to all. Ready? Next one. The most suitable reagent for the conversion. Already we discussed that. It's a primary alcohol to aldehyde. Come on dear, which is the best? The best reagent to convert a primary alcohol to aldehyde is which one? PCC. Next, the vapors of an alcohol X when passed over hot reduced copper produce an alkene. The alcohol is, you know, copper at 573. You may study that it is an oxidizing agent, right? Mild oxidizing agent. That they said here. I told you primary alcohol on oxidation we get aldehyde. Secondary alcohol on oxidation we get ketone. Tertiary alcohol do not undergo oxidation. Instead it undergo dehydration. For example, let me take a tertiary alcohol, okay? It is our tert-butyl alcohol. The tert-butyl alcohol when treated with the copper at 573 Kelvin here. It's an oxidizing agent, but tertiary alcohol do not undergo oxidation. Instead it undergo dehydration. So OH, H, water cut, you will get the alkene. So which alcohol give you a alkene with copper at 573? That is tertiary alcohol. One more question based on this one. What happens when tertiary butyl alcohol? This is the tertiary butyl alcohol, okay? At 300, what is 300 degrees Celsius in Kelvin? 573, okay? Or over copper. So that they are asking the same reaction. What is this product here? This is 1, 2, 3. 2-methyl propene. Same question they are asking. 2-methyl propene is the answer. 2-methyl propene is formed. So remember, tertiary alcohol do not undergo oxidation. Instead it undergo dehydration, forms alkene. 74. Which of the following compound will be most easily attacked by an electrophile? Their electrophile charge is plus. Electrophile charge is plus. So where plus charge species attack? Negative, right? You know, alcohol is EDG. Alkyl groups are EDG. Halogens on benzene ring have EDG and EWG effect. You know, EDG, whenever you studied you just check the phenol resonance structure. Phenol resonance structure, if you check the ortho and para positions get negative charge. Whenever there is an EDG group on benzene ring, if you draw the resonance structure, all the ortho para position you get negative charge. That means electron rich. So electron donating group make their ortho para electron rich. So electrophile can easily go to which place? Ortho and para. So whether option C or D. Both are EDG. EDG when present, electrophile can easily go to ortho and para. Among alcohol and methyl, which is more donating? Alcohol, because it's having lone pair. So option C. So electron donating groups make the ortho para position always electron rich. So electrophile can easily attack. Next, out of benzene, ready. Let me take the compound. Out of benzene and phenol. Out of benzene and phenol. Why phenol is more easily nitrated? What do you mean by nitration? Nitration means bringing NO to electrophile. Again, same question. What we said, why electrophile can attack to phenol faster than benzene? Because phenol contain OH group. OH is an EDG. EDG make the ortho and para position electron rich. So electrophile can easily go there. Where is answer? Presence of OH group in phenol increase the electron density at ortho and para. Yes. Where more electron density, where nucleophile can attack. Nitration, chlorination, Friedel-Crafts, these all are what? Electrophilic substitution. Question number 76. Picric acid. We know what is picric acid here? When phenol react with the concentrated HNO3, we get 2,4,6-trinitrophenol is called what? Picric acid, yellow precipitate. What is picric acid? 2,4,6-trinitrophenol is called picric acid. So 2,4,6-trinitrophenol is picric acid. Remember its color also, yellow precipitate. Ready? Next one, the major product obtained on interaction of phenol with the sodium hydroxide and carbon dioxide. Do you remember this reaction? Phenol when react with the aqueous NaOH. First what we get? Sodium phenoxide, that's ONA. Sodium phenoxide when treated with carbon dioxide and followed by hydrolysis. What you get here? Salicylic acid. Salicylic acid, this is our Kolb's reaction. So what is the product here? Salicylic acid. 78. In the following reaction, what is this X and Y? Come on dear. What is this X reaction? Phenol react with the bromine in CS2. Bromine and CS2 mean mild bromination. What you get dear? You get orthobromophenol and parabromophenol. Ready? But bromine water if you are using, you will get 2,4,6-tribromophenol also. Okay, what is the other reaction? What is the other side? Phenol reacting with the chloroform, NaOH and HCl. What is that? Salicyl aldehyde. That is our Reamer-Tiemann reaction. So X is ortho and para bromophenol. Y is salicyl aldehyde. Option B. Next one. Identify the final product. Ready? We are ready to answer anything. Phenol when treated with the zinc. What you get dear? Benzene. Right? Benzene, what is this? Friedel-Crafts acylation. Which group come to benzene? Benzene with the COCH3. What do you call benzene with the COCH3 dear? Acetophenone. Phenol when react with the zinc, we get benzene. Benzene on Friedel-Crafts acylation, we get acetophenone. Question number 80. Benzoquinone. How many of you remember the product benzoquinone? Benzoquinone is this one. It's a diketone. Benzoquinone, how we prepared from phenol? How many of you remember what is the oxidizing agent? We are using Na2Cr2O7 with H2SO4, chromic acid or sodium dichromate. So dear, phenol when treated with Na2Cr2O7, it's an oxidizing agent converted to benzoquinone. So reagent is what? Option A. Phenol, consider the following reaction. What is the product final? Phenol when treated with zinc, already we discussed, we get benzene. Benzene on, what is this? Friedel-Crafts alkylation, you will get toluene, right? What happened? Toluene when treated with the alkaline. Dear, alkaline KMNO4, acidified KMNO4 are strong oxidizing agent. The alkyl completely converted to what? Acid. So what is a benzene with acid? We call benzoic acid. Question 82. Methyl alcohol. What is methyl alcohol? Methanol, right? CH3OH. is industrially, we study wood spirit and all. How methanol is preparing industrially, carbon monoxide react with 2H2, we get methanol. It is very important to know the catalyst and all. Zinc oxide and Cr2O3 is the catalyst. Around 200 to 300 atm pressure and 573 to 673 Kelvin temperature all are there. 2000 to 3000 Kelvin, 573 Kelvin to 673 Kelvin. High temperature, high pressure. Carbon monoxide react with 2H2, you get methanol. So answer is which one? CO and H2. The enzyme which can catalyze the conversion of glucose to ethanol. So methanol preparation we study now. What about ethanol? Let me just tell you the theory. What do you know what is C12H22O11? Sucrose. We know sucrose on hydrolysis we will get one glucose and one fructose with the help of an enzyme called invertase. Invertase converts sucrose into glucose and fructose. I am taking this glucose, what is glucose? C6H12O6. So the glucose will convert it into ethanol and the carbon dioxide by the help of an enzyme called zymase. That they are asking here. The enzyme which can catalyze to convert glucose to ethanol, that is what? Zymase. Now, ether is obtained from ethyl alcohol in presence of H2SO4 at 413 Kelvin. Ethers. When alcohol heated with acid at 443 Kelvin, it is dehydration. At 413 Kelvin forms ether. Next, ether are prepared by the reaction of sodium alkoxide and alkyl halide. That is our Williamson ether synthesis. Which of the following reagents should be taken prepare to this one? So, what do you want? Methyl and tert-butyl. Methyl tert-butyl ether if you want to prepare. If you want to prepare this ether, which is the best suitable reagent? Dear, it's very simple. The bigger alkyl part should be sodium alkoxide and the small part should be the haloalkane part. That means I am taking that methyl chloride with sodium tert-butoxide. Sodium tert-butoxide. This is the best reagent to convert. What is Williamson? When a haloalkane react with the sodium alkoxide, we get ether, right? So this haloalkane should be smaller group. Sodium alkoxide should be bigger one. Then easily the NaCl you can cut and you can get the ether. What happen if it is opposite? What happened that bigger in haloalkane, smaller in sodium alkoxide? Dear, if sodium alkoxide part is small, it acts as a base, strong base. Then beta elimination happen instead of Williamson. So if you want to get Williamson ether process, haloalkane keep it small, sodium alkoxide is big. So where is the answer here? Br, here chlorine I used, Br can be used. Okay, Br is the question. So Br use it. So CH3Br and NaOCS, right? Option B. Next one. Which of the following are the product shown by the reaction of methoxyethane with HI? What is methoxyethane? CH3OCH2CH3. With what? HI. Again, ether bond breaking. Which bond you break, whether left or right of ether? Dear, if on ether primary group, small group when comes, follow the order SN2. What is SN2 mechanism? Break the less crowded CO bond. Where is the less crowded part? That you break it. Which is the less crowded part? Here you break. So oxygen minus CH3 plus. So you get to the CH3 iodine attack plus to the O minus who will attack? O minus H will attack. So you will get methyl iodide and ethanol. Where is methyl iodide and ethanol? Option D. So left and right if you have. So this is the theory. I will give a short method all of you immediately. On how to break ether. There are three cases, okay? Case number one. If you have left and right, primary, or primary, secondary, or secondary. If this kind of group when comes, follow SN2 mechanism, break the less crowded CO bond. Where is less crowded part? That you break. Second condition, where you have a tertiary with the primary, tertiary with the secondary and all, it follow SN1 mechanism, break the tertiary part always. And one more case is there in aromatic ether. In aromatic ether, for example, anisole and all, this is the condition. After the breaking, you should get phenoxide ion. After the breaking, we should get phenoxide ion. Just by applying this one, check it other question. See, this is the question. In the reaction, what is this anisole? Anisole when react with HI. HI mean HBr, H plus and Br. Where you break. This is an aromatic ether. So the condition after the breaking, you should get phenoxide. So I will break here. Then only I will get phenoxide and this. Always oxygen negative, carbon positive. To the negative, who will attack? H plus will attack. So what is the product here? You get phenol and CH3Br. Right? Where is the answer? Phenol and CH3Br, option D. Next one, the ether that undergo electrophilic substitution reaction is, their electrophilic substitution is happening aromatic compound, benzene compound. So is it contain benzene? No. Option B, what is this? Anisole. Right? Electrophilic substitution happen on aromatic compound. These all are aliphatic, right? That's simple. 89, anisole. What is anisole? Benzene with the OCH3. Alright, anisole is what? Benzene with the OCH3. Anisole on reaction with the chloromethane. What is chloromethane? CH3Cl in presence of anhydrous. What is this reaction? Friedel-Crafts alkylation. So Friedel-Crafts alkylation means which group comes? CH3 will come. Where we can place it all? Where we can place it here? Anisole is a ortho-para directing group. So you will get ortho-methyl anisole and para-methyl anisole. Ready? So question, or anisole on treated with this compound, ortho-methyl anisole and para-methyl anisole are formed. Para-methyl anisole and para no, ortho-methyl anisole para no, ortho-methyl anisole and para-methyl anisole. That first answer is wrong, right? Because this is given ortho-methyl anisole and para-methoxy. Carefully read the question, okay? So answer is what? Option C, ortho-methyl anisole and para-methyl anisole. Here they mention para-methoxy. Careful. Anisole is an ortho-para directing group. On the Friedel-Crafts reaction, you get ortho-methyl and para-methyl anisole. Question number 90, dehydration of alcohol. Already discussed that. Dehydration, eliminations basically follow SN1 reaction because carbocation stability is the factor. So dehydration of alcohol is an example of, here they are asking dehydration is an example of which one, dear? Elimination reaction, right? Elimination, dehydration, removal of water. Next one, the alcohol which does not react with the Lucas reagent. Tertiary alcohol immediately react. Secondary alcohol, after 5 minutes they give turbidity. Primary alcohol is the one not reacting at a normal temperature. So which is a primary alcohol? N-butanol. What is isobutyl, dear? This is what isobutyl, okay? This is isobutyl alcohol. And N-butyl alcohol mean normal butyl alcohol. Tert-butyl alcohol you already know, right? Tert-butyl alcohol, tertiary. And what is sec-butyl? Sec-butyl means this one. This is what? Sec-butyl alcohol. Alright. Generally, primary alcohol do not, normal alcohols do not undergo Lucas reaction faster. Phenol react with a bromine in CS2. We discussed the phenol when react with the bromine water, it give you 2,4,6-tribromophenol. But bromine in CS2 is a mild bromination. You will get ortho-bromophenol and para-bromophenol. You will get ortho and para-bromophenol. 93. What is aspirin? The medicine which is using, right? What is aspirin, dear? We studied when phenol, what is phenol and what is COH here? Salicylic acid. When salicylic acid react with acetic anhydride, what is this compound called? Acetic anhydride. What do you get? What do you get? You get OH and OCOCH3. This is called acetyl salicylic acid called aspirin. Salicylic acid when react with acetic anhydride, you will get acetyl salicylic acid. This is called our aspirin. So what is aspirin? Acetyl salicylic acid. 94. Identify the catalyst in the hydration of alkene to produce alcohol. You know, alkene when react with the water, in presence of an acid, you will get alcohol. This is called acid catalyzed hydration. What is the catalyst we are using? An acid. What is an acid? HCl. The first step of the mechanism, you may study the three mechanism in this chapter: alkene to alcohol, alcohol to alkene, alcohol to ether. The first step of the mechanism of conversion of ethanol to ethoxyethane. There are three steps actually. Ethanol. What is the first step? You remember? How many of you remember the first step, dear? You will take the alcohol. You know, we will treat acid with what temperature? 413, right? What is the first step in this one? The alcohol that get protonated. They will take the proton to ethanol. So what do you get? CH3, CH2, OH, lone pair hydrogen plus. So H plus addition, what we call protonation. So protonation is happening on ethanol. So protonation of ethanol. First step. Please study all of you. First step in this mechanism, protonation. And from the textbook you can able to understand. Second step is what? The removal of water. Third step is what? Deprotonation. The question number 96. What happens when an aldehyde is treated with a lithium aluminium hydride? Lithium aluminium hydride is a reducing agent. So aldehyde on reduction, what you get? Primary alcohol. Primary alcohol is formed. Now, primary alcohol is formed. Next one, which of the following aldehyde can produce primary alcohol when treated with a Grignard reagent? We discussed that. Methanol. Methanol or formaldehyde, when react with the Grignard, we will get a primary alcohol. That's what? Methanol. What about other aldehyde? Secondary alcohol. What about ketone? Tertiary alcohol. Next, what is the final major product in Reimer-Tiemann? Reimer-Tiemann give you salicyl aldehyde. Salicyl aldehyde. Which salicyl aldehyde? What is salicyl aldehyde? Actually, we are writing OH and CHO. So CHO is the main group. So this is ortho, right? This is the ortho position. So ortho salicyl aldehyde. Next one. Aspirin is already we discussed. Aspirin is produced from the reaction between salicylic acid with what? Acetic anhydride, right? Acetic anhydride. Last question dear, to get carboxylic acid directly from alcohol. We studied primary alcohol. If you want to directly convert into carboxylic acid, we need a strongest oxidizing agent. That is what? Acidified KMNO4. Alkaline acidified, where acidified KMNO4 is the strongest one. So these are the 100 MCQ from the chapter Alcohols, Phenols and Ethers. Hello guys, we can discuss the amine chapter, the most important 100 MCQs. So I think when we discussing the 100 MCQs, I think after completing the 100 MCQ, we may cover the complete chapter concepts with the detailed solution. Okay, let us go for the first question. Okay, ready? Which of the following is the most preferred reagent for reducing nitroethane to ethylamine? Basically, nitro to amine. Which all are the best reagent to convert nitro to which one? NH2 amines. We studied it as per basic theory of the chapter. We use the reducing agents like hydrogen with the palladium in ethanol medium, or we can use iron and HCl, or we can use tin and HCl. These are the reagent we studied. Where we may study that this is the best reagent. Iron and HCl is the best. Which of the following is the most preferred reagent? That is Fe and HCl. There is a reason. You may study that. So normally when we react with the iron and HCl, the iron and HCl first react, it will give you FeCl2. This FeCl2 again react with the water in the medium, give HCl back. So it's giving HCl back. So in the beginning we have to use less amount of HCl. So therefore the best reagent to convert nitro group into NH2 if they ask, we can go with which one? Iron and HCl. Okay. Next question. Which compound is formed when hydrogen gas is passed through nitrobenzene? Okay, nitrobenzene is here. Okay, nitrobenzene. They are passing hydrogen gas in the presence of finely divided nickel. Okay, hydrogen with a nickel or palladium catalyst. What happened? Nitro group converted to what? NH2, NH2, same reaction. Here we said the hydrogen with the palladium, or that what hydrogen with the nickel, same purpose, NO2 converted to NH2. What is that compound called? Aniline, right? So nitrobenzene on reduction with the hydrogen, we get which one? Aniline. Next one. Nitrogen atom of amino group is dash hybridized. You know, amines are the derivatives of ammonia. Amines are derived from ammonia. What is ammonia structure? You know, NH3 we can write like this one. We know hybridization is given by, we may study it in 11th grade chapter chemical bonding. Hybridization is given by the sum of sigma bond and lone pair. How many sigma bond? 1, 2, 3. 3 sigma bond and 1 lone pair. So what is the total sum? 4. 4 mean 4 orbital we have to mix. So sp3, 1 s orbital and 3 p orbital. So remember all, ammonia is sp3 hybridized. Amines are derived from ammonia. So amines, primary, secondary, tertiary, these amines are what? sp3 hybridized in nature. Okay, pyramidal shape, trigonal pyramidal shape. So what is the hybridization of nitrogen in amino group? Mean we can say sp3 is the hybridization. Question number next, fourth one. C3H8N cannot represent. That's actually, let me write the formula: CH3, CH2, CH2, NH2. Just to check the formula, all of you, 3 carbon, okay. 3 plus 2, 5, 5 plus, this is not a small thing here. C3H9N, okay, C3H9N. So this is the compound 1 possible. So C3H9N cannot represent, okay. So this is 3 carbon contain 1 amine. What is this amine? It's a primary amine because it contains NH2. I can write a secondary amine also, NHN, CH2, CH3. N-methyl ethanamine. This is secondary, right? It's possible. Even tertiary also possible. Even tertiary also possible, right? You all hope you know how to understand its primary and all. If it contain NH2 group, primary. If it contain NH group, secondary. If it contain LL tertiary, right? So C3H9N, the formula can represent both primary, secondary, tertiary amine. Quaternary ammonium salt is not possible with the formula, okay? So that is C3H9N, these are the structures possible. One more is there, actually the NH2 can be placed it here. Anyway, quaternary is not possible with 3 carbon. Next one. The most convenient method to prepare primary amine containing 1 carbon atom less. This is the only one chapter, main chapter we are studying how to get a amine with a 1 carbon less. That is Hofmann-bromamide degradation reaction. Hofmann-bromamide reaction. Through Hofmann reaction, you may study the amide from which 1 carbon less amine we will get it. So if you want to reduce 1 carbon in product, the amine, then the reaction will be what? Hofmann-bromamide degradation. Next, when excess of ethyl iodide, what is ethyl iodide? C2H5I. When excess of ethyl iodide is treated with ammonia, what is this reaction, my dear? Remember all, this is our ammonolysis. Ammonia, when treated with a haloalkane, we get primary amine. But you know, ammonolysis, what is the main demerit? It won't stop with the primary, it gives you secondary, tertiary, up to quaternary, the reaction continue. But there is some exception cases, you remember all. If you use ammonia in excess, and carry out with the haloalkane, primary amine will be the major product. Primary amine will be the major product. But if it is opposite, that means if you use the alkyl halide in excess, then the quaternary, the reaction will continue primary, secondary, tertiary up to the quaternary salt. Up to the quaternary salt, the reaction will continue. What is ammonolysis? Ammonia, when react with the haloalkane, we get amine. But it won't stop, that's a problem. It will continue up to the quaternary. But there is some points, experimental evidence is given that if you are using excess ammonia in the beginning, primary amine will be the major product. If you are using excess haloalkane in the beginning, it is always end up to quaternary. So here the question, if they are using excess ethyl iodide, if the reaction continue up to quaternary. So that means you will get tetraethyl ammonium iodide. Tetra. What is a tetra means? Quaternary ethyl ammonium iodide. Up to the quaternary reaction get continue. You know, ethylamine is primary, diethylamine is secondary, triethylamine is tertiary, but quaternary up to that reaction continue. Next question. Benzoic acid. What is benzoic acid? Benzene with COOH. Benzoic acid when treated with SOCl2, thionyl chloride. What is the function of thionyl chloride? To remove OH and place chlorine, right? So what we get? Benzene with a COCl, benzoyl chloride. What is it called? What is this called? Benzoyl chloride. Benzoyl chloride. Okay, fine. Next. A product SOCl2 and the product X formed is. So this is the product X formed is. React with ammonia. React with ammonia to give Y. What happen if you treated with acid chloride with ammonia? Cl and one H cut. HCl out, you get an amide. What is amide? Benzene with CONH2. What we call this amide? Benzamide. What is this amide? Benzamide. This is the compound Y. Okay, next. Y on reaction with the bromine and KOH. What is bromine and a base means? You know, NaOH or KOH, whatever. So, you know, this is an amide. Amide on reaction with the bromine and NaOH. This is our Hofmann bromamide reaction. The CO group replace and or remove. You will get the product finally what? This is the compound Z. What is this? Aniline is the main product. So remember, benzoic acid when treated with the thionyl chloride, we get benzoyl chloride. Benzoyl chloride on reaction with ammonia, we get benzamide. Benzamide on Hofmann reaction, you get aniline. So Z, the reaction is what? Aniline. Question number 8. Amines that cannot be prepared by Gabriel-Thalamide synthesis. You may study the theory that through Gabriel-Thalamide synthesis, we can prepare which one? Primary aliphatic amine. Through Gabriel, we can prepare primary aliphatic amine. Aromatic amine is not possible. So, amine that cannot be prepared by Gabriel. Aniline. Aniline is which amine, my dear? Aniline is a primary aromatic amine. What is benzyl amine? Benzyl amine means benzene with the CH2NH2. It's an aliphatic, right? NH2 connected to alkane chain. What is methyl amine? CH3NH2, aliphatic, primary. What is isobutyl? Isobutyl means CH3CH, CH3CH2. This is called isobutyl amine. It's also primary. Aliphatic amine we can prepare through Gabriel. Aromatic amine cannot. So aniline cannot prepare through Gabriel. 9. Tertiary amine have lowest boiling point among the isomeric amine. We studied what is the order of boiling point of amine. Primary greater than, secondary greater than tertiary. Because primary amine contain NH2 group, more hydrogen. So more hydrogen bond can create. And then only secondary and least one is which one? Tertiary. So primary amines are more basic, then secondary, then tertiary, because primary amine contain more hydrogen bond, can form more stronger intermolecular hydrogen bond. So why tertiary amine very least boiling point? Because they cannot form hydrogen bond. What is their answer? They do not form hydrogen bond because they not contain any hydrogen. Okay, or have higher molecular mass. Okay, that's it. Next one. Which of the following is used as Hinsberg reagent? What is Hinsberg reagent? Hinsberg reagent is benzene sulfonyl chloride. Benzene sulfonyl chloride. What is the structure? Benzene sulfonyl chloride. Short form we can write. What is this? C6H5SO2Cl. Where is that? C6H5SO2Cl. Option A. What is the purpose of Hinsberg reagent? It is used to distinguish between primary, secondary and tertiary amines, right? Question number 11. Anilinium hydrogen sulfate. What is this? You studied like this one. When aniline react with a fuming H2SO4 or sulfonation, H2SO4 contain H plus and HSO4 minus. So the aniline take the, by using the lone pair, take this H plus, you get anilinium. What is anilinium? NH3 plus and HSO4 minus. Anilinium hydrogen sulfate. This on heating, you know, it converted to what? Sulfanilic acid, NH2 and SO3H. That is called a sulfanilic acid. Sulfanilic acid. So read the question all of you. Anilinium hydrogen sulfate when heated with the sulfate on heated with H2SO4 at 543 to the 453 to 473 Kelvin produces what? We get sulfanilic acid. So aniline on treated with H2SO4, first we get anilinium hydrogen sulfate. You studied this reaction under sulfonation, right? And this on heated you get sulfanilic acid. Question number 12. When aniline is heated with concentrated H2SO4, it form. Aniline is heated with the concentrated H2SO4. What is H2SO4 contain? Just to be discussed, H plus and HSO4 minus. What we get initially? Initially we get NH3 plus and HSO4 minus. Later on heating becomes sulfanilic acid. But sulfanilic acid is not given here. So we can go with which one? Anilinium hydrogen sulfate can form. Same question. Now amines have. They're all amines, the basic property while you're reading from NCERT, you may see that amines having a fishy odor, fishy smell. So that's a general property of amine. Amines having fishy odor. Just remember. What is the best reagent for converting 2-phenyl propanamide? What is prop? 3 carbon. Amide means CONH2. So 1, 2, 3. 1, 2. So 2 second position phenyl ring. So this compound 2-phenyl propanamide into 2-phenyl propanamine. Okay. 2-phenyl propanamine. What is the best reagent to convert 2-phenyl propanamide to 2-phenyl propanamine? Is there any change in number of carbon? I think no. This is an amide, and this is a amine. If you want to reduce one carbon, then we can use Hofmann bromamide. But here there is no reduction in carbon number. So if you want to convert a amide into amine, we have the reducing agent. What are the reducing agents to convert amide into amine? Basically, we are using LiAlH4, lithium aluminum hydride, followed by hydrolysis. So where is this LiAlH4 is mentioned? Yes, LiAlH4 is there. The best reagent to convert amide into amine without change in carbon is LiAlH4. Okay. Now, aniline is used. What is the application of aniline? They're all aniline. I think that's the chapter, the final part you may studied. Aniline is used. Aniline when undergo coupling reaction with the phenol and the benzene diazonium chloride when react with aniline and the phenol, we get dyes, orange dye and yellow dye, right? So aniline basically used in dyeing industry for coloring agents. Next one, an organic compound A on reduction. What do you mean by reduction? Addition of hydrogen gives a compound B, which on reaction with the chloroform, CHCl3 chloroform and potassium hydroxide. What is this reaction? That is our carbylamine reaction, giving a compound C. The compound C on catalytic reduction means hydrogen with a palladium or nickel, gives N-methyl aniline. What is N-methyl aniline? Benzene with a NHCH3. N-methyl aniline. The compound A is. Okay, let's make a back calculation. Is it a secondary amine or not? Yes. If you want to get a secondary amine by reduction, it should be an isocyanide, NC. You know, cyanide on reduction, you get primary amine. Isocyanide on reduction, we get secondary amine. So it's an isocyanide. Yes, we know carbylamine reaction mean isocyanide is the product. So what should be B? It should be aniline. You know, aniline on carbylamine reaction become isocyanide. If you want to get aniline by reduction, what should be this? It should be nitrobenzene, because nitro group on reduction we get aniline. So what is the overall answer? What compound A is which one? Nitrobenzene is the compound A. Clear, my dear students? Okay, next one. The compound obtained by heating a mixture of primary amine, okay, a primary amine reacting with the chloroform and alcoholic KOH. Yes, what is this reaction? Chloroform and KOH is there, mean carbylamine reaction. Foul smell. What is the foul smell? Isocyanate. We get isocyanate, right? Isocyanate. So they started from primary amine. So what we get? A alkyl isocyanate, right? Alkyl isocyanate. Not halide, not amide, right? So when amines react with the chloroform and KOH, we get always the isocyanide is a product. Alkyl halide, what is alkyl halide? RX. On treated with the KCN, followed by reduction, reduction means hydrogen with any catalyst, leads to the formation of which one? Tell me all. Primary haloalkane when react with the KCN, we get cyanide, right? KX cut, you get RCN. Cyanide on reduction, we get what? Primary amine, RCH2NH2. CN become CH2NH2. So what is the answer? RCH2NH2, that is option B, RCH2NH2. Right? Simple reaction. Which of the following does not react with the Hinsberg reagent? You know the observation. Primary amines react with Hinsberg reagent, you will get a precipitate which is soluble in alkali. Because it is contain acidic hydrogen. Secondary amine also react with the Hinsberg reagent, you will get a product which is insoluble in alkali, is the observation. Next, whereas tertiary amine do not react with the Hinsberg reagent because no hydrogen present in tertiary. So question, which of the following does not react with the Hinsberg mean? They are asking you which is a tertiary amine. Which is a tertiary amine? C, because it contains N alone, right? Because or N connected to 3-methyl group, it's a tertiary. That's it. 20 question above, what is Z? This is ethyl amine. Ethyl amine on diazotization, what we get? C2H5 N2Cl, diazonium salt. Diazonium salt when treated with bromine. Diazonium salt treated with which one? Bromine. So what is that? Bromine with red phosphorus is given. So basically the reaction you can understand from the ammonia. So ammonia means what? Ammonia means what? Excess they are using. So what is that? Ammonolysis is there. So C2H5 N2Cl with the bromine, if you are excess you are using, you will get C2H5Br. Where excess ammonia if you treated, what happened? H and Br will cut, you will get C2H5NH2. We studied if you use excess ammonia in ammonolysis, the primary amine will be the major product. So C2H5NH2 is what? Ethanamine, right? Ethanamine. So ethanamine, that's actually ethanamine started, we got ethanamine back, right? So ethanamine on diazotization, what we get? Actually diazonium salt. You know this diazonium salt is highly unstable. Since studied aliphatic diazonium salts are highly unstable, so immediately it react with which one? Water form what? Alcohol. Actually this alcohol is reacting with the bromine and phosphorus, we get bromoethane, then ammonolysis we get primary amine. This this reaction is from the, this step is from the haloalkane chapter. Alcohol when react with the bromine and red phosphorus, we get haloalkane. Now, which of the following when heated with a mixture of ethanamine and alcohol? What is ethanamine? Ethanamine is C2H5NH2. Ethanamine, what is alcoholic potash? Potash means potassium hydroxide, okay? So alcoholic potassium hydroxide gives ethyl isocyanate, gives ethyl isocyanate. So what is this reagent? If you want to get isocyanate, what is the product? What is the reaction? Carbylamine reaction. In carbylamine reaction, the amine react with alcoholic KOH and what? Chloroform. What is chloroform? CHCl3. What is chloroform? IUPAC name, trichloromethane. What is that? Trichloromethane, option C. Trichloromethane. See, it's the same reaction they are asking in different mode, right? So whenever a amine react with alcoholic KOH and chloroform, then only we get what? Isocyanate. So they're asking which is the missing one? Chloroform. Chloroform is trichloromethane. 22. Which of the following pair species will yield carbylamine? Remember, carbylamine test is given by primary aliphatic or primary aromatic amine. Remember, that means basically they should contain NH2 group. Check it all. See this CH3, CH2, Br and KCN, you get cyanide, right? You will get, what is the product? You will get CH3, CH2, CN. No, cyanide is not the one giving carbylamine. Amine should form. What happened when bromoethane react with the excess ammonia? Excess ammonia if you are using, primary amine will be the major product. So you will get CH3, CH2, NH2. Yes, this is a primary amine. It can give carbylamine test. We know AgCN, if you are using it isocyanate, you studied in which one? Which reaction? Our haloalkane reaction, right? Which of the following pair of species will yield carbylamine? So carbylamine test. Which of the following pair of species will yield carbylamine test? So here actually the product is what? CH3, CH2, NC. CH3, CH2, NC. So carbylamine, if they ask the questions like which will give, which is very close to the reaction of carbylamine test mean, we can go with which one? C. Right, because in carbylamine reaction, what is the product? Isocyanate. Even if you treat it with AgCN, you will get the product what? Isocyanate. But here the question, which of the following pair of species will yield carbylamine? So carbylamine what, my dear? Carbylamine means isocyanate, okay? Yes, carbylamine means isocyanate. So who give isocyanate is the question. So let's go with option C is the correct answer. Clear? Who will give carbylamine reaction means we can say primary amines are giving carbylamine reaction. So you can go with which one? Option B. But here, which of the following pair of species will give you carbylamine? Carbylamine means isocyanate. So isocyanate is getting from third reaction. Okay? Careful. 23. The compound is given as C6H5. This is C6H5, CONHCH3. This can be converted into C6H5, CH2, NHCH3 by which reagent? What is this reaction? This is a amide to amine. See, amide to amine without change in carbon. So amide to amine without change in carbon, already we discussed LiAlH4 is the best, right? LiAlH4 is the best to convert a amide into which one? Amine without any change in carbon. Next question, benzene diazonium chloride when treated with the CuCN, we get cyanobenzene with the nitrogen and CuCl. The above chemical reaction is associated with which of the following name? CuCN basically we are getting from the Sandmeyer reaction, right? Basically we are getting through Sandmeyer reaction. But here they said nitrogen and CuCl is the byproduct. Basically Sandmeyer mean nitrogen is the byproducts we are getting. So anyway, Getterman, sometimes they will give you some Balsheman, you studied already to bring which one? Fluorine. Getterman reaction is what? That's also we can use it, but that's copper powder we are basically using. Then Fittig reaction is to prepare biphenyls, and Sandmeyer is the one. What is the basic reagents we are using for Sandmeyer? We are using Cu2Cl2 along with which one? HCl, Cu2 Br2 along with which one? HBr, and CuCN along with which one? KCN. These all are belongs to which one? Sandmeyer reaction. Now the reaction of aniline with benzoyl chloride. What is benzoyl chloride? Benzene with COCl. Benzoyl chloride gives what? We can directly write the product here since it is MCQ. Very simple. Take this H and Cl, cut. So we will get the compound benzene with NH connected to CO, one more benzene ring. What is this product is called? N-phenyl. N-phenyl, benzene with an amide. What we call? Benzamide. N-phenyl benzamide. Is it there? N-phenyl benzamide is not mentioned. That is also called benzanilide. Benzanilide. N-phenyl benzamide is completely called what? Benzanilide. Question. The same one question already we discussed in part 1. The hybrid state of nitrogen is in. Okay. The hybrid state of nitrogen in R2NH. What is R2NH means? Secondary amine. We discussed this question before, that is sp3. If they ask questions based on the hybridization of amines, basically it will be sp3 because amines are derived from ammonia. Ammonia is sp3 hybridized. Therefore, already we discussed in part 1. So this is the hybridization of amine, sp3. Next one, which of the following is the strongest base? If they ask you about the strongest base, we know that aromatic amines are very less basic. Because in aromatic amine like aniline, the lone pair on nitrogen is involved in resonance, so it's not available for protonation. See all, the nitrogen is on benzene, so it's aromatic. Here nitrogen on benzene, aromatic. Here nitrogen on benzene, aromatic. But here nitrogen not on benzene, it's an aliphatic, my dear. Aliphatic amines are the strongest base than aromatic amines, right? So aliphatic amine is the most. Now among the following, which is the weakest base? Weakest base means aromatic. Check which is aromatic. Here nitrogen not on benzene ring. Here nitrogen not on benzene ring. Nitrogen not on benzene ring. But what is this? What is this? What is this? These all are aliphatic amines. What is this? CH3, CO, NH2. It's an amide, my dear. This is an amide. Keep in mind, amides are weak base than amines. Amides are weak base than amine because the lone pair in amide involved in resonance. So the lone pair is not available for protonation. Remember, basicity order when asking, amides are weaker base than amines. Okay, so we can go with option D. Amides are weakest base. Next one, among the following, which is the most basic compound, most basic? They're all aniline. What is aniline? Aniline is aromatic, right? So cut it. What is acetanilide? Acetanilide means benzene with NHCO, CH3. See, the lone pair is involved in resonance. Cut it. Amides also least. Para-nitroaniline, that also contain aniline, less. What is benzyl amine? What is benzyl amine? Benzyl mean benzene with a CH2, NH2. See, the nitrogen is not on benzene ring, so the lone pair is available for donation. Therefore, aliphatic amines are more basic. Let's go with option A. Clear, my dear? Next one. Aniline in a set of reaction yielded a product D. What is the last product? D. Let's start. First structure is what? This is aniline on diazotization. What we get? The aniline on diazotization, diazonium salt. Diazonium saltron treated with the CuC undergoes Sandmeyer reaction. You get cyanobenzene. Cyanide on reduction. What we get? Aniline means amine. CH2, NH2. You know what is this? HNO2 is called nitrous acid, right? This is an aliphatic amine on diazotization. It becomes the salt CH2, N2 plus Cl minus. We know aliphatic diazonium salts are highly unstable, so immediately it react with the water. That they won't give you, okay, we should perform. Aliphatic, this is not aromatic, right? Because nitrogen is not on benzene. Aliphatic diazonium salt immediately react with the water and form what? Alcohol, CH2OH. What is this compound called? Benzyl alcohol. So we get option A, C6H5CH2OH. Remember, if it is aromatic diazonium salt, that means N2Cl, benzene diazonium chloride, it is highly stable due to resonance. But this is unstable, so immediately react with the water, form alcohols. So end with alcohol. The correct order of increasing basic nature for the bases. So one is given ammonia. Ammonia, it's a primary amine and it is a secondary amine, and methyl is the group present. We know the order is aliphatic amines are more basic than ammonia. Ammonia is more basic than which one? Aromatic amines. Basically, aromatic amines are least basic. Correct. Or increasing order, okay, increasing order. Start. So these are the aliphatic amine, right? In aliphatic amine, more the alkyl group, more basic. So which one? This is more basic one, more alkyl group. So C is the most one. Then which one? B, and least one A. So where is the option? Ammonia, methanamine. Yes, option D. Correct order of increasing basic strength. So more the alkyl group present, more the basic character, right? So therefore this one, then this, and then ammonia. Next question. Which is most basic? So basicity is a repeated question for exam ID. This is amine chapter. Amines are basic. Which is most basic? This is aromatic, leave it. This is also nitrogen connected to benzene, aromatic. Yes, C is what? Aliphatic. Oh, no. This is aliphatic, this is also aliphatic. Here more alkyl group is there. More the alkyl group, more donating group, more plus effect, more the basicity. So let's go with option D. The amine that does not react with the acetyl chloride. What is acetyl chloride? Acetyl chloride is CH3COCl. The one which we are using in Friedel-Crafts acylation, right? This is called acetyl chloride. So the amine that do not react with acetyl chloride, which is very simple. Normally amines when react, the Cl react with the hydrogen which is present in amine. So which amine do not react with the benzoyl chloride means the one which do not contain hydrogen. Which one do not contain hydrogen? Tertiary amine. See, on the nitrogen, no hydrogen. Tertiary amine cannot react with the acid chlorides. Okay, because there is no hydrogen to react with the chlorine. Next one. Aniline is less basic than. So they're asking you which is most basic among this one. Triphenylamine. What is triphenylamine? 3-benzene ring group, right? 3-triphenylamine. See, it is very less basic because more amines are there. I think option 2, my dear, this is what benzylamine. What is benzylamine? CH2NH2. It's an aliphatic amine. Already we discussed it's more basic. See, diphenyl. Benzene ring is there, no? Leave it. Nitroaniline is also aniline. So, aniline is less basic than. So, they're asking you which is more basic. There is an aliphatic amine already, that is benzylamine. Now, which one of the following is the product that is formed when a primary amine when react with the chloroform and which one? Alcoholic KOH. Yes, what is this reaction? When primary amine react with the chloroform and alcoholic potassium hydroxide, we get isocyanate. Isocyanate, the foul smell, right? So where is isocyanate? Yes, option A, isocyanate. Now the product obtained when methylamine is treated with nitrous acid. What is nitrous acid? HNO2. You know, this is our diazotization process, right? So aniline, amines on diazotization, it becomes the diazonium salt N2Cl. But we studied all of you, this is a aliphatic, right? So this is an alkyl diazonium salt. This is a alkyl diazonium salt. You know, alkyl diazonium salts are highly unstable because resonance and are not possible. So don't stop here. It immediately react with the water. You know, water contain the ion H plus and OH minus. The OH come to CH3. You get CH3OH. Byproduct H plus and Cl minus HCl and the nitrogen gas come out. So product is what? CH3OH is the product. Where is that? Option 1. So if you are getting a alkyl diazonium salt, please don't stop there. Immediately react with the water, make it alcohol. Okay, that's a stable. Now, secondary amines can be prepared by. What is secondary amine mean? For example, CH3NHCH3. Secondary amine can be prepared by which reaction? Reduction of nitro compound? No. We know nitro compound on reduction we get amine, primary. Reduction of isonitrile. What do you mean by isonitrile? Isocyanate. Yes, dear all. NC on reduction you will get NC. This is the theory I will just tell you. If you have a CH3CN and CH3NC, what is this? Cyanide and isocyanate, right? Cyanide on reduction, you will get CH3, CH2, NH2. Basically, CN become CH2, NH2. It's primary, right? Cyanide on reduction, you get primary amine. But isocyanide on reduction, you get CH3, NHCH3. The NC become NHCH3. What is this? It's a secondary amine. Not at all. Cyanide on reduction, primary amine. Isocyanide on reduction, we get secondary amine. So we can say reduction of isonitrile give you which one? Secondary amine. Now, which of the following is the IUPAC name of the compound in which one hydrogen of ammonia, what is ammonia? NH3, is replaced by an ethyl group. So, one hydrogen they are removing. So, what is one hydrogen removing? It becomes NH2 by an ethyl group. What is ethyl? C2H5. What is the name of this compound? Ethanamine, right? Ethanamine. Where is ethanamine? Option C. Did you get the question? That level of question, type of question. They are asking from ammonia, one hydrogen you are leaving. From ammonia, one hydrogen we are leaving. So what is left? NH2. and it's replaced by a ethyl group. So what is it called? Ethanamine, right? Next one. Identify the correct, question careful, identify the incorrect name of the compound. Let me check the compound. Possible structure, let me tell you, okay? This is 1, 2, 3, right? I can say it is propan to amine because second position amine. What is CH3? CH3 is called, you know, CH3, CH3 I can write like this. What is this group is called? Isopropyl. So it's called isopropyl amine. We can say like that. Or what is the another structure? Okay, then we can check it. Okay. So propan to amine, we can write it as what? 2-aminopropane. That's also correct. So question, which of the following is incorrect? Isopropyl is possible. 2-aminopropane, propan to amine. N-propyl amine is not possible. N-propyl amine, that's not connected to this compound. This is propan to amine, right? Which of the following is the correct IUPAC name of the compound? What I'm just expanding. CH3N, CH3, CH3, right? What is the correct IUPAC name of this compound? Any one carbon you take the parent chain. So these are branches. What is this branch? Methyl on nitrogen. So it's called NN-dimethyl. NN-dimethyl, one carbon amine, what we call methanamine. NN-dimethyl methanamine. NN-dimethyl methanamine, right? Option C. What is the correct IUPAC name of the amine? CH3NH, CH2, CH3. Simple question, it's a secondary amine. How to name this amine, my dear? Take the biggest chain. Left side 1 carbon, right side 2 carbon. So ethanamine is the parent chain. So this is a branch. So N-methyl ethanamine, right? N-methyl ethanamine. What is the answer? What is the answer? N-methyl ethanamine. That is option A, right? N-methyl ethanamine. What is the IUPAC name of this compound? Just to pause the video, find the answer all of you and just watch it. Here, left side ethyl, down ethyl, right side is bute. So right side is the parent chain. So this ethyl and ethyl are the branches. So here nitrogen contain 2 ethyl branches. So it's called NN-diethyl. NN-diethyl, where is that? That is option C. NN-diethyl butanamine, right? Butane 1 amine, correct? First 42, option B, C. What is this product? Reduction of aromatic nitro compound. Aromatic nitro compound, for example, nitrobenzene. Reduction means what? Addition of hydrogen with what, palladium something. Okay, they're already using the catalyst, which one? Tin and HCl. Yes, we know. Nitro group on reduction, what it become? Amine, right? Amine. So aromatic nitro compound on reduction, we get aromatic amines. Aromatic primary amine. Aromatic primary amine, option A. 44. Which of the following compound cannot be identified by carbylamine test? Please mark it, all of you. Carbylamine test is given by only primary aliphatic or primary aromatic amine. So which one do not give carbylamine is the question. This is a primary amine. This is primary amine. This is primary amine. What is NH mean? It's a secondary amine, option D. Only carbylamine test is given by primary aliphatic or primary aromatic amine. This is secondary, do not. 45. Which of the following compound react with the NaNO2 and HCl? What is this? Diazotization. 0 to 4 degrees Celsius to give alcohol or phenol. I told you that when you treated with NaNO2 or HCl, or what is this NaNO2 and HCl react together, you get HNO2, nitrous acid. If a species undergo nitrous acid and giving directly alcohol means it should be a aliphatic amine. Which is an aliphatic amine? Primary amine, B. See, what is this compound? C2H5NH2. If you treated with NaNO2 and HCl or HNO2, you get C2H5N2Cl. Do you remember? Alkyl diazonium salt is highly unstable. So immediately it reacts with the water and it becomes what? Alcohol. So that is possible by primary aliphatic amine. Even this primary aromatic amine also, aniline also can undergo diazotization, but it form a stable compound. It won't give alcohol immediately, right? So therefore option B. Acetylation of a secondary amine in alkaline medium yield. Let me give you an example. Secondary amine, right? Okay, let me take a secondary amine, RNHR. Is it a secondary amine? Yes, NH group is there. Secondary amine react acetylation. What is acetylation? Treating with a CH3CO, OCO, CH3, acetic anhydride. How can we write the product directly during acetylation? Simple. From the amine, take H. From the anhydride, take this part. So what is actually cutting? CH3COOH cut. What is left? RNR, alright, connected to this remaining part. What is remaining part? COCH3. What is the name of this compound? It's called, nitrogen contain 2 alkyl group. So it's called NN dialkyl. NN dialkyl ethanamide or amide. Generally amide. NN dialkyl amide. What is CONH is called? Amide. So where is the product, all of you? NN dialkyl acetamide. Yeah, acetamide. Or NN dialkyl amide is there. NN dialkyl amide is anyway not B and D, right? Anyway not B and D because both are amine. During acetylation, we will get what? Amide. So NN dialkyl acetamide or NN dialkyl simply amide. We can say option A because they said clearly it's what? Acetylation. Acetylation, okay, generally we can say even amide also possible. Acetylation means we are adding acetic anhydride. So acetic anhydride when we using, this term is already clear, ethanamide means acetamide. So let's go with option A. Next, the amines are basic in nature, yes. Hence they form salt with hydrochloric acid. You know, amines are basic in nature because they contain lone pair that can easily donate and take the H plus, right? Which of the following will be insoluble in dilute HCl? Insoluble in dilute HCl means they are asking you which is weak base. Which is a weak base. Tell me all which is a weak base. This is an aromatic amine. Yes, least basic. This is more aromatic ring is there, very least basic. This is aliphatic. This is also aliphatic. So they are asking you which amine is insoluble in dilute HCl mean which is a least basic. Dear all, what is the option A? Option A is aniline. You know, in aniline, the lone pair is not available. It's involved in resonance stabilization. What is B? What is B, my dear? There is 3-phenyl ring. 3-phenyl ring, okay? 3-phenyl ring. See, the nitrogen lone pair is fully involved in resonance. It's not at all ready to donate the lone pair. So let's go with option B is the very least basic. Therefore, it is insoluble in HCl. 48. Primary, secondary, tertiary amine may be separated by. We discussed only one reaction in this chapter to distinguish between primary, secondary, tertiary amine. What is the reaction? Hinsberg reagent. What is Hinsberg reagent? Benzene, sulfonyl chloride. Already we discussed that. Primary amine, how it behave. Secondary amine, how it behave. Tertiary amine do not react. Right. Next one. An organic compound X. An organic compound X was treated with a sodium nitrate. What is sodium nitrate? NaNO2 and HCl. That is diazotization in ice cold. Ice cold means 0 to 5 degree. Bubbles of nitrogen gas were seen coming out. What is the compound X can be? So remember, cold condition, the diazonium salt is given by an aromatic organic compound X was treated with a sodium nitrate and HCl in ice cold condition. Bubbles of nitrogen gas were seen out. So let me take a aliphatic system. Okay, anyway it's a primary amine because diazotization is given by primary amine. Let me take a aliphatic primary amine. For example, RNH2. When we reacted with this reagent, we get what? Rn2 plus Cl minus. We discuss it's very unstable. So immediately it react with which one? Water, form what? ROH, nitrogen and HCl. But if it is an aromatic amine like aniline, that also undergo diazotization, we get diazonium salt. But you know, it is highly stable, it won't give nitrogen gas. So nitrogen gas, if you want to produce, it should be what type amine? Primary aliphatic amine. It should be a primary aliphatic amine should be that. Question number 50, dear all, we are going to 50 question. Among the following, which will have the positive carbylamine test? Come on fast. Carbylamine test is given by primary aliphatic or primary aromatic amine. You know, this is a primary amine. This is secondary. This is tertiary. This is primary. So, which will give? All primary amine can give, okay. So, 1 and 4. Where is that? 1 and 4 can give which one? Question which will give the positive test, okay. So, 1 and 4 are primary. They can give which one? Carbylamine test. Clear all of you? Question number 51. Cyclohexylamine. You know what is cyclohexylamine, right? This is what we call cyclohexylamine. Is stronger base than aniline. Yes, correct, right? Correct. Why cyclohexylamine is more basic than which one? Aniline. We know cyclohexylamine is an aliphatic amine and aniline is an aromatic amine. We know very well why aromatic amines are least basic, because in aniline the lone pair which is involved in resonance, or resonance what we also call conjugation. So where is the answer? Yes, option A, right? In aniline, the electron pair is involved in conjugation. That means resonance. So since aromatic amines, we know they are less basic in nature because the lone pair is involved in resonance. But here the lone pair is not involved in resonance. So easy to available for protonation. Therefore more basic. Question number 52. The strongest base among the following is, which is the strongest base? Check it whether any aliphatic is there or not. This is aromatic, cut it. This is also aromatic, right? Because it's connected to benzene ring. This is also aromatic, connected to benzene ring. This is what? Aliphatic, because nitrogen connected to an alkane chain, right? So dear all, once again I am reminding you, benzene contain all compounds are not aromatic, okay? If nitrogen directly on benzene, then only it's aromatic. What is the last compound? Last compound is benzyl amine, where nitrogen is not on benzene ring. So the lone pair is available for protonation, easily basic. So strongest basic is D. Question number 53. Reduction of, what is the compound? CH3, CH2, NC. What is this? Isocyanide, right? Okay. With hydrogen in presence of nickel or platinum catalyst, what it give? Already discussed in the part 2 session. Cyanide on reduction, we get primary amine. Isocyanide on reduction, we get secondary amine. So what is the product? CH3, CH2, NC become NHCH3, right? It's become secondary amine. Where is the answer? CH3, CH2, NHCH3, option B. Remember all, cyanide on reduction, primary amine. Isocyanide on reduction, secondary amine. Okay, notice. Next one, which of the following is not a primary amine? Not a primary amine. What is meant by primary amine? They basically contain what? NH2 group, right? Okay. For your reference, I am just giving the compound structure. What is meant by tertibutyl? Tertibutyl means one carbon connected to 3-methyl group is called tertibutyl with amine. See, it's primary. Option B is given secbutyl. What is secbutyl? CH3CH2, CHCH3. This is called secbutyl with amine. This is also what? Primary. Option C is given isobutyl. What is isobutyl? You know, this is called isopropyl with one more carbon is called isobutyl amine. That is also primary. What about D? Dimethyl amine. That means 2-methyl group in between amine. See, this is a secondary amine. So, which is not a primary amine? That is option D. Clear all of you? Okay. Next. Which one of the following is aromatic amine? Aromatic amine means the nitrogen should be on benzene ring. See, this is aromatic, right? Because nitrogen on benzene. This is also aromatic, nitrogen on benzene. This is not aromatic because nitrogen not on benzene is aliphatic. So we can say both A and B are aromatic in nature. Clear? What is the IUPAC name of the compound? C2H5 twice NCH3. Let me write. What is C2H5 CH3 CH2? N, one more CH2 CH3 and then one CH3 is there. Okay. Question, write the IUPAC name of this compound. What is IUPAC name? Take the parent chain first all. See, left side 2 carbon, right side 1 carbon, 2 carbon. So 2 carbon is the biggest chain. Let me take this the parent chain. So this is ethyl branch, this is methyl branch. So ethyl or methyl, which one we write first? Ethyl, right? So we can say N-ethyl, N-ethyl, N-methyl, N-ethyl, N-methyl, ethanamine, right? We can call ethanamine, right? Ethanamine. So what is the name? What is the compound? N-ethyl, N-methyl, ethanamine. That is option C. Question 57. Okay, not wasting your time. Just to keep practicing the question, all of you. Next question, carefully listen all. This is a ketone and this is chlorine. What is the function of KCN? KCN convert chlorine into cyanide. So what we get? Cyclohexanone. This one Cl become Cn. Cyanide on reduction. Cyanide on reduction. What Cn become? Cn converted to CH2NH2. Right? Cyanide become primary amine. So where is that product, all of you? I think it's option B, right? Yes. Cn is there. Cn becomes CH2NH2. Clear? Simple reaction. Now, which one of the following reducing agent likely to be the most effective in bringing about the following change? What is this change? It is an amide. An amide converted to amine without any change in carbon. What is the best reagent we discussed? LiAlH4, right? LiAlH4 is the best reagent to convert amide into amine without any change in carbon. Next one. Which is the end product in the following? What is this? Carboxylic acid. Carboxylic acid when treated with the PCl5, what happened? What is the basic function of PCl5? The OH converted to Cl. So we get benzene with COCl called benzoyl chloride. When acid chloride treated with ammonia, what happened? One H, one Cl cut. We get amide. We get benzene with CONH2, benzamide. Benzamide on Hofmann reaction, CO group cut. What we get? Final product is what? Aniline, right? Final product is what? Aniline. So what is the reaction once again, my dear? They given you carboxylic acid when treated with PCl5, SOCl2 and all, the OH part becomes Cl. This is called benzoyl chloride, and treated with ammonia, it's called what? Ammonolysis. We get like ammonolysis, we get which one? Amide. So like it's just like simple. So chlorine and NH hydrogen is removed, like the ammonolysis process. Amide on Hofmann reaction. If it is Hofmann, cut CO group. Finish. So product is what? Aniline. Next, amine that cannot be prepared by Gabriel-Thalamide synthesis. Through Gabriel-Thalamide synthesis, we can't prepare which one? Aromatic amines. So they're asking you, which is an aromatic amine? Which is aromatic amine? Aniline. Methylamine is aliphatic, benzylamine is aliphatic, isobutyl aliphatic. Through Gabriel-Thalamide synthesis, we can't prepare aromatic amine. We can't prepare, therefore, aniline. Which one of the following amide will give ethyl amine on reaction with the sodium hypobromide? What is sodium hypobromide? NaOBr. That is nothing but our NaOH and Br2, Hofmann bromamide, they are asking dear all. So what is the product already given? Ethyl amine. What is ethyl amine? CH3, CH2, NH2. If you want to get ethyl amine through Hofmann, what should be the amide? Propanamide. One carbon should be extra, right? CH3, CH2, CONH2. It should be propanamide. You know the CO group cut, we get this amine. So what is the product? Which one of the amide can be used to get ethyl amine? We can use propanamide, option B. If you start with the propanamide, you get which one? Ethylamine or ethanamine. You know the speciality of Hofmann reaction, one carbon always less in the product. Next, which of the following has highest pKb? Highest pKb means very least basic. Highest pKb means least basic. Come on all, which is least basic? This is what? This is aliphatic. Ammonia is the answer. Ammonia is the answer. Because you know aliphatic amines are more basic than ammonia. Ammonia is least basic. So least basic means highest pKb. Okay, fine. Next one. Most basic species among the following. Which is most basic? You know, this is aromatic. Even this lone pair also can involved in resonance. Aromatic, like aromatic type. Lone pair not available. These are what? Aliphatic. Among these two, which is more? They are all, this is primary, right? Because NH2. What is this? Secondary. Among primary and secondary, basically secondary will be always more basic. Why? Because it contains more alkyl group. More donating group mean more basic. Okay. So option D is the most basic in nature. So whenever they ask most basic mean, first you cut the aromatic, because aromatic amines are least basic. Aromatic amine cut. Among aliphatic were basically more alkyl group, more basic. Next. What is the correct order of the increasing basic strength? Okay, carefully listen all. All are aniline. But you can see here there is a nitro group. You know, nitro group is a withdrawing group. Alkyl groups are donating group. Methoxy, alkoxy is also donating group. And nitro group is a withdrawing group. Okay. We know the general order. Donating group if there, that will be more basic. Right? So, third and fourth one is more basic. Among third and fourth, which is more basic, remember all of you, methoxy group is more donating than methyl group, because you know the oxygen contain what? Lone pair. Methoxy group is more donating, so more basic. So no doubt fourth one is more basic. So either we can cut this one, either A or B. After fourth one, of course, definitely third one, because that is the next donating group. Okay, fine. Next one, we can go with the first one, because that nothing now contain electron withdrawing group. Careful about the last point, my dear. This is a withdrawing group. It is in para position, and here the withdrawing group is in meta position. With respect to the NH2, this is para. With respect to NH, this is meta. Remember all, if the group is present on para position, its effect will be more. So here the nitro group is in para, it acts as a very strong withdrawing group, so that will be the least basic. So second is the least basic, that is only option A. So what are the point here? More the donating, if the donating group present, more basic. Withdrawing group present, least basic. Next, the most basic amine from the following. Dear all, this is aromatic. This is what? Aromatic, aromatic, aromatic. All are aromatic here. All are aromatic. And what is the difference here? Nitro group, withdrawing group. Alkyl group, donating group. Nitro group, withdrawing group. Halogens are withdrawing group. Question, most basic. Most basic means the one with donating group. Which one? Option C. Okay. Next one. Basic strength of different alkyl amine depend upon in aqueous solution is. In gaseous state, we studied in classes like this one. In gaseous state, the order for basicity is tertiary greater than secondary greater than primary, because we consider only plus I effect. More the donating group, more plus I effect, more basic. Therefore, tertiary highest in gaseous. But in aqueous state, we study two cases, my dear. If methyl group the present, the order is secondary, primary, tertiary. If ethyl group present, then secondary, tertiary, primary is the order. There is a reason why in aqueous state the order comes like this, because in aqueous state we have to consider plus I effect, solvation effect, sterific effect all together. So D is the correct answer. In aqueous state, why the order come like this one? We can able to say that in aqueous state we have to consider total 3 state, my dear. Plus I effect, steric effect and solvation effect. Therefore, the order comes like this one. Next one, arrange the following compound in increasing order of basicity. So, this is aliphatic, ammonia, aromatic. Remember all, we have the general order. Aliphatic amines are more basic than ammonia, then only aromatic, right? Okay, then we can able to say like this. If methyl group comes, see, this is one methyl group, this is two methyl group. More the donating group, more basic. So no doubt this is more basic among these two aliphatic. So this is most basic. I think that is only one option, C. So this is most basic, then this one. Then only ammonia, then only aromatic. Okay, very simple. Next one, yes, complete the reaction. What is the final product? Let me start from here. Everyone carefully listen. What is this product? Para-toluidine. Para-toluidine when treated with, okay, let me start here. So, this is what NH2 and CH3. What is mean by AC2O? AC stands for acetate. So, what is AC2O? CH3CO, OCO, CH3. Acetic anhydride is the short form AC2O. Sometimes, you know, during exam, they will mention like this with the pyridine. So, this is what acetic anhydride, this is just elaborated form. What happened? Aniline react with acetic anhydride, that is called acetylation. You will get, take this H and this part, this you remove it. CH3COOH, remove it. So, what is left in the system? CH3 is already there in para, it become NHCOCH3, it become acetanilide. We know amines are very strong ortho-para group, amides are weak ortho-para. So, now they are doing bromination. So, now they are doing bromination. So, where the bromine can go, either ortho or para. But here, para is already occupied by methyl. So, only the allowed place is ortho. So, let me place one bromine on the ortho position. We get one bromine here, already one CH3 is there. Finally, when they treated with the water in presence of acid or base is there, the amide group back to amine. The amide group back to amine. So, we will get Br here, CH3 here. Yes, where is the product, my dear? Check it all. NH2, Br, CH3, that is option C. So, first step is acetylation, then bromination. Bromine, if you add, either it should go to ortho and para. Here, para already CH3 is there. Therefore, I placed on ortho. So, amide on hydrolysis and H plus directly back to amine. Okay. Question number 69. Primary amine react with the benzoyl chloride to give what? Primary amine. Let me take an example. RNH2. Primary amine. Treated with the benzoyl chloride. What is benzoyl chloride? Benzene with the COCl. We studied amines when react with the acid chloride or acid anhydride, we get amides. How we get amide? Very simple reaction. Take one H, take this Cl. HCl cut. Join the remaining. RNH, C double bond O, benzene ring. You're getting RNH, CO, benzene ring. What is this? Amide. You get amide. Which amide? Benzene with amide, what we call? Benzamide, right? Benzamides. Next one. Primary and secondary amine react with acid chloride or acid anhydride to form what? Just to discuss now. It's a primary amine. When reacted with the acid chloride or acid anhydride, what we get? We get amides. Substituted amides, right? We can say, see, these alkyl groups are get substituted, right? That is called substituted amides are formed. Anyway, this is enough. This is enough. Remember, when amines react with acid chloride or acid anhydride, they form what? Amides. Okay, remember, amides. Next one. Which of the following species are involved in the carbylamine test? What is carbylamine test? Take a primary amine reacting with what? Chloroform and alcoholic KOH. What we get? Isocyanide along with the KCl and H2O. This is called what? Foul smell isocyanide test or carbylamine test, right? Question. Which of the following species are involved in this one? See, isocyanide is there or not? Yes. Chloroform is there or not? Yes. COCl2, what is this? Carbonyl chloride is not required here. NaNO2 HCl, not required here. So, what is that? 1 and 2 are possible. 1 and 2 only. Clear all of you? Which of the following, whether you know the reaction, that's a checking one. Next. Which of the following will form isocyanide on reaction with the chloroform and KOH? Remember, isocyanide test or carbylamine test is only given by primary aliphatic or primary aromatic amines. Question. Which of the following will form? So, check it. This is NH, right? It's a secondary. Cut it. This is also secondary. Cut it. This is what primary, yes, it can give. This is what tertiary, it cannot give. Right, carbylamine test or isocyanate test is given by primary, aliphatic or aromatic amines. Next one, which amine among the following will answer positively with the carbylamine test? Again they are asking you which is a primary amine. Primary amine, how can we find? Check NH2 group is there or not. Where is NH2? This is NH, secondary. NH, secondary. NH2, yes, primary. N alone, tertiary. Same, right? Same question. So, which will give carbylamine test mean primary. Primary, they contain NH2 group. 74th question, my dear. Question is, I'm starting. When para-toluidine, what is para-toluidine? You know, aniline and toluene mix is called para-toluidine, right? Para position. Para-toluidine react with the chloroform. What is chloroform? CHCl3 and alcoholic KOH. Then what is the product? You know, this is carbylamine reaction. During carbylamine, NH2 becomes what? NC. That's it. NC, CH3 remain as it is. So what is the product? Where is the product? Where is the product? That is option B, right? Okay. Para-toluidine when react with the carbylamine, it form isocyanate. Question number 75, my dear. The action of nitrous acid. What is nitrous acid? HNO2. That is our diazotization. On an aliphatic primary amine give. Carefully listen on. You know, aliphatic amine, I can write it as RNH2. When it undergo diazotization at a 0 to 5 degree, the NH2 becomes what? Salt N2 plus Cl minus. We know alkyl diazonium salt is highly unstable. So immediately it react with the water in the medium. You know, H2O contain H plus and OH minus. So R combined with OH, you get ROH as the main product. What is this? Alcohol plus H plus Cl minus, you get HCl plus nitrogen gas come out. So overall we are getting alcohol. Where is alcohol? Option C. So when amine react with the primary amine react with the nitrous acid, it end up to alcohol. So alcohol will be the final product. So what is the end product Z in the following reaction? Starting with the ethyl amine. What is ethyl amine? CH3, CH2, NH2. Ethyl amine when reacted with the HNO2. I think we stop the last question from this one. When a aliphatic amine react with the nitrous acid, it forms salt, but it's unstable. It immediately react with the water, form alcohol. So ethyl amine give you what? Ethanol, CH3, CH2OH. Ethanol when react with the PCl5, you know, OH converted to Cl, CH3, CH2Cl. What happened when treated with the KCN? You know, cyanide, yes, we get CH3, CH2CN. What is the name of this cyanide? You can say ethyl cyanide. You can call ethyl cyanide. Or in terms, you know, cyanide is also called a nitrile, right? So in terms of nitrile, how can we say 3 carbon total? So it's called propane nitrile. Propane nitrile. So question, what is the final product? We can say option A, propane nitrile. You know, cyanide is also called a nitrile, right? So this is called ethyl cyanide or total 3 carbons, so propane nitrile, right? Question number 77, identify X and Y in the following reaction. Okay, starting with the amide, CH3CH, CH3CONH2 is given. One amide is given. They are performing Hoffman. Hoffman reaction means what? Cut the CO, finish. We get CH3, CH3, NH2, fine. Then this is the compound X. Now they are treated with what? HNO2. What is HNO2? Nitrous acid, my dear. This is aliphatic again. Aliphatic amine when react with the nitrous acid directly write its alcohol. You get CH3, CH, CH3OH, isopropyl alcohol or propan2ol. So where is this product, all of you? I think it's option C, right? CH3, CH, CH3, NH2, CH3, CH, CH3OH, right? That's it. Question 78. Which of the following statement is not true? First, dimethylamine is a stronger base than trimethylamine in aqueous state. In aqueous state, we studied if methyl present, secondary, primary, tertiary is the order. Yes, this is secondary, correct. Secondary amine show carbylamine reaction. No carbylamine reaction only given by primary amine. So option B is the Correct answer, right? Question, which is the statement is not true. Secondary amine show carbylamine. No, only primary amine. Nitrogen gas is evolved when ethyl amine is treated with nitrous acid. Yes, we discussed. Primary amine can show carbylamine. Correct. Option B. Which of the following amine does not react with Hinsberg? We know Hinsberg reagent, if you treat it with an amine, there is no reaction, mean it should be a tertiary amine. Which is a tertiary amine? Option C. Tertiary amine easy to find. N, right? So dear all, once again, NH2 if there, primary. NH alone, secondary. N alone, tertiary. That's it. So tertiary amine do not react with the Hinsberg. This is primary, this is secondary. Only tertiary do not react. Electrophilic substitution of aniline with the bromine water. Yes. We know aniline is a very strong ortho-para directing group. If you directly add bromine water, the bromine go to all of its ortho and para position. So it becomes 1, 2, 3. 3 position. What is this position? We can say 2, 4, 6 tribromoaniline. 2, 4, 6 tribromoaniline form. Remember, aniline is a very strong ortho-para directing group. When it reacts with the bromine water directly, it's reacted to give 2, 4, 6 tribromoaniline. Amino group is ortho-para directing for electrophilic substitution, yes. But on nitration, the major product is meta-nitroaniline. We know very well. Aniline is very strong ortho-para. What is the nitration process? Nitration process, we are using concentrated HNO3 and concentrated H2SO4. That is a very strong acidic medium. So here what happened? When aniline contact with an acid, it immediately form a salt. What is a salt? Benzene with the NH3 plus. What is benzene with the NH3 plus is called anilinium ion. Anilinium ion. Aniline is ortho-para directing group, but anilinium ion is a meta-directing group. Therefore, you are getting you may study the process like this one. When aniline on nitration, directly, you will get 3 products. You get para product around 51%, meta around 47%, and ortho around 2%. So why aniline is actually an ortho-para directing group, so it should give only para and ortho. Why it's giving meta product around 47%? Because aniline react with the acidic medium form anilinium ion. It is a meta directing group. Therefore, you're getting meta product. So where is the answer is this one. Aniline gets protonated. Protonated means taking H plus with a strong acid to give anilinium ion, which is meta directing. No doubt option A is the correct answer. Next, how aniline can be converted by efficient procedure to mononitro derivative? We studied the procedure like this one. Aniline is a very strong ortho-para directing group, very strong. So we want to make it weak first. If you directly add nitration, we studied the para, meta, ortho, all of them get. We want to get mononitro, that means only one nitro. What is the procedure? First, we will protect the NH2 group by the process called which one? Acetylation. During acetylation, we are using, pyridine. Pyridine is a base which is used to neutralize the acid byproduct. So what is the product when aniline undergo acetylation? We get NHCOCH3. We get acetanilide. We get what? Acetanilide. Dear all, during acetylation, amines are converted to amide. Amide is weak ortho-para. Now we can do nitration. Nitration means what? Nitration means we can use concentrated HNO3 and concentrated H2SO4. So nitro group can go to para and ortho, where para is the major one, right? So we can write like this one, NHCOCH3 and one nitro group here. Now we want to get our amine back. They said mononitro derivatives of aniline. So how to get this amine back to amide? So amide back to amine, we can use acid or base, we can use it. We get the amine back. It will become NH2 and nitro group. So they're asking, in order to prepare mononitroaniline, what are the procedure we have to do it? Check it all. Nitration directly, don't do that. Aniline with a dimethyl, nothing. Aniline to acetanilide, then ortho para nitroacetanilide, then hydrolyzed. Yes. Option C. First aniline on acetylation become acetanilide. Then I told you if you add nitro, it go to ortho and para, where para is the major product. Then hydrolysis, acid or base you treated, you get the product. Next one, identify the reagent for the following conversion. This is benzene diazonium chloride. If you want to get iodobenzene, what is the reagent we used? Warm Ki. So first one we can use the warm Ki. Okay, so either option A or C. This already ready, right? Not I2. That's also option C is the correct one. Yes, that's it. Warm Ki. Benzene diazonium chloride to cyanide. What we can use is CuCN. That's a Sandmeyer reaction. Diazonium salt, how you can convert into OH, that we can use warm water. So that's option C only. So diazonium salt is very important here. All many reaction we studied there. Please go and study it. Okay. The structure of product X. What is this X in this reaction? Let us check it all. Remember, there is a methyl group, nitro group, and aminone. What they are treating first NaNO2 and HCl, which means what? Diazotization. What happened on diazotization? The NH2 become N2Cl salt. CH3NO2 acetes. What is the function of H3PO2 hypophosphorus acid? It convert the diazonium salt completely to benzene. Means overall this group vanish. So you will get the product benzene with CH3 and NO2 alone. Where is that? Option A. What is the first process? First process diazotization, NH2 become N2Cl. Second step, if you treat it with H3PO2 and water, the diazonium salt completely vanish. So that benzene and the CH3NO2 will be there. Fill in the blanks with appropriate choice. Okay, let us go for the reaction, everyone. See that carefully. Aniline directly if you do bromine water. We discuss. Aniline on which directly if you add bromine water, you get 2,4,6 tribromoaniline. Aniline on diazotization. NH2 become N2Cl. Bromine acetes. What happened if you treat it with a Cu2Cl2? That is our Sandmeyer reaction. N2Cl become chlorobenzene. Yes, we get Cl and bromine. Where it is? That's clear, very clear from option B itself. Only 3 bromine is getting from here, right? N2Cl and chlorine. Finish all? Simple reaction? Yes. Question number 89 for you. What is the end product here? What is C6H6? C6H6 is nothing but benzene. What happened? Benzene on nitration. You will get nitrobenzene. What happened? Nitro group on reduction with the tin and HCl become aniline. What happened? Aniline on diazotization, it become diazonium salt, N2Cl. What happened? Diazonium to salt treated with H3PO2 and water, it become benzene. Finish. So what is the final product, my dear? Benzene is the final product. So study the reaction. Okay, study the reaction. Next one. The product D, see this all giving you some idea about the reactions. Okay. So again, aniline on aqueous bromine, you get NH2, Br. Diazotization, NH2 become N2Cl, Br. What is HBF4? You know, HBF4 contain 2 ion, H plus and BF4 minus. What happened? H plus go with the Cl, you get the salt first. What is the salt? N2 plus BF4 minus. This will come here and Br. Finally, when you directly heat, when the salt directly heat, that becomes fluorobenzene. Fluorine come to this one, Br. Right? So what is the product? 2,4,6 tribromofluorobenzene, that is option A. What is the reaction here? Aniline on bromine water, you will get 2,4,6 tribromoaniline. Diazotization, it becomes salt. Salt on HBF4, the Cl and H go to the N2, BF4 comes, on directly heat become fluorobenzene. That is our Bals-Schiemann reaction. Next, identify X, Y, Z. What is this? Aniline on what? You get these 3 bromine. We know that it is bromine with aqueous. This bromine water. Where is that? That is only one option D. Then on what you get N2Cl, NH2 how become N2Cl, NaNO2 and HCl diazotization. Yes. And how you can completely cut this N2Cl, we can use H3PO2 along with H2O or ethanol also fine. Okay, D, correct. Next one, what is the correct IUPAC name of the following amine? CH2 double bond, CH single bond, CH2 single bond, NH single bond, CH3. Right, start all of you. Where is the biggest chain on nitrogen? This side. So prop is the parent chain, so this is the branch. Amine is there, double bond is there. Amine having more priority, so 1, 2, 3. We can start N-methyl. N-methyl, total 3 carbon, therefore proper second position alkene. So 2 in first position amine, so 1 amine. N-methyl, proper 2 in 1 amine. Where is that? N-methyl, proper 2 in 1 amine, right? Option D. Question number 90. Among the following, which is the strongest base in aqueous medium? They are all this here nitrogen connected to benzene ring, aromatic. Aromatic is very least basic. Cut it. This is aliphatic, aliphatic, aliphatic. You know, in aqueous medium, if methyl group comes, the order secondary, primary, tertiary. Where is secondary? This is secondary. Option C, more basic. So first you classify them as aliphatic, ammonia and aromatic. Aliphatic is the most basic, no doubt. In aqueous medium, in 2 special cases we studied. Here methyl present, so secondary, primary, tertiary is the order. So secondary C. Question strongest base. Okay. Question 91. What is the correct increasing order of the basic strength? Start. All are aniline, all are aromatic. You know, nitro group is a withdrawing group. Alkyl groups are donating group. Who can increase the basicity? Donating group. So no doubt, third one is most basic. So third one most basic, yes, this one. Then this, and last one is with withdrawing group. So more donating group, more basic, more withdrawing group, least basic. Finish. Next one. The gas evolved when methylamine. What is methylamine? CH3NH2 with nitrous acid, HNO2. Many times we discussed. When primary aliphatic amine react with the HNO2, that becomes salt. What is a salt? N2 plus Cl minus. We know alkyl diazonium salt is highly unstable, that is because no resonance. So immediately react with the water. You know, water contain H plus and OH. So CH3 combined with OH, you get CH3OH. It become alcohol. The nitrogen gas come out plus along with this HNCl, HCl. So what is the gas here? Nitrogen gas. So the gas evolved when methylamine react with the nitrous acid is which one? Nitrogen gas, dear all. Next one. In the nitration of benzene, using a mixture of concentrated H2SO4 and HNO3, the species which initiate the reaction is, you know, benzene when we treated with the concentrated HNO3 and concentrated H2SO4, they are asking you which group come to the benzene. You know, nitro group. Where you studied this reaction as general electrophilic substitution. Electrophiles are coming with a positive charge, dear all. If it is chlorination, Cl plus is the upcoming group. Nitration mean NO2 plus. Alkylation mean the alkyl group. Acylation mean the acyl group. All are electrophile. They are coming with a positive charge. So where is NO? During nitration, which is the upcoming group? NO2 plus. Okay, NO2 plus. Question number 94. Which of the following compound will not undergo azo coupling reaction with the benzene diazonium chloride? We studied 2 reactions in coupling reaction. Hope you remember. Benzene diazonium chloride we treated with the phenol and the aniline. We get orange dye and yellow dye. So the question is, remember all of it, this is the point. If it want to undergo coupling reaction, we have already benzene diazonium chloride. Benzene diazonium chloride is there. The another group should be contain a electron donating group. Okay, benzene diazonium chloride when react with a aromatic system with the EDG, electron donating group, undergo coupling reaction faster. So they are asking which of the following compound will not undergo coupling reaction. That means there is a withdrawing group. Which is a withdrawing group? Nitro. Nitro group is a withdrawing. You know, aniline mean NH2. Phenol mean OH. Anisole mean OCH3 on benzene. Nitro is NO2. We know nitro group is the withdrawing group. Here these all are what? Donating group. If there is a donating group is coupling with the diazonium salt, yes, it undergo reaction faster. Which do not undergo coupling reaction mean there is a withdrawing group. Just keep in mind. So that is nitrobenzene. Which of the following should be most volatile? Dear all, most volatile mean they are easy to vaporize. Most volatile means they having least boiling point. Lesser the boiling point, easy to vaporize. So you know the boiling point order, we know primary greater than secondary greater than tertiary is the order of boiling point. So which one is the least boiling point? Tertiary. Where is tertiary? Where is tertiary? This is primary, this is secondary, this is hydrocarbon, and this is what? Which one? Second one. This is tertiary. Tertiary cannot form any hydrogen bond, so therefore it is least. Which one? Basic one we can least boiling point. So third one is tertiary. So most volatile means what? They are having least boiling point. The least boiling point is given by the amine, tertiary amine. Okay. So second one. Next one, when aniline react with, okay, write the reaction fast. When aniline react with NaNO2 and HCl at 0 to 5 degree, what is the product form? What is this? Diazonium salt, right? What happened? Benzene becomes, this becomes NH2 become N2Cl. What is this compound called? Benzene diazonium chloride. Benzene diazonium chloride. Don't convert into alcohol, okay, because it's already stable compound, so it's not normal water, it won't react. So when aniline react with NaNO2 HCl, it give diazonium salt. Next, a unpleasant smelling carbylamine. We know carbylamine test having, that's isocyanide having foul smell. Unpleasant smelling carbylamine are formed by heating alkali and chloroform with. We know a primary amine. The carbylamine test is given by what? Primary aliphatic or primary aromatic amine. When primary aliphatic or primary aromatic amine, when treated with alkali like NaOH and chloroform, give you what? Foul smell isocyanide. So what is that? Any amine, not possible. Any aliphatic amine, not possible. Any aromatic amine, not possible. It should be any primary amine. Means any primary means it can be primary aromatic or primary aliphatic. Okay. Next. For the preparation of para-nitroiodobenzene. Okay. Para-nitroiodobenzene. From para-nitroaniline. What is the best method? What is the overall conversion here? Nitro is already there. We want to convert NH2 to iodine. What is that? First we have to treat it with what? NaNO2 and HCl. We get diazonium salt. NH2 become N2Cl. Later on treated with which one? Ki, warm Ki. So iodine come to benzene. So which is the best method, my dear? Tell me, Ki where it is NaNO2 HCl followed by K, right? Option A, right? Yes, CuCN, I2 and can use it. Iodine if you want to get, always Ki we have to use it. Second last question, 99. C3H9N. We discussed this one question another way. C3H9N. Let me write the possible structure. Okay, 3 carbon with an amine. 3 carbon I can draw like an amine like this one. Propanamine. Now I can place the amine on the second carbon. This is called propan2 amine. I'm saying the possible structure. Okay. This is primary. Now this is secondary possible. N-methyl ethanamine. One more is possible. CH3N, CH3, CH3, a tert methyl trimethylamine. Question, this amine, these are the possible structure for this amine. Question, this amine represent, yes, primary amine possible, these are primary. Secondary amine possible, this is secondary. Tertiary amine possible. All of this, yes, we can go with option D. So, with the C3H9N formula, all the 3 amines are possible. These are the 4 amines. Here all our last question, 100th question. What is the number of isomeric primary amines obtained from? How many primary amines are possible with the formula? C4H11N, overall 4 carbon. How many primary amines are possible? What is primary amine? They should contain NH2 group. Check it out. First one is CH3, CH2, 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 NH2. This is one possible. This is butanamine, right? Let me place NH2 on the second carbon. So I can write CH3, CH2, CH, NH2, CH3. Butan 2 amine. This is primary amine. Now let me change the carbon chain. Let me write CH3, CH, CH3, CH2, NH2. This is one another. Now let me make the another carbon chain here. CH3, C, CH3, CH3, NH2. Possible, right? So I think around 4 structures I got it. Can you please cross check it? Any other structure is possible or not? 4 carbon chain, this is the maximum possible. 1 on first position, second position, finish. Now 1 carbon I made it as a branch. Now 2 carbon made it like a branch system, like that. So I think this is the maximum structure possible. So with the primary amine, we have total 4 structures are possible. So here, my dear, around 100 MCQs we discussed, 100 MCQ we discussed about the amine chapter. I think all the chapter, almost all the chapter, all the concepts, including basicity, reactions, distinguishing test, everything we discussed in this 100 MCQ. Hope you are confident in this one. Those who are not confident in the chapter, that's only because of this theory. Theory you make it, theory you catch it with you. Theory you have to hold in your mind properly and just apply, okay, where I studied. Whenever I'm discussing this question, when I'm showing the question, pause the video and just find the answer. Then you just cross check with the explanation. Hope you clear everything and do your best, all of you. Wish you all the very best for your upcoming examination. All the best.